A warm welcome to all of you for this World Ocean Day Symposium. We are fortunate to have Professor
Dr. Francis, whether you got disconnected?
Yeah, looks like he got disconnected.
He has re-entered. He has re-entered.
I'm sorry, I lost the connection. So, good morning, all of you, and a warm welcome to this World Ocean Day Symposium. United Nations celebrate 8th June of every year as the World Ocean Day to commemorate or celebrate the theme of ocean sciences. We need to reach out to the society. We need to protect the ocean environment for the well-being of our planet Earth. So this year we are fortunate to have Professor Ravindra Kulkarni, Honorable Pro-Vice Chancellor of University of Mumbai to inaugurate the session, and Dr. Satish Chenoy, MOES Chair Professor and former Director of Indian National Center for Ocean Information Services in COIS, Hyderabad. Dr. Meena Kumari, former chairperson of National Biodiversity Board and former Deputy Director General of Fisheries in Indian Council for Agriculture Research. And we also have several speakers from different parts of the country, experts in their field. Actually, we plan to have this symposium with two themes. One is oceans and climate. Another is fisheries and ocean. So we know that the ocean plays an important role in our everyday life through regulating the climate or giving us the resources to live. So we thought the importance of ocean can be discussed in this symposium during this full day, one-day event. So I welcome all of you to the event, and I will now request Professor Ravindra Kulkarni, Honorable Pro-Vice Chancellor of University of Mumbai, to inaugurate the event. We know that Professor Kulkarni is a very well-known academician and a researcher in the field of chemical technology. I don't think I need to introduce Professor Kulkarni to any of you. He's a famous figure. He is a very able administrator. He has been a guiding factor for CEMAS for more than a year now. It was his brainchild to establish this center. So I welcome Professor Kulkarni to deliver the inaugural address.
Thank you, Professor Francis. Let me extend a warm invitation to Professor Chenoy, Professor Meena Kumari. So it was really a matter of pleasure that you have joined us, and thanks for accepting our invitation. Dr. Satish Chenoy, in fact, was one of the pioneers who was involved in conceptualizing the overall Center of Excellence in Marine Studies, and he constantly supported the overall planning as well as visualization of this center itself. And we are glad for the form of Professor Francis. We have our full-time director, who himself is a great scientist in the same area of studies. Thanks to Dr. Meena Kumari for joining this program and promoting our moral. And I hope we will continue support the overall promotion of activities connected to ocean itself. Worldwide, we are coming across the significance, importance, and of ocean, not only as a part of bioeconomy, but even as a part of sustaining life's resources. And at the same time, it does support various studies, including the biodiversity itself. United Nations has also declared this current decade, 2020 to 2030, as a decade of oceans, so as to have more stress, so as to have more studies in reference to ocean, as well as promoting the sustainable development in reference to healthy marine environment. In fact, as a center of excellence in marine studies with University of Mumbai, it's our definitely priority, and as well as we are required to take up collective efforts in the field of oceanographic research across the globe, so as to meet the targets of United Nations Sustainable Development Goal. As we understand, oceans play an important role in the existence of life on Earth. Oceans regulate the weather and climate of the Earth. They create the right ecosystem for the marine life and provide living and non-living resources for the survival of humankind, and acts as the cheapest mode of transport of goods. Even today, like we across Mumbai, we do find several ports across which the major transport of the goods is taking place. And with vision of Sagarmala of Government of India, in fact, the mode of transport and trade, as well as commerce across seaports, is going to be enhanced at a very large scale. And of course, as a human being, connected to Konkan region, we are well aware of the traditional fishing activity, right from as a normal activity, and going to high-tech industries itself. About the growth of industries connected to various dimensions of marine system, we need to see that our marine environment is really well supported. The ecosystem is well preserved, because it appears that because of global warming and climate change, as well as because of heavy marine pollution in an uncontrolled manner. So definitely it is providing great threat on the marine ecosystem, and it's our duty to take up the right steps in order to have a right sustainability, as well as right preservation of the marine ecosystem. At this stage, probably we'd like to talk about the establishment of Center of Excellence in Marine Studies. In fact, University of Mumbai, having connected with a seashore of 720 kilometers, naturally the establishment of Center of Excellence in Marine Studies becomes a natural phenomena. Of course, we took long time to establish, but now better late than never. We have now started with regular academic as well as the research activities connected with marine studies in a multi-dimensional manner. So we expect the Center of Excellence in Marine Studies to undertake the academic as well as research on underwater domain awareness, UDA, probably deep ocean mining, right support to the naval studies, as well as security, naval security phenomena, definitely promoting the various diverse aspects of blue economy. And while doing all this research, we need to undertake the right and right lookout towards environment and disaster management in reference to sustainable development of marine ecosystem itself. So, as such, like whether it's the marine study center, we'd like to have it in a we'd like to grow it in a multidisciplinary mode, because we have started MSc in marine studies as well as MA and MCom in maritime studies as well. And probably in future, like we are beginning with the PhD research center as well. So let us hope with support of all experts who are involved deeply in marine studies in reference to diverse aspects, we will be able to push the Center of Excellence in Marine Studies so as to meet the goals, the objectives of the blue economy given by the Government of India. With that, probably the University of Mumbai would be able to serve the right purpose and objectives of the connected with Sagarmala vision given by Government of India. So I extend my sincere thanks to all who have joined this program. And so the program is already inaugurated, and we will have a, of course, keynote lecture by Dr. Satish Chenoy, followed by Dr. Bina Kumari, and really we have 7 speakers who are leading experts in different branches of oceanography, climate, and fisheries. So probably through that we will have a right emanating recommendations, not only with reference to growth of Center of Excellence in Marine Study, but at the same time emanating recommendations with reference to the preservation of ecosystem of the ocean on account of this ocean day. Thank you.
Thank you, Professor Kulkarni, for your encouraging words and inaugurating the session. I'm sure that this one-day symposium will lead us to a good discussion and get enough recommendations for us to, focus our goals also. So, may I now request Dr. Satish Chenoy to deliver the inaugural address. I wish to introduce him to the attendees. I'm sure that most of you are known Dr. Chenoy. He's one of the finest oceanographers in the world, and he has steered the Indian National Center for Ocean Information Services to the most reputed operational oceanography center in the world. In fact, he brought several recognition from UN to INCOIS, starting with the recognition as regional tsunami warning service provider for the Indian Ocean region. INCOIS has got that reputation. It's one along with Indonesia and Australia, is recognized as the regional tsunami warning service provider. And he conceptualized the International Training Center for Ocean Operational Oceanography, ITCO-Ocean, which is now again recognized by UNESCO as the Category 2 training center under IOD program. So if we look at his research career, he has been working on physical oceanography problems, and he established the ADCP array all along the coastal waters, which gave immense data for us to understand the coastal circulation. Earlier, we were having only bits and pieces of data, but his visionary approach to establish about 17 such ADCPs to measure the currents has changed the understanding of coastal circulation. He also is one of the architects of the Deep Ocean Mission program of Government of India, and he has led several observational campaigns he is a recipient of prestigious MOES award for the ocean science and technology. Also, he is a fellow of elected fellow of two national academies, Indian Academy of Science and National Academy of Science, India, and also the Telangana Science Academy. So we are fortunate to have Dr. Chenoy today to start the symposium. In fact, he told me that he has another lecture in the afternoon. So it's good that we put his lecture in the morning itself so that we get a good idea of oceans and climate and its implications on society. He's the right person to talk about it because he steered the INCOIS, which is basically a service organization with a very good background in research. So I request Dr. Chenoy to deliver the plenary lecture on that topic. Thank you.
Thank you. Thank you, Dr. Francis. Let me thank Professor Suhas Petnekar, Honorable Vice Chancellor of Mumbai University, and Professor Kulkarni, Honorable Pro Vice Chancellor of the University, and the staff of the CEMAS, especially its director, Dr. Francis, for inviting me to be part of this one-day symposium and also to deliver a lecture on this occasion. As we know that the influence of ocean is increasing in our day-to-day life. Whether we like it or not, it is increasing, because earlier we thought that ocean gives only the fish for food, and recreational purposes we go to the beach. But as we understand more on the ocean, its influence is vast, especially even on the weather and the climate, which affects our life, day-to-day life in various ways. In fact, the Canada's International Center for Ocean Development and the Ocean Institute of Canada, they proposed this idea of Ocean Day at the UN Conference on Environment and Development in Rio de Janeiro. But it took a long time for the United Nations General Assembly to accept this concept and declare 8th June as Ocean Day to be celebrated all over the world every year. The main purpose of Ocean Day is to bring more awareness among the public about the oceans, and also to concentrate on resolving the issues of oceans and save the ocean waters. So the concern of ocean is keep growing, as Professor Kulkarni rightly mentioned. Now the UN General Assembly has declared the decade during 2021 to 2030 as the decade of ocean science for sustainability. So that is the importance now being attached to the oceans, because there are reasons for that. So in today's talk, I will look at some of the issues. Of course, my talk is not going to be exhaustive about any aspect of the ocean. So I will just try to concentrate on the ocean climate and its implications on the society in some form. Again, I must confess that it is not going to be a complete process. I hope you can see my slides.
Yes, sir, we can see it.
Okay. So the topic is ocean climate change and the impact on society. As we all know that the annual greenhouse gas index is keep on increasing. As you can see from this graph, right now the carbon dioxide concentration has crossed more than 400 ppm, and if you add other greenhouse gases like methane and other gases, CFL, etc., that goes much beyond more than close to 500 now, and it keeps on increasing. So it is somewhat 508 ppm of carbon dioxide. That's the total impact of all the greenhouse gases right now in the atmosphere. And this is not a good scenario for us. And scientists have deciphered what is the kind of warming effect, because when these greenhouse gases stay in the atmosphere, what happens is these greenhouse gases are transparent for the shortwave radiation, that radiation which comes from the sun to us, and it comes back, comes to the earth, it heats the earth, and then the earth at a lower temperature radiates back in the long waves. And this long wave gets trapped because of these greenhouse gases. They are opaque to these long waves, and it doesn't allow the long wave radiation to escape from the Earth's atmosphere. So that radiation stays within the Earth's atmosphere, and it warms all parts of the Earth, atmosphere, oceans, then the cryosphere, all parts of the Earth it warms. So if you decipher due to the natural processes, if only the natural process like changes in the solar radiation and volcanic activity, how the temperature of the Earth would have changed. That's what the bottom curve shows us, that green patch and the green curve shows. And if you add the natural process plus the human and human induced processes like emissions increase and the trapping of long wave radiation, etc., etc., you see that that curve is very close to the observed. So there is no doubt that this is not a natural process. It is solely because of that increase is because of the human induced processes. And if you see the excess heat, because every year we are putting excess heat into the Earth system, and out of that, the calculations show that only 1% stays in the atmosphere, and 3% goes in the land or soil, and 3% goes in glacier melt, and 93% of this total excess heat which has gone to the Earth system, that goes into the oceans. That is what IPCC AR5 reported, and that report still remains valid. These proportions are almost same even during the AR6 also. So with this 1% excess heat which has gone in the atmosphere is making us so uncomfortable. We always complain that this year the warming is more, or rains are very different, etc., etc. So if oceans are not absorbing that 93% of the heat, our fate would have been even much worse. So ocean, we should thank the oceans that it is absorbing almost all the heat and keeping that heat with the ocean. But that also is not a good scenario. Maybe right now we are getting some solace from that, but how long the oceans can hold on to this kind of excess heat? And because of this excess heat which is going into the oceans, the ocean heat content is keep on increasing, and that has been proved or shown beyond the doubt that the ocean heat content has increased by about nearly 20 into 10 to power 22 joules. 10 to power 22 means if you write 20 and another 22 zeros to that, so that is the kind of heat which has been getting stored within within the 700 meter or the upper 700 meter, then plus more heat is getting stored in the deeper ocean also. But this figure is only for the 700 meter layer of the ocean. And what happens when this kind of heat is being stored in the ocean? The obvious effect is that the sea level or the water level will increase. One thing which is happening because of this excess heat which is going into the ocean is that it heats the water. So when you heat the water expands. That is called thermal expansion. And the heat which affects the glaciers and the land and Iceland or Antarctic, it will start melting that ice. So if you look at the observations from sea level gauges or tide gauges which are established all around the world, if you take all that data and plot this trend, that is what it looks like. And also since 1994 onwards, we also, or 93 onwards, we have the data from satellites. The satellite altimeter also provides the sea level data, and they are more or less similar numbers they are giving. And the fact is that the sea level all along the coast is increasing. Earlier, it was about 1.4 millimeter per year, the global average. And that has now turned since 2000 or 2006, for the 2006-2015 period, the sea level increase is something like 3.6 millimeter per year. And with the observations what we have now, we are able to decipher the thermal expansion, how much sea level is increasing due to the thermal expansion, and what is the increase or what is the trend due to the added water. The added water means this added water comes from the glacier melt, maybe from our Himalayas, Alps, and those kind of glaciers. Plus, but mostly that water is coming from the melt of Greenland and Antarctic ice sheets, which are on the continent. They are melting and adding water to the ocean. So if you look at that melt water or the added water is causing more sea level rise than the thermal expansion is causing. Of course, that also is not ignorable quantity what the sea level is caused by the thermal expansion. So if you add both the added water, the sea level rise due to the extra water which is coming into the oceans, plus what is the sea level rise due to the thermal expansion, you will see the curve which is shown up here, and that coincides with the observations. So these calculations are believable and more reasonable. But if you look at the sea level rise, it is not that the sea level is increasing uniformly all over the world, and there are regional differences. Some parts, for example, this Western Pacific, etc., the sea level rise is much more, and some parts it is less. But if you look at the average, it is about 3.6 millimeter per year is the increase right now. So after a few centuries or a few decades, a lot of our land will get inundated due to this sea level rise. And in the Indian Ocean, if you look at the Andaman Sea and Eastern Bay of Bengal region, that has higher rates of sea level rise than compared to the western side. But it's a fact that the sea level is rising all over the North Indian Ocean. So somebody at our institute had analyzed this sea level data, which was available from various major ports like Aden, Karachi, Mumbai, Kochi, Visakhapatnam, Diamond Harbour, etc. And that was for the period before 2000. And the sea level rise along the Indian coast was estimated as about 1.3 to 1.75, except for Diamond Harbour, which showed a larger rate, which is 5.74. There is a reason for that difference at the Diamond Harbor, because there the land also is going down, or there's a land subsidence which is going down, that also is appearing in this sea level trend. So to get the exact trend of sea level, we should know how much the land is subsiding or emerging, going up, and otherwise what is the sea level rise. But on an average, we can safely take that before 2000 or late 90s, the sea level along the Indian coast was rising at a rate of about 1.7 millimeter per year. But later, some of the colleagues at NIO, Unnikrishnan and his co-authors, they analyzed some of this tide gauge data as well as the altimeter data for the recent years, from after 2000, from the altimeter, and also they have looked at the tide gauges, and they came out with a new figure that right now the sea level along the Indian coast is increasing at a rate of 3.2 millimeter per year. But remember that this estimate is from the altimeter, so the errors could be larger. So it is very essential that the analysis of sea level change using tide gauge data at the Indian coast is essential to determine the actual increase in the sea level. So otherwise, we still do not have a accurate figure. But I also believe that the sea level must be increasing either at 3.2 millimeter per year or somewhere between 1.7 millimeter per year, what we saw from the tide gauges earlier, and this 3.2 millimeter per year. So something like it must be more than 2 millimeter per year increase of sea level is happening all along the Indian coast, which is not a good sign for the people who are living on the coast. So what are the implications? One is the oceans are warming and the sea level is increasing. Of course, I need not tell if the sea level increases, what is going to happen. The low-lying areas on the coast is going to get inundated, and we are going to lose more and more land to the sea than what we have right now. One of the implication is that and I need not tell about this also because all of you are experiencing even this summer also that our annual mean surface temperature is going up and up. So this is the sort of projection made by the assessment of climate change over Indian region by IITM Pune scientists, that the temperature or the annual mean surface temperature is going to go up. So if somebody is thinking that the next year will be better, we may not have a harsh summer, don't think that we are going to have more and more harsh summers. And this figure shows how much that will increase under different RCPs or the projected pathways. If we emit more carbon dioxide, we may end up in RCP 8.5 or RCP 85, and that will be very disastrous for all of us. And it also shows that the heat waves, number of heat waves, for example, this year, the number of heat waves and the intensity of the heat waves are very high. Even some parts of Maharashtra as well as the entire North India, even Telangana and southern parts of our country experience these heat waves. So heat waves frequency is increasing at the rate of 0.23 per decade. Per decade, about 0.23 number of heat waves are increasing, and the number of days of heat wave also, there is an increase by about 1.3 days per decade. And the maximum duration, or when a heat wave occurs, how long it will stay, that also is increasing. So whichever way the heat wave, one is the number of heat waves are going to increase, and the duration of the heat wave is going to increase, and the maximum duration or how long that heat wave can stay, that period also is increasing. And these heat waves have a strong connection with the sea surface temperature in the equatorial Indian Ocean. So look at the connections. We thought that oceans may not be involved in these heat waves in North India, in Madhya Pradesh or Rajasthan, what is happening. But there are established connections. It shows that when the SST in the equatorial Indian or eastern equatorial Indian Ocean, eastern equatorial Indian Ocean is the area which is close to Indonesian islands and the Malacca Strait, etc. So those areas, when the SST is going high, the chances of heat wave in the central India also are higher, and that clearly comes out from some of these analysis. Similarly, if we look at the mean rainfall during the 1950s to 2015, there is a decrease. We are getting less and less monsoonal rainfall. Of course, this is all India average, which I am showing here. And there is a decrease from 1950 to 2015 data, what has been analyzed. But the projections show that the future projections show that the monsoon will get stronger, and the monsoon rainfall will become more intense and will affect larger areas, mainly due to increase in atmospheric moisture. One of the reasons which has been suspected for this decrease in the rainfall during the last half a century or since 1950 is that the difference between, because the oceans are also getting warmed and the land also is warmed. As you see from that cartoon, we all must have studied in our geography classes in the high school that because in the summer, in the northern summer, the land gets heated up, and that produces a low pressure system over the land, and that sets up these monsoonal winds. Comparatively, the ocean is cooler than the land that during the summer time. But because the ocean has also increased during the past several decades because of the climate change, the gradient between this land and ocean has reduced. So that reduction in the gradient must have led to the lesser precipitation during this 1950 to 2015. But the future projections from the assessment of climate change over the Indian region is that in future the monsoonal rainfall will increase and it will affect more and more areas. But the onset dates are likely to be early or not to change. So the present onset date, which has been taken as an average, it is 1st June. So either it could, the monsoon will start at the same time on 1st June, or maybe slightly earlier, like this year monsoon onset occurred on 27th of May. So something like that might happen. Otherwise, there is no much difference in the annual precipitation. But the issue is that we are getting more and more extreme rainfall events. So if you observe the rains, even in Mumbai, you must have seen that it is not that during that 4-month monsoon period from June to September, we are not getting uniform rainfall. Some days you will see that there is intense rain, and that brings the entire city to the standstill, the flooding and heavy rainfall. So this is called the intense rainfall or extreme events. So either you will have a large spell of no rain or a drought condition, or you will have intense rainfall events. And during 1950 to 2015, definitely the intense or the extreme events, either the drought condition or the flood, the extreme rainfall condition has increased, and it is going up and up. And the projections also says that it is quite likely that it will rise. So this rise is due to an increasing variability of low-level monsoon westerlies over Arabian Sea, and again Arabian Sea sea surface temperature or SST is supposed to be driving this intense rainfall events which are occurring over the central India and other locations. So again, you can see that there is a connection between the oceans and the intense rainfall events, which we all are experiencing our life during this monsoon season. And also there is a threefold increase in extreme rain events over central India during 1950 to 2015. So this monsoon is no more going to be the uniform supply of rainwater, or it will rain. It may not rain uniformly. When it will rain like what we say cats and dogs. And if it doesn't rain, it will be like an intense summer. We will feel very uncomfortable during that period. There is a reduction in if you look at the data from 1900s or before that, from 1850 onwards, you can see that the number of cyclones which are forming over the North Indian Ocean has decreased, or there is a slight decrease in their numbers. But of late, or from 2000 onwards, there is an apparent increase in the stronger cyclones, or extremely severe cyclonic storms are increasing. And we have experienced that these days, whenever the cyclone occurs, they are extremely severe, and they bring much more damage to our day-to-day life, as well as to the coastal regions. So the climate model simulations project a rise in this severe cyclones intensity and tropical cyclones precipitation intensity in the North Indian Ocean basin. So in future, we can expect that we may have fewer cyclones, but whichever cyclone what is occurring, that may be more intense, more severe, and the damages that will cause could be much higher. So if you come look at the oceans have several importance to our life. Ocean contains most of the living space, because oceans covers more than 71% of the earth, and ocean has 80% of Earth's living organisms are living in the oceans, and only 20% of us, including man, we are living on the land. And almost half of the oxygen we breathe is produced by the ocean plants called the phytoplanktons. And the fish ocean provides, earlier estimate was about 4.2 billion people survive with this 15% of their annual protein from the fish, which has been caught from the oceans. And 90% of the world trade is carried across the ocean rather than over the land or air, and holds an estimated 80% of Earth's mineral resources. So whichever way you look, the oceans have a larger impact and larger importance for in our lives. So the issue is that as the carbon dioxide gets dissolved in the ocean, the additional carbon dioxide gets dissolved in the ocean, it will increase its acidity, because carbon dioxide, like soda, it's a carbonated drink, which is produced by dissolving the carbon dioxide in that drink. Similarly, the carbon dioxide, additional carbon dioxide, will get dissolved in the ocean, and the changes in temperature and the salinity because of the warming, And because of that, the solubility and chemical equilibrium of the gases in the ocean, that will change. And the changes in temperature and salinity will lead to the changes in circulation, supply of carbon and nutrients from below the top surface of the ocean, and ventilation of oxygen waters. Because if you have more and more fresher water because of higher precipitation on the ocean surface, the mixing will be slow, and that will prevent the ventilation of deeper waters. And that stratification will affect the marine productivity in three ways, because the mixing between surface and deeper waters will be slowed down, and length of the growing season it will affect for the fisheries, and the general environmental conditions itself will get changed, making the life of the inhabitants of the ocean more and more troublesome. And there are, though there are no many measurements are available about the pH change of the ocean, whatever are available observations, they clearly indicate that the pH of the ocean is decreasing, or the pH is going down and down, leading to the acidification of the ocean. So this is a major concern for the scientists and policymakers, that what will happen if the entire ocean becomes more acidic. Right now, it is neutral, but it is showing the trends that it might become acidic. So ocean acidification might take place soon. And because of the depletion of oxygen and a slow mixing process which is happening, the oxygen is running out of the oceans. There is no ocean oxygen supply from the surface. Especially, you can see that our North Indian Ocean is one of the marked area of very low oxygen content, and the further lowering of those oxygen will affect our marine life in this region, and that will affect our day-to-day life, because if the marine life gets affected, our fisheries will get affected in huge quantities, and we will have difficulty in catching the fish from this area. And the projections show that in all scenarios, whether it is scenario 2.6 or 4.5 or 8.5 or whatever it is, the oxygen depletion is or the deoxygenation is going to continue. So the future is not very bright for the oxygen. And either due to the oxygen depletion or warming, whatever it is, one of the publication which I have seen, maybe Dr. Minakumari will talk further on the fisheries, which shows that the oil sardine and the mackerel, which was earlier seen only along the southwest coast or the Kerala coast or parts of Karnataka coast, are now seen even up to the Mumbai coast, or even on the east coast of India up to Visakhapatnam. So why this habitat change is happening, either because of the warming of the ocean waters or because of the depletion of the oxygen, we need to find out that. Maybe Dr. Minakumari will tell us more about that. So the coastal region especially, it's a fragile coastal ecosystem with a large community around, because most of the population, a high rate of population is living on the coast. If you look at our Indian population, nearly 30% of the population of India is living on the coast, and our mega cities or metropolis cities like Mumbai, Calcutta, Chennai, all these are on the coast, and other cities like Visakhapatnam, then Cochin, several cities are also on the coast itself. So high rates of population growth, development of industries takes place, trade and commerce, all these are taking place on the coast, and it will affect nearly 2/3 of the world's population, because of the large number of cities located on the coast. and high biological productivity of these waters, of the coastal waters, wealth of the species and generic diversity, and fluvial discharge. All this is happening in this area, and this really a fragile ecosystem which might get affected because of this climate change, and there are signs of its effect because of the climate change. So considering the importance of the ocean and the coastal regions, UN declared the UN Decade of Ocean Science for Sustainable Development with a vision for a decade, or this decade, that is 2021 to 2030, is the decade of the ocean, or decade of ocean science for sustainable development. And the vision of the decade is develop scientific knowledge, build infrastructure, and foster partnership for sustainable and healthy ocean. At this occasion, I am really appreciate Mumbai University for establishing this center, and I would request Dr. Francis as well as Professor Kulkarni to project this as one of India's contribution to this decade, the establishment of a new center, the Center of Excellence in Maritime Studies at Mumbai University, as one of the Indian contribution to the towards the increasing the awareness of or the contributing towards ocean science for sustainable development of the oceans. At the end of this decade, it is expected that there should be several social outcomes. That is because of the increased awareness of the ocean. We will have a clean ocean, because pollution, especially the plastic pollution, is one of the major theme of the ocean decade. A lot more research and efforts are being put into reduce the plastic pollution, or getting dumping the plastic in the oceans, so that the once the pollution is reduced, it will be a healthy and resilient ocean. And we should be able to predict the ocean. Even now also we are able to predict to a certain extent. In fact, INCOIS does that day-to-day prediction of the ocean, but we should be able to predict it more accurately in a better fashion at the end of this decade, so that it will be a safe ocean. We will be able to predict the ocean. So for the fishermen, they can, or anybody who is venturing out at the sea, will have a clear knowledge of the ocean, and they will be able to prepare for their safety at the ocean. And it will be a sustainable and productive ocean. The kind of science that will create during this decade will guide us towards how to harness the ocean resources, especially the living resources as well as the non-living resources, without damaging the oceans. Like the bird extracts that honey from the flower without damaging the flower. That is the best example of a sustainable coexistence. Similarly, we should be able to coexist with the oceans. You make use of the ocean resources, but without creating any damages to these oceans. And also we'll have more transparency and access to more data from the oceans collected by various countries. So unless there are immediate and deep emission reductions across all sectors, right now we are standing at somewhere 1.5 degrees centigrade warming compared to the 1950s or 1900s. It is keep on increasing. So unless there are immediate and deep emissions reductions across all sectors, this 1.5 degree will soon breach, and the global temperature will keep on increasing. So the assessment report which has been published recently, it says that unless global greenhouse gas emissions peak before 2025, that's another couple of years, and then reduced by 43% by 2030, that is another less than a decade, and methane is reduced by 34% by 2030, we will not be able to limit within this 1.5 degree centigrade temperature. And if that limiting goes again, the peaking of the emission should take place in 2025 and reduction by 27%, then the temperature might go to 2 degrees centigrade. But now everybody is worried whether even we will be able to achieve that and keep this increasing temperature by 2 degrees. Even that 2 degrees is a high, quite high number. So the temperature will stabilize when we reach net zero carbon dioxide. So now the thinking all over the world is that, see, for example, you take the case of India. We cannot be told that, no, you don't use more vehicles, you don't use more energy. Because for the development, these are required. We have to use more energy. We need more industries. We need, and people get wealthier and wealthier, so they will look for more vehicles, etc. But we should make effort that these new efforts will reduce the carbon dioxide emission, or we will compensate for that emission. So that is what is called net zero carbon dioxide. During the Glasgow meeting last year in 2021, many developed countries, they have committed that by 2020, 2050, they will become net zero carbon dioxide emissions. And India cannot afford that, keeping the development goals and keeping the needs of our population. So our government has committed that by 2070, we will also become net zero carbon dioxide, because we are still a developing country, not like other developed countries who has already emitted so much carbon dioxide, and now they are asking others not to emit. That's not acceptable. So we should be given some more time. That's what our government has asked. And by 2070, we are aiming to become carbon neutral. So there are several areas or several sectors and options are available now. For example, demand and services, energy, land use, industry, urban sector, buildings, transport. If we adopt certain standards and certain technologies, we can reduce this carbon dioxide emission, as well as compensate for whatever emissions we make. So the one good news is that many of the countries have achieved a steady decrease in emissions consistent with limiting warming to 2 degrees centigrade. So whether you like or not, the warming of 2 degrees is going to happen. Maybe by 2030 or 2035, our temperatures will be higher by 2 degrees. But many countries have made that effort, and they are slowly decreasing that emissions. And zero emissions targets have been adopted by at least 826 cities and 103 regions. That's a good sign. And the efforts in India also are not far behind. In fact, during the Paris COP in 2015, we have committed that 40% of our fuel for the energy sector will be from from the renewable sources. And with the effort of our government in the promoting solar power and wind power, we have already reached that target of reduction in fossil fuel. So we have cut down on the use of coal. That was the major source of our power sector by 40%. That is 9 years ahead of the target. That is something which we are all proud of, and congratulations to our government that we are doing much more than what we have committed to the world. The other aspect is to become the carbon neutral, we should be able to remove the carbon dioxide from the atmosphere. For that, we have to require to counterbalance hard to eliminate emissions. That is, we have to adopt to the new technologies, and through biological methods like reforestation, soil carbon sequestration, etc. We should encourage and adopt. And new technologies require more research, upfront investment, and proof of concept at larger scales, and essential to achieve at near net zero. And agreed methods for measuring, reporting, and verification required. So when I say that I have reached carbon neutral, there should be standards to measure that, so that the whole world can agree that yes, I have reached that level. So if you look at the second point, through biological methods, that is possible for each of us. We can also plant trees or whatever plantation we do, that those plants will absorb the carbon dioxide, and at least we should desist from removing the trees which are already there. So this is where we can also contribute individually in the reduction of carbon dioxide, or by doing that we can help our country that to become carbon neutral by 2070 through this process. So to sum up, the evidence is clear. The globe is warming. The oceans are getting warmed and warmer and warmer, and it is affecting our day-to-day life through several means, from the fishery production to the weather and day-to-day weather and climate of the region. And the time for action is now. Unless we act now, this will go into a runaway condition, and the tripping point might soon be reached, and it will be a disastrous condition that we may not be able to sustain at all. So thank you very much for your kind attention.
Thank you very much, sir, for this very enlightening lecture. In fact, see, you have touched upon the impacts of climate change, right from sea level change to effects on monsoon, extreme weather, and the impact of carbon dioxide emission, how to mitigate that. So it was a very wonderful experience. I think we have another 10 minutes for interaction. I request participants to raise their questions, if any. We can have a short discussion with Dr. Chenoy. Yeah. So the floor is open for all. You can unmute and speak.
Sir, can I ask a question?
Yes, Dr. Varsha. Yeah.
Yes. Thank you, sir. The presentation was indeed very wonderful. At the same time, a lot of concern in terms of the actions that need to be taken, and also encouraging in terms of that India is, kind of marching ahead in achieving its goal. Nonetheless, I wanted to ask you, sir, on an individual basis or as an institution, how do you think we can contribute? So basically, it's always, one tendency that we have is probably, everything needs to be done by an institute or by the government or by somebody, but not me. So how do you think that this approach could be changed? That is one. And secondly, do you think that we need any psychosocial interventions to bring about the change in attitude of people in looking towards the ocean, or in terms of looking at climate change and global warming per se? Thank you, sir.
Thank you. That's a good question. Yes, I fully agree with you that we cannot expect only the government to do the everything. Of course, government will bring up the policies and may encourage technologies, etc. But as you have rightly pointed out, in India itself, we are about nearly 1.4 billion people here. So if each of us, or at least 50% of us, decide that we will cut down on our energy usage, for example, we can that a individual can do. For example, I can switch off the lights whenever not required. I can switch off the or close the leaking taps, or use lesser water. That will not only save the water, it will also save the energy which has to be spent on pumping that water, extracting the water, etc. Like this, several things can be adopted in our day-to-day life itself. And to protect the ocean, the best thing and the important thing all of us has to do is, please don't use the plastic and throw that plastic somewhere. You may think that you are dumping that plastic in the dustbin, but final destination of all this plastic is the ocean. And you must have seen several videos, etc., how that plastic is affecting the life in the ocean, how those even the mammals, the whales and the sharks, etc., are getting choked because of this plastic. Even on land also, the cows and other animals are getting affected. So if you decide that when we go for a grocery, we carry our own bag individually, we can reduce a lot of plastic. When we go for vegetables, carry our own bag, so that we don't ask that shopkeeper to give the plastic bag. We can refuse to accept. So if we do that, somebody else who is watching us, they also may feel the same, and they will also follow. And as you have mentioned that definitely the awareness and education is required for the society, and all of us can become those educators, and go around and profess about the importance of the dangers of climate change, and what we can do to reduce that. What difference we can make in our life without sacrificing any of our developmental aspirations or our progress in our personal life. We can do many more things. I definitely agree that, and I would like to encourage each one to do something for the environment, for the climate aspects. Thank you.
Thank you, sir.
Yeah, in fact, Dr. S.N. Oja of SAIFI also had a similar question, how to facilitate collective action. So I think Dr. Chenoy answers to that also. Now we have a question from Dr. Rajiv Nigam. So, sir, go ahead.
First of all, Dr. Chenoy, thank you for delivering a wonderful lecture with full of information. I would like to know what is the relative consumption of energy per person comparing India and say Western world like USA. And when we are expecting to reduce the consumption, it will be also per person basis or the area basis. Because if we accept the same criteria in reduction of the energy consumption, developing country like India will be much more badly affected by that.
Yeah, thank you, Nigamji. Nice to hear from you. If you look at the energy consumption per head energy consumption in the US and compare that to India, we are almost 1/5. That is the figure I remember. We are even now also we are consuming much less energy than what a person in US or the developed European countries are consuming. If they are consuming 25 kilowatts of energy, we are consuming just 5 kilowatts. Only issue is our number is more. So if you multiply 5 into 1.4 billion, that is the figure they try to use to tell us. It is like I'll eat lot of food, but a family of 10, I say that no, you also eat only 1 kg of rice, which I am eating myself. Like, so that's not a practical. So the whole politics of this climate change actions and climate change is that this disparity has been imposed. See, I was part of this negotiation group which met recently to negotiate about the finalization of working group 3 report of IPCC. See, now they don't talk about this industrialization. For example, it happened in 1850s. So in all earlier reports, most of the figures are all presented from data from 1850 onwards, which clearly showed that the industrialization and these countries, they contributed much more to these climate change issues than in the recent, of course, recent years also the numbers have gone up because China and India, which has large populations, started developing, etc., etc. But these days they try to downplay that. So if given a chance, they will talk about from 1990 onwards, when these two nations started growing up. And then they say that now you people are emitting more. That kind of a argument comes in, and we shall never agree for that. We say that you did this much more, much before us, and now you should compensate for that more than what we can do. So that is true. We will not be able to match, even if they say that we cut our consumption by 50%, for example. From 25, they may say that I am consuming only 12.5 kilowatt, which I used to consume 25. So I am consuming only 5, and if I had to consume by 50% right now, it is difficult for me. That's why we also say that we will reach that target after 2 decades. You reach that target.
Thank you.
Yeah, we can take one more question. Aditi has raised her hand, so you can go ahead, Aditi.
Thank you, Dr. Francis. Thank you, Chenoy sir, for the excellent lecture. So my question is sort of overlapping on the past 2-3 questions that have been asked. I hope I'm audible.
Yes, yes.
Yeah. So of course, there is this politics of climate change where, first world countries have historically pressurized developing countries into signing pacts or getting into policy making, which is actually not helping a country's development. But looking at the domestic side, since it's Ocean Day, I'll refer to the coastal ocean climates. We have a very large scale of traditional fishermen, indigenous communities who are involved in fishing, who are facing a lot of issues now with both industrialization of fishing as well as with the changing climate. So as both scientists or faculty or say citizens, how can we ensure that they are not sort of robbed of their forms of living, because this is their primary occupation, and with industrial fishing and say deep sea fishing, their entire livelihood, the entire ecosystem is at risk. But the traditional fishing methods do understand how to continue sustainably without harming the environment. So how can the scientific community help in this regard? I'd love to hear your comments on that.
Yeah, as you have rightly mentioned, this climate has become a more of a political issue as well, because the reason is there are several conflicting interests are at play. If you look at our fisheries, of course, Meena will correct me if I am wrong. As far as my understanding goes, we are not harvesting as much fish we are able to harvest. I think we are harvesting something like 3.8 or 3.9 million metric tons per year. That is mainly happening because we have not adopted to industrial technologies for harvesting the fish. But if we go into the industrial kind of and some of the fishery scientists say that we can reach that number to easily up to 4.5 or so. Meena will tell us exactly what that number is. So that means we have maybe another 500,000 or 0.75 million metric tons of fish available, which is out at our sea, which we are unable to. We are not harvesting that every year, which will be definitely will help us in not only feeding our people in earning a lot more foreign exchange from these fisheries. But the issue is that how far we can go for industrialization of the fishing without sacrificing the interests of the traditional fishermen. So that is where the good governance and good policy making and the sustainable development comes in picture. So the scientists can contribute into the sustainable development aspects. For example, with the science knowledge, we can advise the government that okay, this much only is harvestable. Beyond that, if you harvest, you will be killing the juveniles or depleting these resources. And also, we can say that what kind of technologies we can practice in our area, such a way that there is enough fish which is left behind for the traditional fishermen to catch, as well as sufficient quantity or the industry also can sustain. Another aspect is that our traditional fishermen, they don't go very far for fishing because they don't have higher technologies or larger boats with them. So most of them, 80% of them conduct the fishing in the nearby waters, about 50 kilometers or maximum 100 kilometers from the coast. But beyond that, there is a there is a lot of fishery. So can we bring the industrialization of the fishing beyond that area and see that they don't cross over and get into this traditional fishermen's demarcated area of fishing, etc., etc. These are my just some of the thoughts, but there are ways. And if we have to develop, everybody has to develop. We cannot allow only one section of the. It is not a good only one section of the society develops, and every aspect of the society has to be taken up, and that is where the good governance, good policy making comes in picture, and we can give the scientific advices based on the science that the scientists create. Thank you.
Thank you, sir.
Yeah, I think we can take one final question from Radha. You may just introduce yourself and ask the question, and then with that we can close the session also.
Hello. Yeah, this is Radha from Physics Department, and as sir rightly mentioned, it is the time for science beyond boundaries to come together, you know, because when sir rightly mentioned, knowledge of science is important in all this environmental issue and particularly the oceans. And here I would like to, because I could also see in the chat, there was a question which is asked about that, you know, following of traditional methods, and there is a little block from the like fishermen or something to adapt to this. And also, you know, the research is being confined more. The moment you say research, it is taken that it is only confined to high-end higher education or something. So, somehow I look forward that this awareness should also spread to our undergraduate colleges and so on. So in that way, I'm trying to ask, in what way do you think this awareness for not just science teacher or teachers, for our younger people, how can it off? That is my question.
Yeah, thank you very much for that question. Yeah, I fully agree with you that the science should expand its horizons. We can no longer afford to practice science only in the labs and our institutions. There is a growing awareness in the city, in the society, as well as at the government level, that the science is part of the society, and the science should get involved with the societal requirements and societal aspects. So if you look at the present day government funding itself, the government is looking at more of societal applications. So if you submit a proposal or a plan for more of societal applications, the likelihood of getting that proposal funded is much higher than the science which you will do only for your academic interest or understanding alone. So the now the if I also, the second point is not only in India, even the worldwide. Now any proposal which has been considered as a major proposal, which should invariably should have a social scientist also as part of that. Social scientist means the involvement of the society automatically comes in. So the feedback from the society has to be taken in that research, and also the society should be involved in conducting the experiments and testing the results on the society for the societal requirements. So the more and more involvement of society is definitely a must. I'm sure that Dr. Francis will steer this center more involved with the societal requirements, especially because Maharashtra has a long coastline of 700 and more than 700 kilometers, and a large population which is living on the coast, which has their own requirements, which are deeply connected with the happenings in the ocean, and also the fisheries, etc., etc. So definitely it is the thinking is changing now, and science has to interlinked with the societal requirements. That's what I also feel. I hope I answered your question.
Yeah, thank you very much, sir. Yes, in fact, the university has started this center as an interdisciplinary center. We have social scientists, we have economists, and also scientists as part of the center. So we will definitely work in an interdisciplinary way to reach out to the public, to the required community, reach the science to the society. That's our aim. So thank you for that advice. And now I think we will close the inaugural session and move to technical session. Before that, I request Dr. Varsha, our Deputy Director, to propose the vote of thanks. Yeah.
Thank you, Dr. Francis. It's my pleasure, privilege, and honor to do this, propose the vote of thanks. At the outset, let me thank our Honorable Vice Chancellor and Pro Vice Chancellor for being a constant source of support and encouragement. And I don't think without their support and encouragement, we would have seen this webinar today. I also wish to thank our plenary speaker and the chief guest, Dr. Chenoy. Your lecture was extremely engaging, and it is evidenced by the number of questions that have been raised by the participants. It was an engaging lecture, sir, and we look forward to interacting with you further and taking your guidance to take this center to newer heights. Let me also take this opportunity to thank our forthcoming speaker, Dr. Meena Kumari, who is going to speak on fisheries. But ma'am, we are interested in listening to you again on biodiversity, which is your area of expertise. And I wish to thank you in advance for the lecture that you would be delivering next. I take the opportunity to thank all the speakers for their intellectual contributions that is going to happen in this entire day. I wish to propose my thanks to Dr. Nansilan, especially for gracing this occasion. I also extend my thanks to the entire supporting team, which includes the GAD, the General Administrative Department, the Engineering Department, the UCC, the IT Department of the University of Mumbai, and all other players who have enabled us to put forward this webinar in place. The entire staff of CEMAS, also the director, of course, who has steered this particular center and this symposium. I wish to thank each one of you for your valuable contribution in making this webinar come together in place. Last but not the least, let me thank all the participants for their wonderful questions and their active participation, which indicates that the webinar will be surely a success. So I thank each one and all for their presence and their contributions. Thank you once again.
Thank you, Dr. Varsha. And with that, we can close that inaugural session and we will move to the technical session. And the technical session, we have our keynote speaker, Dr. Meena Kumari. I think now Dr. Meena Kumari got introduced to the community already, but I will take a little time to introduce her work. Dr. Meena Kumari is the former chairperson of National Biodiversity Authority of India, and she was also the Deputy Director General of Fisheries of Indian Council of Agriculture Research. Before becoming the Deputy Director General, he was the Director of Central Institute of Fisheries Technology situated in Kochi. Basically, she is a marine biologist, but she is extremely well known in the work related to fisheries, fishing technology, and fisheries resource management. So I request Professor Dr. Meena Kumari to deliver the keynote talk of this session. Over to you, ma'am.
Thank you very much, Dr. Francis. At the outset, I would like to thank the Vice Chancellor of Mumbai University, Dr. Suhash Patlekar, and Dr. Professor Kulkarni, Pro Vice Chancellor, and to you, Dr. Francis, as Director of Center for Excellence of Marine Studies in Mumbai University, and all those who are coordinating this webinar, for just having me to deliver a keynote address at this webinar. I must also say that I have just recovered from my viral fever, so my sound, you have to bear with me. And in between, one or two times, coughings also will be there, so don't bother. I'm fine now. So before just going into the theme, this fisheries management towards sustainability. So Dr. Satish and I has given me a lot of tasks that she will explain, she will do this, she will tell you, and also which has increased my task. What I have prepared is a simple presentation so that the students will definitely understand. And when we think about management, when nothing is done, everything is in plenty, we try to manage things. The second option is everything is collapsed. Now you have to revive. Now you have to manage somehow just to keep it in the condition which is present and which will not deteriorate in the future. So as far as fisheries is concerned, I opt for the this one. It is not in plenty, so that we can just introduce some management measures. So we have already harvested enough from the oceans, and there is a little more remains to be harvested. So in this particular situation, management has got a very relevant, management has got relevance. So now briefly, I would like to share my share my presentation with you. Okay. Is it okay?
Yes, ma'am. We
It
can
is,
see that.
it is visible. So, fisheries management moving towards sustainability. So, in my opinion, first of all, you should listen, or you should know the definition of what is management. Sorry, I think this is moving fast. Management. This management is a technical term which encompasses the sustainable utilization, especially fisheries is concerned, fishery resources in harmony with the environment. Dr. Chenoy talked about environment. I really congratulate Dr. Chenoy for this. A lot of data is been also present, and he was also very particular in emphasizing that you have to be very careful and very careful in retaining the fragile environment as it is. So the environment is also equally important. If you want to manage, the environment has to be protected. And sustainability, the word sustainable utilization was first coined in the Brundtland report. As far as the word was there, but it was as far as UN is concerned, this has got a great importance. Brundtland committee report was presented to the UN Assembly in 1987. That was Norwegian Prime Minister, none other than Dr. Brundtland, who has presented this, and she has coined this word, development that meets with the needs of the present without compromising the ability of the future generations to meet their own needs. We have to meet our own needs, and also without compromising to the future generations. That is, future generations. What we are having now has to be present, or has to be handed over, or has to be taken forward to the for our future generations also. So this is what is meant by sustainable as well as fisheries management is concerned. Even though fisheries has got very two part in it, that is, one is the inland fisheries and marine fisheries. Today I will focus on marine fisheries, because management is very much required, because and inland fisheries has almost plateaued for a long time, and we are expecting few inland fisheries to develop by way of aquaculture. So the sustainable development goals, that is what we are now focusing on. Now, the UN's 17 sustainable development goals, everyone knows about it, starting with no poverty and zero hunger in both fisheries is reflected. And goal number 14 is conserve and sustainable use of the ocean, seas, and marine resources for sustainable development. So that is very clearly mentioned. So we have got no inhibition in just highlighting that the conservation and sustainability of the use of oceans, and there will be infrastructure support and programs, projects, policies which will be supporting this to have the fisheries management in place at the background. So when you look at the world fisheries, the extreme bottom in red is the inland fisheries. You can see it has not increased much. It has been plateauing for such a long time, from 1950s onward. But marine fisheries, it has got a steady increase. And now, for the last, perhaps from late 90s onwards, it is plateauing. Aquaculture is at the increasing trend, but ocean aquaculture is still in the beginning and its infancy. This is what you see in the world fisheries. So now we can see the Indian fisheries. What is the profile of the Indian fisheries? A long coastline, more than 8,000 kilometers, 8,118. That is a official record. Exclusive economic zone. Now there is a proposal to increase the exclusive economic zone also. Along continental shelf and inshore area, almost more than 4,000 fishing villages, and the human component, which depends on fisheries, is more than 4 million people, and active fisher population in this is 1.2 million. In the Sagarmala program, the number has slightly increased. Major fishing harbors 8, minor fishing harbors almost 27, and landing centers are more than 1,551, and a lot of mechanized vessel and motorized vessels which is going into the sea for fishing. So this is where we have to see how much effort is being put into fisheries and fish harvesting. So there is actually what is to be required. What is required, more than what is required, we have crossed the limits. So now how to manage this? That is a problem. Each one of us is responsible for that. So now let us see what is the biodiversity in oceans. Chenoy has very clearly told that 80% of the living organisms, only 20% in the land, but 80% is available in the oceans. So the variety of coastal ecosystems that is harboring many different species, which includes estuaries, lagoons, mangroves, backwaters, salt marshes. When you go to deep sea, the number of species will be coming limited. And the marine habitat play a very significant role in ecological and economic stability of the country. Why? Because these are the areas from wherein we amass what we, that is agriculture. In agriculture production, fisheries production is also there, and this is a place wherein you get the maximum harvest from it. So that this is not harvestable resources which I am mentioning. The biodiversity percentage, there is a brief, and this will really interest you. 451 species of sponges, that is corals, that is soft coral, more than 200 species of corals, more than 2,900 species of crustaceans, 3,370 species of marine mollusks, 200 species of bryozoans, 765 species of echinoderms, 47 species of tunicates, more than 1,300 marine fishes. So this is what exactly, even though there are non-fishery organisms are also being collected and exported, but this is the mainstay of our fish harvest, fishes. Then 26 species of sea snakes, 5 species of sea turtles, 30 species of marine mammals, including dugong, dolphins, whales, and a wide variety of seabirds. This is the biodiversity the ocean harbors. So in the coastal areas, lagoons, near shore areas, in the deep sea, a wide variety of organisms are present. And now coming to the harvest, we talk about agriculture production, and I was telling you about this production from the seas are also included into that. And if you can see, the food grain has increased only 6 times from 1950-51 to till now. It has 6 times increase has been recorded. Pulses 3 times only, oil seed 6 times, cotton 11 times, sugarcane 3 times, sugarcane 7 times, horticulture 3 times, milk 11 times, and fish production 18 times. Just next to egg production. our fish production has increased 18 times, which is a great pride in Indian agriculture production. We are very, very happy to share this, even though it is, I was feeling that it is not managed and all, no, and management is very much required. So this 18 times increase is a very heartening news. And now, where from this capture comes in? It is from the, there are different zones wherein the fish is being caught. Pelagic species, that is in the column of water, 54% is being caught from the pelagic, even now, 54%. Why? Because oil sardines and Indian mackerel, they are pelagic species and they contribute to the maximum in production. That is harvest and landing. And about 26%, even though prawns and all and major export items comes under the demersal variety, and it is only 26%, and 12% from as crustaceans and 6% as mollusks. Both are major contributor is 12%, that is pinnate and non-pinnate prawns, and 6% is by the loligo, sepia and all. No, those are the mollusks which is contributing to the food production. Major resources which we have, even though I was just telling you about a large number of biodiversity, large number of animals present, what contribute to our food basket is two major species, which is the oil sardine and Indian mackerel, then ribbon fishes in the order of landing. I am just telling: Indian mackerel, ribbon fishes, cephalopods, lesser sardines, pinnate shrimps, non-pinnate shrimps. Then some perches also contribute. Then threadfin breams. Then crockers. So this is the in the order of landing or order of contribution to our agriculture production. These are the major species which is harvested. And now, what is the effort which has gone into harvesting all these things? This is a graph which shows. You can see the pink dotted line is the non-motorized boat, which was prevalent at maybe in 1950s. They were the highest number present, but it has got a very steep decline. Very steep decline, which means that now without motor, I don't think, even in the inland waters, without motor, I'm not seeing any boat with the oars and all those. So nobody is now trying to venture into the water or for fish harvest. But mechanized and motorized boats have been increasing, very steep increase. There is no control, nobody has known, but the Central Marine Fisheries Research Institute have undertaken an in-depth study, and they have taken into the maximum sustainable yield, how much we can harvest, how much effort has to go in. So they have produced they have come to a study, and they have come to a number of vessels which has to be which is optimum for our Indian fishing conditions. That is in the lighter shade in the as a bar graph, and the darker shade in red is the present situation. So now you will understand why I am talking about fisheries management is necessary. It is 3 or 4 times more than what is the optimum. If you take in the case of nets, that is trawlers, trawl nets, gill nets, bag netters, purseines and all, no, what is present is much less, but what is now being operated is much at a higher number. Only 19,000 and odd number is recommended as mechanized boats. 72,000, more than 72,000 is presently operating. Maybe very recently, maybe a decade or 2 decades back only, registration itself has started of the fishing vessels. Even now, registration is going on. It is a process of getting registered. Even now, I have a feeling that there are boats which are, when you start giving subsidy and all, no, the non-registered boats were not getting. So they started registering, and now this number is available for us just because of that. So, having said that, mechanized trawlers 3 times more, total mechanized boats 3 to 4 times more. Motorized boats also 3 to 4 times more. So with this condition, we have to manage. Not that every day all the boats are going for fishing, but still, when the fish is available, when it is a good season for fishing, when certain species is available for fishing, some boats go. So with this situation in hand, how to just manage the fisheries? That is what we have to discuss today. And since it is attended by a lot of students, college students, I have just borrowed some pictures from one of my friends. Some cartoon pictures are also in good. So let us see what is the impact of fishing over the years. Over the years, the fish stock has been depleted. It was available in plenty at one time. So the fish species has depleted, and the vendors are also in dilemma. What to do with the available fishes, or what to have to that is in the market, how much it is going to be available. So the practicing of illegal methods for fishing, this was banned before, banned during the British rule in India. That is dynamite fishing, poisoning in the water for fishing, and although this was banned, but even now at some places this is being practiced, maybe stealthily, but it is being practiced. So this is illegal fishing is one reason. And Chenoy was also telling pristine waters, and also no more it is available. The pollution, even though many of the factories situated near the rivers and all, no, the pollutants which is discharged finds its way straight into the sea. The pollutants, chemical poisoning, chemicals which is being thrown, pesticides which is being washed off from the rice fields or maybe paddy fields and all, no? So wherever the agriculture is being done, pesticides are being used. This also finds a way into the sea. And finally, the human beings, anthropogenic activities, beach littering. So all these create not a conducive environment for the fishes to survive. And mangrove deforestation. This is very important because this is the breeding ground for nursery ground for many of the fish species, and either for making into rice fields or making into aquaculture ponds. A lot of mangrove deforestation has taken place, but now by way of a lot of efforts and awareness programs, slowly mangroves are being planted. And this, and maybe last tsunami also has given us a warning that without mangrove, the coastlines are not more safer. So mangrove deforestation is one reason for not having much nursery grounds in the coastal region, and illegal in that is fishing of endangered species and poaching. So whenever there is a law that is Wildlife Act, Wildlife Prevention Act, they have very clearly mentioned that certain of the species cannot be taken away at all, but illegal poaching and illegal fishing for endangered species, this also is one reason for depletion of resources. Another very important, reason is ghost fishing. I will explain what is ghost fishing. Certain fishing nets which is thrown means discarded into the sea, either by way of damaged nets or by way of broken it, that is caught under the under any obstruction in the sea floor. These are being thrown, and this will remain in the sea, since it is the very clear mention was done that don't throw any plastic into the ocean. These nets are being made of plastics only, either polyethylene, polypropylene, or nylon. So this will be thrown into the water, and this will remain fishing, and the fish will not be, fish will just attract scavengers, or it is of no use. It is no economic returns we will get from this. This ghost fishing also is a major reason for depletion of resources. And that there comes the need for fisheries management, because it is not that we have got in plenty so that we can manage. Over exploitation has taken place, and negative impacts by from the ecosystem. So the picture of fishing boats, that is a Viraval fishing harbor in Gujarat. The number of boats you see, you will be amazed. Awesome number, and then you will just wonder how one boat can go into the sea from this whole crowd. And the fishes which is landed, it is since it is India is a mega biodiverse country and it is in tropical region, we have got a lot of species which is coming into the net. It is no targeted fishing for especially in trawling, no targeted fishing. So everything comes into the net, is being collected and being dumped there. Intensity of energy used in fish harvesting. So these many boats going out into the sea, how much Dr. Chenoy was very clearly telling, don't use much fuel. The fossil fuel which is used for taking these boats out into the sea is also a great concern. And just once you catch, it is already, when you take the fish out of water, it is already dead. And how this can be, how this is not a loss to biodiversity. All the biodiversity is being caught and either killed or it is not being used. Whenever it does not fetch a high price, it is just maybe 1 rupee per kg, and also it will be a thrown away price for making fish manure or chicken feed. That is cattle feed and all, not cattle feed, chicken feed and pig feed and all, it is being used. So no much money will be realized from that. So this is where the code of conduct of responsible fisheries comes into picture. Way back, not in the recent days, way back in 1992, if I believe, this has the discussions have been started. 1992 discussions have started that we have to manage fisheries and all. No? So 3 years it has taken, and in 1995 FAO Code of Conduct it is called. There is a code of conduct that it was brought forward by the UN, and then this was discussed and suggested to set an international standard of behavior. Behavior means not only for fishing. So behavior of all people who are engaged in the fisheries sector for following responsible practices with a view to ensuring the effective conservation, management and development of living aquatic resources. And also the ecosystem has to be protected and the biodiversity has to be preserved. So this was the intention of bringing the code into practice. But unfortunately or fortunately, it was a voluntary code. Those who want, they can adopt it and they can follow it. So the Code of Conduct of Responsible Fisheries, this was brought forward in 1995, and the benefits which was clearly mentioned in that was conservation of fisheries for future generations, and which will help fishermen to avoid resource and energy waste. Then that time itself they said that not much energy has to be used, it has to be conserved, biodiversity has to be protected, which will lead to reduced cost and higher returns. Reduced cost, that is investment cost, will be lesser and it will have a higher returns also. So we can look into the background. In 1982, United Nations Convention on the Law of the Sea brought the exclusive rights. That is UN law of concern. Everyone who is connected with the sea knows about it. This is the exclusive rights and responsibilities of the management of resources in the exclusive economic zone to the coastal states. So this is what is now. So in 1992, this Committee on Fisheries in this has recommended the development of a responsible fishery. We have to now manage the fisheries and we have to bring in a code or maybe a few guidelines. It is a code as a guideline for responsible fisheries. In the same year, International Conference on Responsible Fishing held at Mexico highlighted the need for an international code of conduct for responsible fishing. So that is where it was put forth. It was accepted in 1995. And this is a book which is available. It is a FAO publication available in the website also. This code of conduct consists of 5 introductory articles, followed by 7 articles which are more specific in nature, of which 3 articles which I felt it is very important, especially people who are handling fisheries or if we are interested in fisheries. That is Article 6, which talks about the overfishing and excess fishing capacity, which has to be prevented. Article 8 covers responsible fishing operations. Then Article 12, they are mentioned about fisheries research also. So now I will now explain or maybe just elaborate on Article 8. What are the responsible fishing operations which they have suggested? Of which this 8.1, that is the article, contents in the article are duties of all states. What are the duties of coastal states which has to be followed? Then flag state duties, port state duties. 8.4 clearly mentions about the fishing operations, how it has to be conducted. Fishing gear selectivity, energy optimization, protection of aquatic environment, protection of the atmosphere, harbors and landing places for fishing vessels, then abandonment of structures and other materials, like just now I was talking about abandoning fishing nets out into the sea. Then artificial reefs and fish aggregating devices for enhancement of resources. So these are the 11 points which is extensively elaborated in Article 8. In Article 8.4, among that, on fishing operations, how to prohibit, or maybe it is a rule, or maybe you have to voluntarily prohibit the destructive fishing gear practices. If it is a mosquito net which you are using, or if it is a dynamic fishing you are doing, it has to be stopped. Discourage fishing gear and practices which will lead to catch discards. So what will, because definitely there will be catch discards when a trawl net is being operated and used. So what you have to use in or how you have to follow the principles in discouraging catch discards. Then promote fishing gear and practices that increase survival rates of escaping fish. There will be definitely some fish will be escaping. So promote such a gear and practices that increases the survival and rates of escaping fish. Minimize loss of fishing gear. Suppose some obstruction is there and it is by accident something is lost, we cannot stop it, but minimize loss of fishing gear and ghost fishing. I am very glad that very recently I was going through in certain Gulf countries, especially in Oman and all, there are some closed season for about a month or so, wherein divers are engaged to take away the lost gear from the sea. So I don't think in any other country they are doing it, but this is one very good bright example which you can follow. Then this is adopted by the FA. This is adopted by UN in October 31st, 1995, which has again I told you that it has set out principles for international standards, behavior for responsible practices to ensure long-term sustainability for living aquatic resources. Then this was at that point of time, it was a new approach to fisheries, which will help fishing industry in their efforts to make harvesting operations responsible and sustainable. So this is what now you have in hand as Bible. Follow this principle, because since each fishing condition is different to each country, they have asked the countries to adapt it to your this one, and the Central Marine Fisheries Research Institute have made a lot of awareness programs, and they have published this responsible code of conduct in different languages so that each state can read it and understand. So this is something which we have right now in hand. And the first thing in fishing gear operations, there are institutes which have done research, which has made interventions in helping, or maybe in helping the discards can be reduced, and also helping in young ones and juveniles to escape from the nets and all. So I was in Central Institute of Fisheries Technology at that point of time, And we have extensively conducted research and proved also that this following some practices, a lot of fishes can be saved. Juveniles can be saved, young ones can be saved, and unwanted, non-targeted fishes can be discarded. So I will just list out and just briefly tell what are the different mechanisms also. Off-bottom trawl nets. Trawl net is another, they say that it is a detrimental gear. It flows through the bottom, it shatters the bottom, and it depletes the biodiversity of the bottom also. So these off-bottom trawls can be, there is a intervention of bottom trawls to off-bottom trawls, which will not flow deep into the mud, but the bottom dwelling fishes can be caught. Then juvenile fish excluder devices, turtle excluder devices. Turtle, I don't think anybody will go out for as a targeted species, it is not caught. So turtle can be excluded while fishing itself. Then square mesh cordon. This has actually people have tried to adopt it, but even now I don't think that in all states, even though many of the states have tried to distribute free cordons and all, no, but even now it has not been completely accepted. Square mesh cordon, square mesh windows in the belly or in the body of the net, fish eyes, V-form water boats, radial escapement devices, collapsible traps, then selective fishing, especially mesh size in gill nets, then large mesh Percy. So one by one, I'll just try to elaborate to you. This is the best you can use. When you say this detrimental fishing by bottom trawls, the trawls are being, I mean, I just wanted to show you that there are diamond type of meshes which is going into the body of the net. So cordon is the bottom part. Bottom part means that is where the fishes are being amassed for taking out. So at the bag cordon, that is the bag part of the net, if you can put square meshes, the same diamond mesh can be made into square. When it is dragged through water, the diamond meshes have a tendency to close its openings, but the square meshes will keep it open, and many of the fishes, small ones, can just escape through the open meshes. That just a picture which will again show. In a diamond mesh, small fishes will be caught. If it is a square mesh, only large fishes will be retained and the smaller ones can escape. And mosquito nets are being used. Once the mosquito net is thrown, especially in inland waters and all, the mosquito nets are being used. We had a very close interaction with fishermen when we were just popularizing it and all. So they were telling, you stop the production of these small size nets, then we will not use. How is it possible? Because there are different uses for different type mesh sizes. No, in a hatchery and all, no, if you don't have small meshes, all the young ones, how do you collect them and then with it? So it is our own need or our own decision that we will use larger meshes. So this is one thing. And then just to show you what is bycatch, what we have done is the square meshes, which just to prove that no commercial catch will be escaping, or it will not be used, it will not be lost. So we put a cordon cover and a cover over that and showed the fishermen only this much is being escaped and the rest everything is retained in your cordon. And this was when you show the fishermen, everybody will agree, only this much and all, no, but somehow or the other, if the other person is not using it, why should I use? What is escaping from my net will the other person will catch. So this is the tendency which I've been seeing all throughout, and even now extensively the square mesh is not being adapted. So this is one thing, and this is a picture from a cruise which I myself has undertaken. That is a deep sea cruise, large net fish, almost 4 to 6 tons can be caught. If it is a full bag, which is full cordon, which is coming up to 4 to 6 tons can come in that. So huge net. And one catch was Epinophilus diacanthus. Epinephrylus diacanthus is a grouper which can grow up to 1 to 1.5 kilograms. And these sometimes they will find a huge shoal near the coral reefs and all. No? In the muddy bottom, it will appear as shoals and all. No? And this is no the 35 square mesh we were using, and you can see the number of groupers, that is the Epinephrylus species, which is escaped juvenile. So just imagine all these are living and contributing to the commercial fishery. What a economic loss which we are now facing if you are using a smaller mesh. And some of the deep sea prawns also which has escaped. So this is then another bycatch reduction device is the radial. When the meshes are clearly open, the drag of the net will get reduced and the energy consumption also will come down. So we have also proved that about 0.1 to 0.2% oil is saved by using a square mesh cordon. But I think there should be much more awareness programs and much more intense, or maybe it has to come as a rule or something like that for using the square mesh cordon. And now square mesh panel in the body of the net. That also has been tested, and we have also proved that no reduction, not much reduction will take place. Only the young ones in the flow of the water, only young ones will just flow, which will come up, will just escape. That is in the body. And fish eye are small openings which is made in the belly of the troll net, through which the young ones will escape. And selectivity in fishing gear. I have completed the fish eye, and we have proved that young ones of lesser sardines, almost 51%, we showed that it is being escaped and it is just got a chance to survive. Carangids 52%, cyanids 88%. These are all the escapement studies which are done and which is shown to the community. Then fishing gear selectivity 8.5. Section 8.5 is adopt fishing gear and methods which minimize waste and discards. Discards, mostly it happens in the first netting, second netting and all. Now most of the boats will go for multi-day fishing. So in the beginning, the first netting, second netting and all comes now. When it has got smaller ones, young ones and all, the major tendency is to throw back into the sea, because they are expecting much more species, or much more landing will come with more economic returns, and they will not have a space for storage. So they will not even bring these discards to the shore also. So which means that the economic loss which is happening is huge. Then selectivity is the ability to target and capture fish by species. So if the season is for ribbon fish, please use the mesh size of the trawl which is suitable for ribbon fish. Or if it is you are going for if it is going for prawns and all, no, use the nets which is suitable mesh size, or the size or sex or in combination, but that is for traps. And allowing the release of all incidental bycatch, which may include undersized fish, non-targeted fish species encountered during fishing operations. So there are many fishing methods that which will not have any specific mesh size or anything like that. No, whatever they have, no, they use it for all species. So if you use it specific to that, and if you are going for a loligo fishing, use a net which is suitable for that. Now, in selective fishing, most of the selective fishing will happen in gill nets only. Trawl gear, it is a non-selective fishing gear. So gill nets, if you can select the correct mesh size for catching the fish which you want to catch, that is which is the season for a particular species. If it is for small anchovies, there is no reason that you have to have a mesh size of 45 mm, which will be suitable for mackerel. So taking into the season, taking into the species availability, select the mesh in such a way that the correct size, or maybe the young ones, or maybe wanted destruction of the species will not take place. In traps, especially traps and pots and all, no? Fishing trap, again, it is in selective fishing. Only the particular, for a lobster trap, only lobster will enter. And in a fish trap, you target for fishes. But if you have to have a correct size and shape of the entrance, the young ones will not enter. Even if they enter, there is always a chance for just making them or throwing them back into the water, because we collect them in the live condition. In long lines, appropriate hook sizes. There are special hook sizes for tuna, marlins, then swordfishes and all. No? Mostly appropriate hook size are utilized to control the sizes. Then separation of species. Shrimp and fish. Now, when you troll, if you get shrimp and fish, you do it separately. But there is a mechanism of rigging which is suitable for shrimp or which is suitable for fishes. Maybe either reducing the length of the trawl or adjusting the headline. Reducing the length of the trawl will just have targeted fishing of shrimp, but adjusting the headline, it will float and you can target the fishes. Then controlling the towing speed. For the towing speed, if it is less, because prawns or shrimps are not fast swimming fish species, so they will move slow. The towing speed should be slower. And if it is fast swimming fishes, you have to pomfret, carangids and all. So you have to have a towing speed, a slightly higher towing speed for that. Then inclusion of bycatch detection devices, turtle excluder devices, and escape tubes. All these will have implement the selective fishing out in the sea. Then I will just tell you about the turtle excluder devices also, which we have developed and popularized. These are the the traditional fishing trap is made of Palmyra leafstalk fibers, which will just get decayed in water within no time, 7 to 14 days. But we have just given or researched and found out that some of the modern lobster trap is made with welded mesh and MS rod that lasts longer. And retention, that is go and take it back, that is very easy. Suppose the currents are high, even if it is dislocated, you can go and take it back from water. But if it is a Palmyra leafstalk fiber trap which is kept underwater, it just gets lost into the sea. And the turtle excluder device, this is a grid, an iron grid, which will be placed just before the cordon, and it will have an escape chute, which is there is an opening. So through the grid, all the water will be filtered and all the fishes will go in. The huge turtle will come and touch the grid, and slowly through the chute it gets it just swims out. So this was people were very apprehensive whether fishes, just before the cordon you have a big hole, so whether this will act well, or this will give the proper proper decision which we require, which that people have a very highly apprehensive about it. So what happened was, this was proved again. A outer covering was made, and we have shown to the fishermen that this is how it is escaping, and only the turtle is going out and all the fishes are retained in the cordon. So this was required at a time where the WTO, World Trade Organization, has banned the export of prawns from India, just because the people were, because again it is a protected species, you are catching turtle also along with trawling. So turtle excluder device was the need of the day at that point of time, and we have extensively worked and distributed the turtle excluder devices with the help of Marine Export Development Authority. They have funded for distributing free the grids, which has to be incorporated, and they have supported to conduct training programs also. So this is, and we have just shown them 0.24 to 1.4 is the escapement of fishes from that. So which is not a huge economic loss. Some pictures wherein the turtle just swims out of the net. And now large mesh purseine. Purseaning, the traditional belief is that you have to use very small mesh, which can be used for all shoaling fishes. And if the meshes are larger, all the fishes will get killed. And you can imagine the net will is so huge. It is almost 1 ton to 2 tons is one net. And if fishes will get killed into it, know how difficult it will. It will take about a week to take out all the fishes from that. So this was a challenge which we had undertaken, and with repeated experiments and repeated this one also we have suggested. So these are the meshes which you can use, 45 mm for mackerel, which means that all the sardines will go from that. If it is a mackerel only, mackerel shoal only, it will get, because mackerel will fetch a little more money. Sardines will, if it is sardine, you go for 35 mm. All small sardines will escape. 90 to 120 mm if it is a tuna school. So at the time, depending on the season, they have to select. And the first maiden voyage, which was undertaken from the Central Institute of Fisheries Technology with the large mesh purseine, was Karanjit, a school of Karanjit. I still remember one fish was weighing about 2 to 2.5 tons, and all selected fishing. There is no bycatch, no discard, nothing. Very huge catch, which is in the same size, shining Karanjits, which has come out from the sea. So this large mesh purseine is also one option for selective fishing. Then comes the environmental friendly fishing gears. The fishing interventions which I have told, it is all in environment friendly. But just to give a stress, or maybe just to give a focus on that, I will just tell about eco-friendly fishing gears which reduce the impact to the environment. Drag gears, not at all environment friendly, but there is actually, you cannot stop using trawls also. These trawls which cause severe damage to sea bottom, a little above previously they were using flat otter boats. Otter boats are the devices which will keep the mouth of the net open. So if you use a different shape, that is a slightly curved V-shaped otter boats, so it will fly in water, it will not deep flow into water. So this is environment friendly again. It will not go deep into the mud and then flow the mud. It will just fly and rigging also is made in such a way, it will not just flow the mud. Then passing fishing gear, everyone knows that it is giving less impact to the environment. And these are the riggings of the trawls. Riggings of the trawl nets have become lighter, which becomes without chain in the foot rope. Previously for prawn fishing, to tickle the ground, they were using chains. Small chains are rigged. So without chains, slightly heavier bottom, slightly heavier bottom trawl. The foot rope will be rigged with rolling lead sinkers or something like that, and then it is stored, which means lesser impact to the bottom, and we form steel otter boats. So this has been proved very useful. And of course in Kerala, Maharashtra, now everybody is now using the V-form motor boats, because it is drag of the net also will come very much low. Super carbon V-form motor boats, which is much environment friendly. Then energy optimization, 8.5. Passive fishing gear, so everybody cannot go for gill netting. So energy intensive fishing gear, how best we can save energy. And trawling utilizes maximum energy, how best you can use or maybe you can conserve energy in Kerala. Very recently, I have found out there are ring seal is being operated from a traditional vallam like mechanized boats. So previously we have seen it with one engine. Now you won't believe this. Another person has put two engines. I also have put now three engines, up to four engines. They are putting and then going out, because the argument is I can reach the fishing ground faster. So whether that much intensity or intensive fishing is required at this point, so that we have to think about it. Then of course, fish aggregating devices for enhancing the resources from the sea. The fish aggregating devices are being put in the, maybe most probably the sunken cars and all, no, sunken cars or concrete structures, tires, used tires and all, they will be put there, put underwater, especially near shore, so that the coastal fishermen also will get some fishing opportunities. What will happen is this will, after some time, the growth of animals or the biofoulers which is in these materials will attract both feeders as well as breeders. So the breeders will, so again it will become a small fishing ground, and the fishermen will be the fishermen will be just benefited by that. If it is, I mean, some of the purseners, they use floating fats, just because sometimes these schools will come under the fish aggregation devices for taking shelter or shade. So then slowly the fish aggregating device will be taken out of water, and then the fish school is being pursed and caught. Even now in the coastal areas, for catching loligo, people use coconut leaves, so that they will come and lay eggs on that, and even now fish aggregating devices. But I will tell that it is equally, I mean, spoils the eggs also, or maybe people will catch and the eggs also will get spoiled. Then advanced technologies like acoustic fish detection, sonars. Now, not even one boat is there without sonars will not be there, but GPS, global positioning system. So unwanted searching time and loss of energy can be reduced. And remote sensing. In a way, it has paved way. In the early 2000 and all, I was also associated with just finding out the see-truth validation of the predictions which is made by Space Application Center, that is availability of the fishing grounds and all. No? So two pictures from that. Maharashtra coast, they have identified two places which we have carried out fishing, and then found that those two places were just given good catches. And then Gujarat coast, also some of the that is potential fishing zone advisories have proved, or maybe fish tooth validation have done, and then they have proved correct. And of course, so this information after C2 the validation, this has been now the Indian Ocean Center for Ocean Information Services in COIS have taken it out, and now this is a regular advisory. Whoever is interested, they can get it. And I know fishermen, closely know fishermen who are in Gujarat, Maharashtra, they are taking this advisory. This has changed tremendously the face of fishing in India. And this has, of course, more fishers, more money, and everybody is just getting benefited by this information technology. And enhancement, when you talk about enhancement of resources, just if I don't talk about the, okay, enhancement of resources also can be done by way of just introducing some legal measures. Restriction and control over fishing units can be done. Then area and seasonal closures So now there is a fishing ban, which is prevalent throughout the country. So each state will have a fishing ban for almost 45 days, minimum 45 days. And their interventions, protection of nursery grounds like mangroves and all, then promotion of mangroves, coral reefs, promotion of selective fishing gear and practices, installation of artificial reefs. This is just a repetition slide. And regulatory measures also include closed seasons, protected species. Wildlife Act clearly mentions that these species cannot be caught, but still poaching is taken place. Ban on certain destructive fishing gears and methods. Implementation of mesh size regulation. So this can come as a, this has not yet come, but I suggest that the high time this is being implemented in the country. Then minimal legal size. This we have tried, and of course now it is the catch of pomfrets below certain legal size and lobsters. So there will not be any export of for such species which is caught and traded. So this too has been implemented, and use of turtle excluder devices, that is also very important, because otherwise when next time WTO comes and tells you why are you not in turtle excluder devices and we are not going to get any prawns from India, so then again you will think of using turtle excluder devices, especially in the northeast coast. Gahir Mata and all, they are very famous for the nesting ground of olive ridley and marine protected areas. I just want to make a mention on that. Not only in this fishing contention, in other things also, 10% of the land area and 10% of the marine area, it has to be protected area. That is what Ministry of Environment and Forest, and we have gone and given a signed treaty wherein we will implement this. So again, it comes in under the marine, not marine. It is comes under the biodiversity, protection of biodiversity. So protected area. So 10% for implementing the 10% protected areas in the land has already been implemented. Now it is 11 or 11.2. So it is very easy. All the forest areas can be declared as a protected area. But how to implement this in the marine areas? We are struggling for such a long time, and there are wildlife sanctuaries or national park, so many declarations, Kutch region, Andaman and Nicobar areas, Lakshadweep, all these things we have done, but we are struggling. It is not because there is no easy way to implement this. It's our own cooperation has to be there. The current area under marine protected area is only 1.61. Not even 2%. This is another legal measure. If you want, you can enhance the resources. If I don't just mention, I will not tell much about it. But if I don't tell about mariculture, I will be enhancing the resources. I will be just losing my focus on my talk. So mariculture is another option. Aquaculture of the ocean. The farming and husbandry of marine plants and animals in the brackish water and marine environment. That also is a reason, or maybe it can be implemented for enhancing the resources. So now all throughout the world, there is not much high achievement has not been made. 24.7 million tons, but we are much behind. We do 4.4 million tons only we have achieved. And there are many organisms which can be cultured. Most it is dominated by seaweed, and then among food fishes, some of them are food fishes. Then mollusks, especially mussels and oysters, can be cultured. Then mariculture status of India. Yes, it is only 0.4 million metric ton. Finfish is 0.08. Crustacean is 0.3. Mollusk is 0.12. So this is the statistics available for mariculture in India. Now to increase fish production, I think there is a lot of species. That is, a lot of finfish species the breeding techniques has to be perfected and it has to come to our food basket for culture. So this is where research comes to play a greater role into it. Then Dr. Chenoy was very clearly telling about deep sea. There is a lot more is available in deep sea, and maximum sustainable yield, a little more has to be harvested, which will come from the deep sea. Yes, I do agree. But it is going to be energy intensive. What is estimated is 0.63 million tons. The estimated value is almost 7,560 million. So from oceanic tuna, oceanic squid, then tuna-like fishes and mesopelagic fishes. So the estimated potential is huge, but the infrastructure and the effort which we have to input is also huge. So even now, if we are compelling and trying to repeatedly telling the fishermen go to the out in the sea, deeper seas for fishing and all, even now the major fishing is being done within the exclusive zone, extended exclusive zone only. So now for future, of course, the management, I will with all code of conduct for responsible fishing and all, no, management at regional level, because different socio-economic situations prevail in different places. In each coastal region is different. The coastal region which is in Gujarat will be definitely different from West Bengal or Puri or Orissa. So I think regional preferences are regional level interventions are very much required, and I think when it comes to fishing, it is a state subject. So it has to be the interest of the socio-economic interests and the objectives of the people are also have to be taken into consideration. So management can start from there. Then responsible fishing, implementing the responsible fishing repeatedly from 2000, 2010, 2000. We are talking about it, but how far we have implemented, still we have to find out. Then development of a national fishery policy, the draft is already ready and that will come soon, I'm sure. Then management of fish stock. However, I will again tell that it is again management, it is in our hands. Environment cleanliness. If not we, who else will do it? The clean environment, improve the infrastructure facilities. I think the blue economy, Sagarmala program, deep ocean mission, everything is in place. I think there is we are marching towards progress only. So infrastructure facilities, there is no doubt it will come in place. And training for fishermen. It is not that how to fish we have to teach them. There are many other training which the fisherman has to undertake. Because I was talking about catching fish and keeping it in the first come fishes. No, after 7 days, what is the condition of the fishes which is caught in the first day? So you have to use proper icing, proper refrigeration mechanisms on board the vessel. So how you have to secure and keep the fish in a cleaner way in the boat and all. So a lot of even now when you talk about fish training, it is not only for fishing, it is for preserving it for a long time. Everything it is included in that. So training for fishermen. Then bottom up management technique. Bottom up management technique means it has to come from the bottom, from the shore towards the higher ups up in the state and then to the central. Then making a national global aquatic living resources registry that I myself have made. Even now the number of species which is going into coming to the registry is much less only. So making a national global aquatic living resources registry is required, because in biodiversity also, if I talk that this is going to be a much important thing. And now it is our own decision whether you have to take care of resources. It is resources are there and we are there, whether it is to be taken. FAO code of conduct, follow it as a Bible, and who all are have to be involved. Radha was asking, not Radha, yeah, what the students can do. It is not only the fishers, like fish vendors, fisherwomen, technocrats, teachers, catch them at the young stage and then teach them that this is what you don't, not to pollute the environment, don't catch the young ones and all. No, cigarette smoking is injurious to health, everybody knows it. Why don't a caption comes in the caption comes before cinema theater and all? No, protect our biodiversity, don't catch young fishes and all. No, why it is not coming? So which will go immediately go into your head, and then even you ask a small child, he will tell cigarette smoking is injurious to health because it repeatedly comes to you. So that is again teachers, administrators, researchers, processors, which is more concentrating on exports, non-governmental organizations, NGOs, and housewives. We will decide that we will not use young ones, we will not buy. So the landing or maybe trading or everything will come down. So each and every one of you, I just wanted to make it clear that not that tomorrow housewives will stop buying young ones and all, no, juvenile fishes and all. But what I wanted to stress is each one has a responsibility, and we all are to be there. If you want to protect our environment and protect our biodiversity, if you want to manage, especially fisheries. Thank you very much. I once again thank the organizers for giving me this opportunity. Perhaps my throat might have, it was clear, means I would have been much easier for me to talk. But anyway, I think I have given justice to the time which is given to me. Thank you very much once again. Thank you.
Thanks a lot, Dr. Meena Kumari. I'm sorry that we stretched your throat, but I hope this was a very useful session. In fact, you have touched upon the code of conduct, the importance of following it, just like a rule, and other best practices, and how to make the awareness of this biodiversity, particularly in the marine environment. It's a wonderful talk. I'm sure that there will be plenty of questions to you, but we are a little short of time, so we may have to restrict the number of questions. So I will leave the floor open to the questions.
Questions can be sent to me. I can just reply them either by mail or WhatsApp. You can share my number.
Yes, that is one possibility, and people can also.
Now you can definitely, yes.
Yeah.
Please.
Yes. Yeah. So just one quick question from my end, while others are coming up with their questions. So see how difficult or how easy it is for us to ask our fishermen to go to deeper waters for fishing. What are the technical difficulties? Because you said that we are overexploiting our territorial waters. Yeah.
Unless agriculture means we have something to see, what is there to harvest. So in fisheries, it is we don't know what is available there. So we are going out into the sea and harvesting. Whether you can pinpoint and say, in this particular area, in deeper waters, fish is available, they might be. That is where the potential fishing zone advisories have come. There is a special advisory for tuna fishing also. So it is very easy. But otherwise, the searching and whether it is available there, so people will be very much interested to go and fish in where fish is available. He knows in the coastal waters there, or maybe a place where sea mound is there fish is there. So definitely he will close his eyes and go and catch. What happens when a lot of Indian fishermen are caught by the Pakistani coast guards and put in jails and all? No, because fish is available. There is no barrier, physical barrier, which will tell you this is the Pakistan boundary or this is Indian boundary and all. No, fish is available there. He will simply go and catch the fish. And unfortunate people will get caught by the other. And what is happening in Sri Lanka? Sri Lanka again, Sri Lanka has stopped trawling in Gulf of Mannar. India has not stopped. So Indian people, when fish is available, they go and catch it. So this is the main difficulty as far as I am concerned. This we cannot tell them. So or I have 1 hectare agriculture plot. So I can tell them only 1/4 you harvest and the rest you leave. So that is not possible in the conditions when you are harvesting underwater.
We need to increase or improve the technology.
Technology, definitely, yes.
Yeah, to give an indication that, okay, these are the fishing grounds where you can get if you go away from
and
the...
equip the large. I mean, now almost all vessels are large. They can go beyond 2 nautical miles. I'm sorry, before the 2 nautical miles, or maybe beyond EEZ also they can go. Many of the huge vessels also have come. But again, the problem is the availability of the fishes. It has to be pinpointed, and the money which he invests, he has to get in return also. The quality of the fish and the money which he realizes for the fish. It is easier to get prawns from the coastal waters rather than go and harvest tuna, which will cost him, or maybe which will have a economic return lesser than the prawns. So I think there are many reasons. Maybe one by one, if you talk, I can just tell it to you. And there is again very recently, Ministry of Environment and Forest, they also have talked about it, and Ministry of Earth Sciences also have talked about it. That is harvesting krill. Krill is huge resources there. It is available, and it is just a prawn-like creature which can harvest in plenty, tons and tons. But with all the energy input and going there, and what we will get in return, and especially the mercury content, fluoride content in the head of the animal will fetch it a very low price, or we have to find out methods to process it and then market it in a higher price, so that the input which I do will be realized by way of profit margin.
Yeah, there's a lot of scope for research in improving the technology. I'm sure that we have a speaker, Dr. Grinson. He will talk about the remote sensing aspect of fisheries. So we have a question from Aditi. So I think we will quickly take that question and move ahead.
Yeah, thank you, ma'am, for the talk. I have a very practical question. You know how you were mentioning that there are different size meshes which help in fishing different sizes of fish. So now when we're talking about, say, traditional fishermen who may not go out into very open waters, but they are closer to the coastal regions, is it practically possible for these traditional fishermen to actually be able to afford multiple kinds of nets depending on which fish to catch in different seasons? And is there any support from the government to such fishermen, to provide them with nets which will help them, fish sustainably? Because it will become like an added support for them to, ensure that their practices are maintained, and, they don't have to pay from their own pockets because they are not exactly very rich class. So is there any support of that kind?
Two parts. One thing, do you think that all fishermen go out in the sea, they will go with one net?
No, I'm asking.
They have a minimum 8 to 9 nets they are carrying, and they know when prawn ground is there, this is the net I have to use, and when squid is available, this is the net. When ribbon fish is net, now with a longer wing, if ribbon fish is there, they have to make the school aggregate, so it has to have a very long wing. So long wing troll will be available with them. There are 3 or 4 types of designs of net will be available with them. Suppose one net is lost, they have to put another net. So they are already having. So I don't think there should be any support from the government or anything like that. I think all the subsidies have to be Sustainability has to be reduced in just bringing the nets in. And the second thing, I don't think because they know it and then they themselves are practicing it. So my only thing is that the larger measures, but all these nets for that matter, they have the cordon which is 18 mm finally.
I see.
So, for even though in many of the coastal states have made it as a rule that you have to use cordon of square mesh and all, no, I have seen in fishing boats, cordon square mesh is there, but they attach 18 mm because they just don't want to lose anything. So that is the problem. Even there is not subsidy, free distribution of square mesh cordons also has been done.
Okay, okay. I see. And one more question, small question I have is, how does one ensure, following of territorial protected territories, especially in marine areas where there is no such thing as a boundary? How does one understand and enforce it? I think that's like a practical policy implementation problem. But as a layperson, I'm asking, how can it be done?
If it is a mechanized vessel, I think Bharat Electronics Limited, they have worked on this electronic device. Everybody will have this fish, sonar or anything like that in that. No, there is a small equipment which is attached to it, which will give a beep as soon as you cross the territory.
Okay.
Which will so that is there.
Okay.
But what again I have seen among the fishermen, they simply switch off it and then go fish and come. If there is nothing to be seen in the vicinity, that is again, who will do the policing in sea? That is the main problem, which now we see. I think there are mechanisms to understand, or maybe understand or demarcate. This is our territory. We can only fish from this area and all. No. But when fish is available at just 2 inches from my territory, why should I stop? So that is what is actually happening is that.
Okay. Thank you.
Thanks a lot, Dr. Minakumari. And once again, let me thank all the participants for this attending the keynote lecture also. Now we are going to break into two technical sessions, one in the morning and one in the afternoon. Morning session is essentially fisheries and ocean. So Dr. Minakumari will chair the session, and my colleague Brunmai will assist her in chairing the session. We have 3 speakers in the morning session. So I request Dr. Minakumari and Brunmai to conduct the session. Thank you.
Thank you, Director, sir.
Yes, yes. Please keep in mind that we are a bit delayed. So, yeah.
I think, Mrinmai, you can just call upon the speakers for the morning session.
Sure.
You can introduce them also.
Sure. So good afternoon to all the dignitaries, expert speakers, scientists and researchers, those who have joined us today, and dear all students. Myself, Mrinmai Rane, I am a faculty at CEMAS, University of Mumbai. At the outset, first of all, I would like to wish everyone a very happy Oceans Day. Now, it's my proud privilege to introduce our first expert speaker of the first technical session, Dr. Brinson George. Dr. George is a senior principal scientist at Central Marine Fisheries Research Institute, Kochi, since 2018. He presided on deputation as a senior program specialist to South Agriculture Center, Dhaka, since year 2020, and coordinating the Fisheries and Aquaculture program for 8 Southeast Asian countries. Being specialized in fisheries resource management, he has completed the postdoctoral research at Plymouth Marine Laboratory, United Kingdom. He served as an honorary coordinator at CPI Environmental Foundation and is a Juliet Massey Honorary Fellow of World Aquaculture Society. He also worked at the Ministry of Education, Maldives from 2003 to 2004 as a scientist at Central Island Agricultural Research Institute, Port Blair, from 2005 to 2012. Sir's current research focus is on citizen science initiatives to address the water quality using satellite remote sensing and marine biooptics. Dr. George is the recipient of Dr. Rajendra Prasad Puraskar by ICAR and Dr. Hiralal Chaudhary and Dr. Kulkarni Award by ICAR CIFE. I welcome you in this one-day symposium. Dr. Vincent George will be delivering his lecture on application of remote sensing and GIS for the sustainable aquaculture. Over to you, Dr. George.
Thank you, Mrunmai. Thank you for the wonderful introduction. I thank Dr. Francis also for the opportunity given. Hope I am audible and my slides are visible. Is it okay?
Yes, sir, yes.
Okay. It is a great opportunity. I feel like my mentors like Dr. Chenoy, Dr. Meena Kumari, and even the professors who taught me, Dr. Oja, is presenting a talk here. So it was a great opportunity. Thank you for this opportunity, Dr. Francis. When it comes to remote sensing, like we can see, like the history of the remote sensing started with the color of the ocean. You can see in this slide, there are different colors indicated in the ocean. This has got a lot of history with it because previously whaling was a major fishing activity happening throughout the world. That time the whaling captains, particularly in this case, Williams goes by, they indicated that the ocean has got different colors and this color has to do something with the fishing activity. So we can see like that can be the precursor of all the remote sensing and related activities because color of the ocean, which can be sensed by the spectral signature of the ocean, which turned the history of the fisheries and aquaculture sector looking from the bird's eye point of view. Coming to the first scientific steps, like Alistair Hardy in 1923 was using some sensors and he was flying some low altitude aircrafts to see like how the water masses can be identified with the help of the spectral signatures. And you can see like the green brown water, the deep blue water, the green water. There is a book, The Open Sea, The World of Plankton by Alistair Hardy. And in which he is describing that we passed a sharp line separating the green water of the channel from the deep blue water of Atlantic. You can see the frontal zones in the oceans also. When you go for a cruise, Madam was explaining how she went for the different cruises. But in all these cruises, you can see, you can separate the color of the water with the proper frontal line, and there are techniques or classifying mechanisms by which we can do that with the help of ocean color remote sensing. So when it comes to the optical nature of the water bodies, we have case 1 and case 2 water in general. We have open ocean water. Ma'am was telling about the deep sea fisheries. Deep sea fishing happens in the open ocean water, and much of the active fishing happens in the coastal waters. And there are a lot of fishing happening in the inland waters also. All these water bodies are important from the fishing point of view, but it is complex when it comes to the near shore coastal waters and inland waters. Whereas in the open ocean waters, it is the phytoplankton which are the major responsible agents of the color. But in the case of the coastal and inland waters, the total suspended sediments, other dissolved organic matters and things co-vary with phytoplankton, and that influences the optical field. So definitely we should have information from all these waters to really assess the spectral signatures what the remote sensing satellites are capturing. So you can see a simple example here, the water which is slightly greenish in color where phytoplankton dominance is very prevalent, and the water which is slightly muddy in color. Credits to Anish Lotliger from Incois. He gave me this particular slide. So you can see like how the spectral signature is varying in these two optically different waters. So the physical or biooptical properties of the waters has got a close link with the absorption and scattering properties, which is more complex in the case of case 2 waters and less complex in the case of case 1 waters. But if you know the information about this, you can categorically retrieve a lot of information from the satellite remote sensing, which is at the bird's eye point of view. The type of style in which we classify this information is a ternary diagram. This is one example of what we did in Vembanad Lake, and you can see like the optical complexity of this water in different seasons, pre-monsoon, monsoon, and post-monsoon season, where the different components like the phytoplankton, colored dissolved organic matter, but all across the lake is pretty much supported by the detritus, and detritus component is mostly contributing to the ternary diagram or the complexity of the optical nature of this water. So how we can use this bioptical nature of the water using remote sensing? When the sun is the source of the energy, and when the energy is coming into the water, it gets scattered, absorbed, and reflected. Whatever reflection is coming in the form of a spectral signature, it is taken by the satellite remote sensing sensors, and those sensors will give this information. So if you know what is approximately happening at the ground level, based on the information what satellite is providing, we can do much more analysis. This is approximately the scientific explanation of what it can be like. I am sharing the slides with the CEMAS team members. Please use the slides and you can study it further. So based on the optical field, what is generating this information, we can use the sensor-based retrieved information to know what exactly is happening with the optical constituents, what is present in this water. Now, this optical constituents, based on the remote sensing as well as in situ information, we can use it for classifying the different nature of the water bodies, because this nature of the water bodies has got some relation with the distribution or abundance of the fish also. We will be explaining it in the further slides. So it is very important to know the water composition, and the water mass classification can be done for such benefits like we can support the modeling activities. Madam was telling about the potential fishing zone identification. So a modeling component is involved, and we can use this information for that particular component. The different physical processes that is controlling the biology, like the presence of phytoplankton, primary production, all these things can be achieved if you know exact information on the bioptical components, what is present in the water. Now, pure assessment of biogeochemicals. I know that Kunal is taking a class on the carbon cycle, so I am not going much into details on this. But per se, for fisheries and aquaculture also, this information is very important. Further monitoring of water quality. We have come up with an exercise on identifying the waterborne diseases using this bioptical field. It's very important these days because the waterborne diseases are increasing, and for the socio-economic health security of the people, this information is very relevant. And the status of marine ecosystem, if the quality of the water is not good, it can affect the Micronesia, like different critical environment what is seen in the marine ecosystem. There are a lot of natural and man-made hazards, and whenever these hazards are there, monitoring and assessment is very important. And Dr. Chenoy was explaining about climate change and related effects. In all these studies, when we use satellite remote sensing as an aid or a tool, this bioptical or the color of the ocean is going to be playing a major role in identifying all this retrieved information from satellite remote sensing. How it can be used for fisheries now. Fisheries primarily is governed by the physical things, what is happening, because the oceanic food web driven by the primary production, it supports in the recruitment of the fishes, the larval transport and monitoring, particularly harvesting mechanisms like identification of potential fishing zone, how the fishes are moving from one water to other water, the straddling stocks, the transboundary stocks, the critical habitats like coral reefs, seagrass beds and kelp forests, detection of harmful algal blooms and pollution events, detection of oil pollution, and finally coming to the fisheries management and conservation. I'm not going into the climate change aspects much because you have an entirely important session happening in the afternoon. So I will stick to like how the different activities can support in first the physics to the biology. Like the components remains the same. It can be water, it can be chlorophyll generated by the phytoplankton. It can be the total suspended sediments, which is brown in color, the turbidity what is generated. The colored dissolved organic matter, which is the decomposition of the organic matter what is happening. And the downwelling diffuse attenuation coefficient, which is important on the path of the light. All these things contribute to the optical turbidity. If we have a clear information on this, we can develop some observational link between the ocean ecosystem and the physics of the mixed layer. That's very important. So we can have this information and we can link the physics to the biology using satellite remote sensing approach. Next is on coastal zone management. We know the ocean is being polluted with different things. The same information, whether a lot of pollution is happening in a particular point source. If a lot of pollution is happening, it can give way to a lot of organic inputs and can create a eutrophication in that particular water. So again, depending upon the component what is present in the water, I was telling about in the case of lake membrane, detritus is a major component. So seeing the different components varying on seasonal as well as on the pollution basis, we can have better coastal zone management plans in place for managing a water resource. Now coming to the fish, I told primary production is very important. So based on the chlorophyll component, chlorophyll can be assessed because the color can be contributed by the chlorophyll also. If chlorophyll component can be assessed to a greater extent, we can see like the biomass has got some relation with the chlorophyll. And to some extent, like there are simulation models by which we can achieve primary productivity also. There are some satellite remote sensing information available, but we can go for primary production through a lot of other steps, because the biomass and the production per time is totally different physical things. But when it comes to models, we can incorporate a lot of the inputs what is available within the remote sensing platform and assess the primary production, what is happening in the ocean, and how this primary production is helping in the generation of the fish in the coastal waters. Now, Madam was telling where to fish. This is one important mechanism where satellite remote sensing has provided some glimpses. In potential fishing zone, the fishes has got a tendency to aggregate in zones where the frontal zones where the ocean color or temperature related frontal zones are remarkable. For example, tuna-like species, they prefer thermal frontal zones, and whereas all the small pelagics, they prefer the color fronts or chlorophyll-based frontal zones. And INCOIS has come up with a refined technology. Madam was also involved in the technical development. I was doing the same thing in Andaman waters, because Andaman waters is having a better pristine waters where satellite remote sensing signals are much better. So we could help in the refining of this technology, and it is being operationalized for the fishermen, so that the fishermen can go to the right place without going for a lot of scouting. So potential fishing zone is one aid which has come for the rescue of the fishermen when it comes to satellite remote sensing technology. Like this potential fishing zone technology can vary with eddies, rings, meanders. For example, when we were doing our potential fishing zone validation in Andaman Nicobar group of islands, there was a group of islands in which it was very remote, but the fishermen were regularly following the PFSL. Why the fishermen were regularly following the PFSL? It is not because of our technology. The fishermen themselves, they were knowing like there is a fishing ground. That fishing ground was a mesoscale eddy, and that eddy was generating a lot of nutrients, and it was enhancing the productivity, and the fishes used to aggregate in those spaces. So such mesoscale features can become permanent fishing grounds, and fishermen can go to that place, and we can use satellite remote sensing to predict the same fishing grounds, not only because of eddies, but using other features also. Now coming to the validation part or the migration part of the fishes, when it comes to tuna is following a particular migratory pattern, and Simufara along with INCOIS, they have come up with the SATS tuna experiments in which the pop-up sensors have been put in the tuna fishes, which was caught alive, and they have been transferred back into the sea. So their movement is being tracked using satellite remote sensing, which is very useful technology to know what is happening in the straddling stocks. Why there is certain group of fishes seen in a particular location and other locations don't have much fishes. This is a typical example. When it comes to the southwest coast of India, the Kerala Konkan coast, we have small pelagics dominating there. But whereas when it comes to the Saurashtra coast, we have more carnivores dominating in those areas. So the ratio of the planktivores are more in the southwest coast, and the ratio of carnivores are more in the northeast coast. Why? Because, for example, if you take the typical thing, only think of the density. The density of the water is much less from the south. As we move from south to north, the density increases. And the small pelagics, their eggs are having good buoyancy. So they can come up to the surface, and surface is the place where they can have their good feeding environment. But whereas the carnivores, they require some external force to come up. Their eggs are not so buoyant. So you can see like the carnivorous dominant area, the density of the water itself is very high, and the planktivorous dominant area, the density of the water is comparatively less. Then if you look into different other factors also, the carnivores required a prolonged food chain to sustain itself. So you can see like the Saurashtra coast, the productivity sustains for more than 9 months, whether it is southwest monsoon or northeast monsoon, both the time the productivity is pretty good. Whereas in the southwest coast of India, the upwelling derived productivity is the major thing what is driving, and it produces a lot of diatomaceous blooms also during southwest monsoon time, which is favorable for the small pelagics. So you can see like the current patterns and all those things which can be identified using remote sensing can help us in studying the distribution and abundance pattern of fishes. Now coming to ecosystem applications. Coral reefs are one of the most productive ecosystem, and in the recent days, the reefs are facing a lot of challenges like in 1998, 2002, 2005, 2010, 2015, and all the ENSO episodic events, like when the ENSO is very strong in Northern Indian Ocean region, we have an excess thermal energy being pumped into the Northern Indian Ocean. Unlike the Pacific and Atlantic, as you know, they have open ends, open to both the poles. The Northern Indian Ocean remains just like a pond, with the entire Asian continent lying on the northern side of it. It is not having a connection to the northern pole. So excess temperature, what is generated, it is getting transferred to the Northern Indian Ocean, and Indian Ocean gets warmed up. Dr. Chenoy was indicating the warming trends also. This is very dangerous during El Nino years in particular, because the modified altered Walker circulation brings in a lot of atmospheric bridging where thermal energy is pumped with a lag of 4 to 6 months. El Nino happens in December, and after 4 or 6 months, when it is peak summer here, we have additional heat coming into Northern Indian Ocean, which again creates problem for corals, because the bleaching and other related events are happening because of the excess temperature waters getting pumped into Northern Indian Ocean region. So we can use satellite remote sensing to know what extent the bleaching is happening, what extent the reef is thriving. All those information we can get using satellite remote sensing. We could come up with some good examples, and we were instrumental in establishing the reef bleach advisory system with INCOIS, the INCOIS team, and my team in Andaman Nicobar group of islands. We were working together to achieve the reef bleach advisories to a greater extent. We are still refining on the models. Different outputs are coming. At CEMAS also, we are involved in again refining this information and getting better operational advisories also. Now, coming to another critical habitat, mangroves. It is having a lot of role. My own lab matchmate, Dr. Kirti, who is a scientist in National Institute of Oceanography, Goa, she could come up with a wonderful physical experiment where she could prove that the mangroves in Mumbai region is protecting the storm surge to an extent of 52%. So the mangrove bioshield is protecting the storm surge by 52%. And we have an increasing instance of cyclones happening more in the Arabian Sea in the recent past because of the enhanced stratification, what is happening because of the increased thermal inputs, what is coming into this region. So to know the mangrove patches, what is distributed along the coastal waters, we can use different satellite remote sensing applications and different classification performance which can be done. For example, random forest method, maximum livelihood classification, K nearest neighbor classification. Ministry of Environment Forest was very much interested in coming up with a proper database on the entire patches in India. So we have supported them in Kerala as well as Andhra Pradesh. My PhD scholar Pranav is working on this aspect, and we have come up with a beautiful database in which all the entire patches have been surveyed in situ. At the same time, we have initially mapped it using simple Google Earth technique, and then finally with the precision techniques with the support of the in situ data collected. This database is available, and Ministry of Environment and Forest through their organizational mechanism of NCSCM, which is based at Chennai, we are operationalizing it as an ecologically sensitive area mapping. Now, coming to different resources, even sedentary resources, the benthic resources like clams can be mapped properly with proper in situ information as well as satellite remote sensing information. This was more into GIS because Francis asked me to include both remote sensing and GIS techniques. So this is one clam biomass study which we did in Vembanad. This study was particularly interesting because Vembanad Lake, it has got continuous dredging. The dredging is happening because the harbor shipping channel gets shallowed because of the inputs of sediments what is coming into this particular ship channel area. So how the dredging is affecting, how other environmental variables are affecting the distribution of the clam population, we have studied and we have mapped it also for the Vembanad Lake. Now coming to the primary producers, there is a major initiative, Ocean Color Climate Change Initiative by Dr. Shubha Satyendranath, with whom I am working very closely. She is from Plymouth Marine Laboratory, United Kingdom. She has come up with one initiative in which all the different satellite remote sensing sensors in the world, which is producing chlorophyll or ocean color, she is bringing it into one platform, synergizing the different sensors into one platform and giving the data, like plethora of data for the entire users of ocean color. So we can use this data of ocean color for different applications of ours. So she is leading that particular program. Now we are in the process of estimating the primary production. Maybe Kunal will be throwing some lights on it. The models available are having pretty good error percentage. We have tried our own Empower model in CEMAS also. Our interest is like, if we know the primary production, what is happening in the waters, somehow we can reach the secondary and tertiary production also using some trophic coefficients. We are measuring such trophic coefficients by which if we can estimate primary production, we can take it to the next level. It is very important. Madam was telling like there is a lot of fishing fleets in the country in different contexts. But if we have to optimize the fishing fleet, we should have some basic information on primary production, what is happening in the waters, and come up with a proper fleet size optimization, for which we should know the potential harvestable fisheries yield in the Indian Ocean region. So we are trying to come up with the primary production models also. Another important event is the harmful algal bloom events. It is very important from the mariculture point of view, not only from the fisheries point of view. In fisheries, fish kills can happen when harmful algal blooms are occurring. If harmful algal bloom is releasing biotoxin, the biotoxin can create health hazards for the people who are consuming the fish which has taken that particular harmful algal bloom. But if in cage aquaculture sites, harmful algal bloom occurrence happens, it will create a hypoxic condition. I tried to work with Sanjeeva Beliar Singh in INCOIS to come up with an octilic bloom. We are still in discussion with INCOIS to operationalize some of the things. We are working with Plymouth Marine Laboratory and INCOIS and CEMAS together in predicting the blooms more often. Already INCOIS is having a bloom advisory system, but all the general bloom advisories will not be good, and we should not take it for granted for fisheries and aquaculture. The blooms which are really harmful for the fisheries, we have to have a separate prediction mechanism, whether it is biotoxin, because when a bloom is happening, it should not panic the people. People should not shy away from eating the fish. If the people should not consume the fish, we have to come up with the right scientific explanation. That particular bloom is really creating a problem for the fish. Similar for mariculture activities, whether the bloom is happening and in what direction the bloom is moving. If the cages are in and around and the cages can be towed to a place of security, we can avoid the cages from the blooms. Or if the bloom is going to be very detrimental on the cages and we cannot tow it away to nearby spaces, we have to harvest the cages. So such advisories can be generated if we know proper information on mariculture and fisheries based harmful algal blooms. We are in discussion with INCOIS to come up with an operational advisory. So this will be also one advantage we can have if we can have proper remote sense related information on generating the harmful algal bloom technique. Previously, we were using in situ plus satellite remote sensing information, but now we use artificial intelligence, machine learning related image classification techniques for bloom detection also. We were earlier coming with a lot of if and but conditions, but now with image analysis, things are pretty more clear than the earlier if and but conditions. Now, I was telling about the chlorophyll biomass enhancement. We have done a small study on aerosol optical thickness. If you go into your mobile application, your mobile application will tell about the pollution, what is happening in the city. So there is aerosol optical thickness information, what is available from the satellite remote sensing. But sometimes some chlorophyll biomass enhancement is because of the aerosol optical thickness, particularly the dust particles, which is bringing in a lot of nutrients and generating a bloom in a particular area because of the aerosol transferred nutrients. So such studies also have been conducted, and we could see like what could not be explained with other physical mechanisms, what is generating a particular bloom in a location. We could see like some solace can happen if we study aerosol optical thickness, particularly the dust aerosols, and bringing in production in a particular location. So that was also done. Whether these technologies are helpful at the time of disasters, with stratification increasing, more cyclones, more related disasters, more things are happening. We can know this is an example of a Thane cyclone, but the old figure. When Oki cyclone happened, the effort of when the cyclone advisory is coming, the first thing what is coming is a statutory warning. Fishermen should not go to the sea. They are losing their days of fishing. It is to the extent of more than 50%, and in some locations it will be up to the extent of 100%. You can imagine the type of loss. Some people were concerned about the subsistence fishers who are going on daily basis and earning their daily earnings from the fishing. So if cyclones are happening over a stretch of 2 weeks and we are giving a 2 weeks cyclone warning, that much fishing will not happen. But another advantage is like when they are breaking the stratification, they generate some production, and immediately after the cyclone is over, there is a solace that production attributed some distribution enhancement happens in that particular location, and fishermen, they venture to the sea after the cyclone, they come out with good catches. That is also happening. Now coming to mariculture, whether we can identify mariculture sites. Some of the mariculture sites require good idea on the carrying capacity. For example, when we are having molluscan farms who are filter feeders, they require a lot of primary producers in and around the vicinity of the farm. This was a small experiment done in Canada by Professor Trevor Platt, who was my mentor. He done aircraft remote sensing, where you can see like exactly how the filter feeding is happening in the rafts. That information is provided by the remote sensing activity. So when rafts are placed in a particular location, this can be one useful technique. Now, how rich is our coastal waters or ocean with respect to the essential fatty acids? We in South Asia, we generally depend upon cereal-based diets. But a shift from cereal-based diets, it is advised these days because it creates a lot of lifestyle diseases such as diabetics. So fish is a good nutritional supplement because it contains polyunsaturated and highly unsaturated fatty acids. EPA, DHA, and all essential fatty acids, it's available. But how rich is our coastal waters? We can have some assessment on the fatty acid phytoplankton carbon ratio and EPA diatom carbon ratio with the help of satellite remote sensing. Budgetal has indicated this for other oceans, and definitely for Indian Ocean, we can do such experiments. And at CEMAS, we are working with our own biochemists. We have a fatty acid profile of different community structure of different phytoplankton what is available in the waters, and we are trying to relate that with phytoplankton related observation which are taken using satellite remote sensing. So we can assess how rich is our waters with respect to essential fatty acids. Next is like how the blooms are progressing. I told it is very important to know like how the blooms are progressing when a particular incident is happening. This can generate a lot of information. Like I told, when cage mariculture is happening, we can tow away from the cages. If biotoxins are released, we have to tell from which location the fishing has to be stopped. So all such information can be generated if we can have proper information on how the blooms are progressing. Now, one major important application of remote sensing is on ecological provinces. When we have to manage the fisheries from an ecosystem point of view, we should really know like which are the ecological provinces in Indian Ocean. For example, now it is a state subject. Kerala is managing its way, Karnataka on its own way. Madam was telling about the different activities of registration of the fishing vessels, how it is going, and the type of census and related activities, what is happening. But we should have an ecosystem-based management system. For that, the first and foremost thing what is required is ecological provinces, which can be generated with the help of application of remote sensing. We can study the structure and function of marine ecosystem using the spectral signatures, and we can delineate the ecological provinces and manage it on from an ecosystem point of view. This is already published. This study was undertaken by CEMAS when I was working with Professor Trevor Platt. Now, coming to modeling, how it is very helpful. Meena ma'am was suggesting on the management measures. The best management measures is like if we can identify the adult stock, determine the fishing ground. If it is a spawning stock, we can determine the breeding ground. If it is a juvenile stock, we can decide the nursery ground. But the problem is like Indian fisheries, it is consisting of more than 700 species. Madam was selling almost a dozen of gears fishermen are using. Indian fishery never collapsed because it's not because we managed it pretty well. It is because we have good biodiversity. A particular fish is lacking in an area, fisherman automatically will reduce his target towards that particular fishery and he goes for the next one. So there is a time for that particular fishery to come up again. So this sort of automatic management is happening with the fishermen. But if you want to really manage the fishery, we should know like how it's getting distributed. But the problem is like the adult stock of a particular fish, it can overlap with the spawning stock of another fish. So all this ifs and buts are there. But I did a small exercise when I was doing my PhD at the National Institute of Oceanography, where I was trying to see like how best we can integrate the hydrodynamic and related variables along with the fishery information to see like how best we can see like if a particular fish is spawning in a particular location, how the eggs or larvae will be carried along with the hydrodynamics in a region and how they get settled and which areas have to be conserved. So this particular exercise was done, and this was a pioneering study with respect to the identification of essential fish habitats. There are critical habitats. Ma'am was telling groupers and snappers will be seen abundant in the coral reef region. So in this area also, there is pretty prevalent presence of cyanids, and they were getting accumulated more or less near to the reefs and the mangrove areas, which is there in Gulf of Kutch. So we can have scientific decision support systems like this, where we can integrate satellite remote sensing, modeling, and GIS capabilities to manage scientifically all these resources. Now, coming to the next important thing is like watercolor remote sensing on citizen science. I was telling like waterborne diseases, it is really affecting the people. So if you can have watercolor remote sensing along with citizen science, like simple camera images from the mobile phone, that can do wonders. Like we are developing a new monitoring strategy for the Vembanad Lake, in which we have developed a mobile application. The name of the application is Turbo Aqua. It is available in Google Play Store. You can download if you're interested in doing that. And there is an equipment required, a small mini 3D printed Secchi disk, which is again color coded. Our interest is to know the color of the water and the turbidity of the water. And some of these equipments can be having some innate sensors. For example, if you want to know about the temperature, you can have eye button temperature sensors also. So the people can transmit the images, the people can transmit the information on the turbidity, the people can transmit the image, information on the color of the water, and we can map the entire open water body using this information. So it's a simple technique. So once you teach the people, there can be a network of citizen scientists who will be doing such information and giving to us. This can be matched with the high resolution satellite images which are coming with the flood of information coming after the Sentinel different series. We can use all this information for mapping the lakes and open water bodies. So rather than shifting from traditional ship sampling measures, we now developed a small niche of citizen science data. We should have our own scientific data to corroborate, but at the same time, if citizen is coming with, or the crowdsourced data is coming, then it is going to aid us in a large way. So with the digital revolution happening in mobiles, we know that we have in India, we have more access to mobile phone. It is said that 45% of the population is having access to mobile, when only 30% is having access to the toilets. So the problem is like when such problems are there, when the sanitation related issues are there, the water quality related issues are there, such information can pave a great way in developing satellite remote sensing plus modeling based advisories to know about the water quality of a open access water body. These are some of the color images which we have generated from Vembanad with the help of citizen scientists. The different Forel UL color codes are seen here. Now coming to the analysis, the images what we have obtained, we could map the Vembanad Lake, like how it will look like based on the different color information what we got, and we could scientifically corroborate that with our own scientific findings also. It has got a lot of remote sensing applications because long-term water quality monitoring is possible, like from the citizen science data as well as in-situ data and satellite remote sensing data. These three information can be fitted together to generate appropriate model to generate the water quality of the lake. One simple example how this can be used. There was an incident in which the flats were demolished in the Vembanad Lake area because Supreme Court intervened because these flats were constructed in coastal regulation zone areas. So when the flat was demolished, it was told like no civil structure will fall into the water, but you can see like it generated a lot of dust, aerosols, at the same time leachates from the flats. It was followed by a rain. It came into the water. But using our citizen science, we could see like what was the change in the color of the water body and how the leachates were changing. And we did some scientific studies also. It's published in remote sensing, where we could see it with the help of remote sensing, citizen science plus our own scientific data, how the water quality is changing and how it is coming back to its normalcy. So all this information was generated with the help of the study. Our another important aim is to associate these information with the microbial health of the lake. So if we can get this information and if we can fit into epidemiological model, Vembanad Lake is a lake where there is a lot of population density seen around the lake. The population density of Cochin is more than 5,000 people per square kilometer, and when it comes to the different parts of the Vembanad, it is also very heavily densely populated, and it is a CVCA, critically vulnerable coastal area. The people are directly depending on the water as a resource for their daily activities. So when there is an outbreak of a disease like cholera or something which is happening, it is really affecting the working days of the people staying there. So it is approximately to the level of 10 to 15%. Every year they are losing that much of working days because of acute diarrheal diseases. So what we can do is like we can generate advisories based on satellite remote sensing and in situ data on whether there is a possibility of an outbreak of a disease. Operational advisories can be given, and we have developed the model also. At the same time, now the frequency of floods are increasing. If we have the pixels of moisture content and non-moisture content pixels, we can easily see like how the flood is spreading in a locality. So flood mapping, well mapping, sanitation mapping, all these things can be outshoot of this program, and satellite remote sensing is going to play a big role in deciding these advisories. So these are some of the activities, and we have come up with a program called Onward. You can, everybody, whether it is a remote sensing scientist, microbiologist, ecologist, social scientist, epidemiologist, or people who are interested anyway in this areas, you can join Onward. And Onward is a network where we are trying to see like how best we can study the aquatic ecosystem, to study the health of the ecosystem, particularly on waterborne diseases. Interested people can join Onward. You can use the forms to fill yourself to enter into Onward. Most of my studies have been motivated by Professor Trevor Platt, who was my mentor, and his wife, Dr. Shubha Satyendranath. So Professor Platt passed away recently, and in memory of the type of education he has imparted to the global diaspora of scientists, we have established a Trevor Platt Science Foundation, which is offering a lot of capacity building and related information. You can go to the Trevor Foundation website, and if you are interested, you can apply there also. I have been teaching in CEMAS on a virtual basis last year. So I have taken some lectures also. If interested, we can further delve into the areas of opportunities, what is available with different foundations, different groups. So since I was restricted on talking on remote sensing and GIS, I have touched only on those areas, and Meena ma'am's lecture helped me to reduce my own burden because she explained very well on the different aspects of fishing and related things, and I have touched on most of the areas of remote sensing and GIS applications. There is wider scope. It requires a lot of information modeling and related things. We can talk for hours on this basis. I have touched on some of the areas. If you have some questions and queries, we can definitely solve some of them in this platform. Otherwise, you can come back to me. I am ready to answer. I am active in most of the social media platforms. When I am in India, I am happy to interact with you. Thank you.
Thank you so much, Dr. George, for your insightful talk. I request Dr. Binakar Kumari ma'am kindly summarize the session.
Thank you, Dr. Grinson, for the wonderful, because very recently what has happened with the remote sensing, I was also not knowing. So it was a good opportunity for me to listen to the latest developments there. So since you are a faculty of CEMAS, I think there will be definitely more opportunities for you to interact with the students. And good that now that we have the Trevor Science Foundation also, so that a lot of more people can be just trained on just getting these trained for getting and citizen science also trained to get the data from aquatic sources. So anybody has got questions? I think 2 or 3 questions we will admit. Any data on antibiotic resistant organisms?
Okay, when we work with remote sensing, what we get is spectral information, but so as to follow it up with different activities. For example, what you asked is like microbiological information. So we have a microbiologist in our team, not only one microbiologist. Now we have a medical doctor also in our team. So we discuss with them. They want some information. For example, our microbiologist, he was trying to see like how the Vibrio is interacting with the different optical constituents. I was explaining the optical constituents. So whether the Vibrio is interacting with the phytoplankton, or whether the Vibrio is interacting with zooplankton, or we did in situ sampling. For the entire stretch of the lake, we did in situ sampling, and our microbiologist was doing AMR test also, the microbiological test also, and he did in situ studies on how the interaction is happening. With this basic information, we fit this information with our environmental data into epidemiological model. And we try to see like how best we can use satellite retrieved information to run those models to give the advisories. That is how it is functioning. So AMR information is available for Bembanat Lake, with which we are working. If it has to be taken for other lakes, definitely a lot of in situ sampling is also required. Thank you, ma'am, for the question.
Any other questions?
Dr. Ojas
Yes.
asked.
I think
ISRO
there are a
has-
lot of satellites. ISRO has developed satellites.
In marine fisheries. Okay. Yeah, Meena ma'am was touching it. That's why, like, ISRO has got ocean satellites alone. Now our interest is on having a fisheries satellite dedicated. So OceanSat 1, OceanSat 2. But the problem is like when in all these studies, what I have indicated, we have used other satellite information, not Indian satellite information. The problem is like we have better validated products. Like I was telling of the example of the ocean color. OCCCI is the best platform because in that platform, worldwide, whatever satellites are there, everything is merged into that platform. We tried to work with ISRO also to include ISRO information also into this platform, but there were some hitches, but some of the information was taken, but it is not fully loaded there. So when we have a better validated data set, which is in the form of a final product, which can be used by stakeholders like me. I am not a remote sensing specialist. I just use these products for resolving marine ecological challenges. So we use those information. But when it comes to an operational strategy, like INCOIS is directly using Indian ISRO satellites, like OceanSats are used by INCOIS. They receive the information straight. That is the advantage of what we have with ISRO. But we cannot get such information from other countries. So when we have our own satellite as a strength, we can use that for operationalization of it. But when we have to develop the technology, let us go with those products which are having scientific merit, and we go ahead with those well-validated products and do development of our technology. So ISRO do have satellites, but we use it for operationalization. And definitely we sometimes try to work on it because ISRO gives us project to fine tune the things and we work on it. Like I have a program with NRSC also, ongoing program. Maybe Kunal is going to explain much on it.
Anyone else? I think, thank you, Brinson, because we have got 2 more presentations to be taken up in the morning session.
Thank you, ma'am.
I mean, from my personal side and also from CEMAS, so thank you so much. And definitely, we look forward in hearing a lot of lectures from you on the developed strategies which is present in remote sensing. Thank you very much.
Thank you for the opportunity. Thank you.
Thank you, Dr. George. So moving on to our next talk.
Kunal Chakrabarti. Yeah.
So our next fourth speaker is Dr. Narsiya Thakur. Dr. Thakur is a senior principal scientist at CSI and National Institute of Oceanography, Goa, and heading a chemical oceanography division. He has earned his PhD degree from NIO and done his postdoctoral research at University of Mainz, Germany. Before joining NIO in 2007, he had established and leading marine biotechnology group at Nicholas Piramal Research Center, Mumbai, to discover marine-derived bioactive molecules for therapeutic applications. He is leading a national research program, BioProSmart, for exploring industrial applications of marine organisms. He's also known for his research work on marine chemical ecology to understand chemical interactions between marine organisms at different trophic level and translate this knowledge for bioprospecting. Dr. Thakur has 40 research publications to his credit, and he is a coordinator and research guide at ACSIR and Goa University. Sir is also a coordinator of Patent and Technology Cell. Dr. Narsiya Thakur, I cordially welcome you. Sir will be delivering his lecture on marine bioprospecting. Over to you, Dr. Thakur.
Yes, thank you very much. Can you see my presentation?
Yes, sir, yes.
Okay. It's my pleasure to deliver a talk at this particular symposium because it is organized by my Mumbai University. And I'm really happy to talk about marine bioprospecting. So bioprospecting is nothing but prospecting of any organism, living resources, and marine bioprospecting related to marine bioresources. So this is a systematic and well-organized search for useful products and processes, not only from microorganisms, but also from plants and animals, etc. And here we are looking for products, for commercialization, or having industrial application, as well as societal relevance. So my agenda of talk is like this. Initially, we will see which are the organisms, because in marine bioprospecting, there are different products for different sectors, but I will be focusing more on therapeutic products or healthcare products. And these products are in the form of marine nature products. So in marine biodiversity, we have to see that which are the organisms they make these marine nature products or bioactive molecules. Then we have to ask a fundamental question like why these organisms are making these molecules, that is under chemical ecology, and then how can we explore these marine nature products for therapeutic applications or healthcare applications. And then second last one is C2 pharmacy, some of the molecules which are presently in clinical trials and in market, and couple of slides about our work at CSR and I. So this is very common picture of zonation of sea. Everybody knows that there are three major zones in the ocean. First one is euphotic zone, then bathyl zone and abyssal zone. So euphotic zone, the net primary production is more because of sunlight can reach up to 200-meter depth. And this area, that is intertidal region and subtidal region, is very much important because there is a diversity of organisms in this particular region. So we can explore this diversity for bioprospecting. And also in other regions like bathyl region and abyssal region, there are organisms surviving there, and they are adapted themselves to survive in that extreme conditions or those special conditions in those zones. So some of the organisms which are very important from bioprospecting point of view. First group is marine sponges. Marine sponges are phylum Porifera, pore-bearing organism. They are sessile and stick to the substratum. They can filter the water because they have well-defined canal system. And this group is having almost 9,000 species of sponges worldwide. Out of that, almost 450 species we are having in Indian coast. Second group is sea anemone. This is Midarians, and they have very peculiar characteristics. They produce venom, and this venom they produce for ecological reason for capturing prey or to fight against a predator. But this venom is very much important for bioprospecting, and I will come to that point afterwards. So this is a group of organisms very potential for bioprospecting. Then we have corals, algae, zebra mussels, jellyfish, barnacles, and very importantly, bryozoans, which is also a very attractive source for bioprospecting. Then coming to echinoderms, there are organisms, though these organisms are having some physical defense like sea urchin or starfish, but this group of organisms, they produce a lot of toxins, like for example, sea cucumber having toxins like holotherine, and these toxins are very much important for bioprospecting. So now coming to chemical ecology, now when we are communicating, we are using verbal language, right? But in ocean, the organisms are using language in the form of chemicals. They have chemical language to interact with each other, to defend against predators, so many defense purpose as well as for communication purpose. So these are allelochemicals and infochemicals. So understanding this chemical language or understanding this language is in the form of organic chemicals, and this is mostly the organic chemistry is involved here. So understanding chemical language or understanding interaction between organisms is under chemical ecology. And I would say there are many organisms are having physical defense. Like I was showing picture of sea urchin, there is a physical defense. But there are some organisms which are sessile and soft-bodied, like sponge. Sponge is sessile, cannot move from one substratum to other substratum. It's soft-bodied, and there is no physical defense at all. But there are challenges in ecology, in ecosystem, like there is a competition for space, there is a predation, there is associated fauna. So how this simple sea creature survives in this condition? So now I'm just going to touch all these three points. Like you can see the space for competition for space. You can see a sponge is growing here. There is algae, there is zoanthus, that is a soft coral. Again, sponges with fighting for space with zoanthus, sponge with zoanthus, sponge. This is other species of sponge with zoanthus. So basically in intertidal region, these sessile organisms, they need substratum for their settlement. So during the larval stage, they search for the substratum and they settle there throughout their life. And in that particular competition, every organism is struggling for right space, because once they settle there, they should get ample amount of nutrients, the proper water flow. So this competition is very severe. Then second competition is like predation. Many dangerous predators are ready to eat this soft-bodied organism. You can see that some organisms, the sponges are here. The piece is there is a bite of the fish on the sponge. Then grazing of gastropods on the sponge. So there is a trade of predation. And third one is association. So like I'm just taking example of sponge, but this is the case for many sessile organisms, many sessile invertebrates. So you can see here the sponge with a lot of bacteria inside, almost 40% of biomass in some of the sponges, because sponges are filter feeders, and also trade from other organisms. Many other organisms are living in the pores. So there is again very much pressure of associated organisms on this. So now the question is, how does this simple sea creature survives in the competition? And these are the chemical weapons these organisms are using. And these chemical weapons are, you can say, nature's pharmacopoeia. There are a lot of molecules from available with the organisms, and they use smartly. When there is a need, they use these chemicals for fighting for the space, or to deter the predator, or to tackle the problem of associated organism. So you can see this particular picture. This is a sponge, and which is filtering a lot of water. So through this water, the sponge is getting a lot of pathogens, and sponge is producing antibiotics to kill those pathogens. Possibly we can use these antibiotics for human benefit. Then similarly, the organism is secreting toxins to deter predators or to kill predator. And these toxins are very much important for anti-inflammation or analgesic purpose. And finally, as I was mentioning about the space competition, in the space competition, they secrete a lot of cytotoxic molecules to kill rapidly growing cells of their neighbors. And these cytotoxic compounds are very much useful for cancer chemotherapy, because in cancer or tumor also there is a rapidly growing cells, and these cytotoxic molecules are proved to be very effective. So now coming to marine nature product, all these molecules, bioactive molecules from the organism, different marine organisms, not only marine invertebrates, but also from the plants, microalgae and microorganisms especially, are coming under marine nature product. So here is the journey of marine nature products. Like 1960 is the birth year of marine nature product chemistry, where certain molecules were extracted from acidians. And this was the first time that marine nature products were discovered. And 1970 was a golden era, because till 1970, nobody was looking at the marine organisms for any molecule or any bioactive molecule. All the researchers were concentrating only on terrestrial part. But 1970 was a golden era, and then 1980, a lot of molecules were isolated, and 1990, this work continued. So one thing I would like to highlight is that marine nature products is not only the pharmaceuticals, but all the products from marine sources, which are healthcare products, enzymes, dietary supplements, food pigments, biopolymers, everything coming under marine natural products. Okay, so marine nature product for healthcare application. Here is the historical perspective, like 1815. For the Ebermeyer mentioned the medical application of roasted bath sponge. Then Chinese pharmacopoeia also recommends seaweed-based recipes. But very importantly, our own traditional medicine system, that is Ayurveda, is recommending marine nature products. And there are so many marine nature products are in use in Ayurvedic formulations like Pravar, Pardika, Shukti, Shankha, Agnichara, like that. So there are products in Ayurvedic systems which are derived from marine. So what I would like to highlight is that our ancestors were knowing the importance of marine natural products in healthcare application. So a couple of slides, very interesting slides. Even sponge juice was used to treat eye infections. It was just a crude way, but they were thinking, our researchers, our ancestors or researchers were thinking that whether we can use this kind of organisms for say for treating certain diseases. Then Spongia tosta, this particular sponge, and the iodine skeleton is used in homeopathic formulation. Then in Camper, Professor Camper in 1771 has first time described that this bioorganic matrix of the sponge can be used in plastic surgery. And he discovered one application of the sponge, that he had taken, or he has fabricated this lime wood ring, and top of that the sponge was fit. So that was for damaging nose. So this, maybe that was not in actual application that time, but that thoughts were there that we can use these marine nature products for healthcare applications. So now there is a systematic product drug discovery, you can say. So the journey starts from isolation or collection of marine organisms from different depths. Like we collect the organism by hand picking during the low tide, that is from intertidal region. Also by diving up to say 20-meter depth along the east and west coast of India and the coral reef areas, and by participating in the cruises to collect the samples from deep ocean. So there is a collection of marine organisms, then the extraction of molecules or the extract preparation, and then we go for in vitro assays, that is outside animal bodies in the laboratory, in the petri plates, on the multi-well plates. Then if the activity is there, then there is in vivo testing in animal model. And there is a lot of chemistry involved. First, chemistry is isolation, a lot of chromatographic techniques and spectroscopic techniques for the isolation as well as characterization of the molecule. And then for the chemical synthesis if the molecule is really potent. And then there is a toxicity testing and pharmacokinetics and pharmacodynamics. Like pharmacokinetic means how that particular drug, the molecule behaves in the body, like distribution of the molecule, then metabolism, excretion of the molecule. And pharmacodynamic means how your body is reacting to the molecule. So this is also very much important part of any drug discovery process. Then formulation means once you have identified a particular molecule, say for as an antibiotic, then you have to decide in what form you can deliver that molecule in the patient. Like it will be in tablet, capsule, injection, what route it should be. So that comes under the formulation. Then there are 4 important clinical trials. Everybody heard about clinical trials during this pandemic. And this is also very tedious process. And finally, your product is reaching in market. So this is a minimum time I have mentioned here, that is 10 to 15 years. But most importantly, involvement of different disciplines in this particular process. Like here we need marine biologists and ecologists, then organic chemists, pharmacologists, synthetic chemistry people, again toxicity, for toxicity studies we need specialists, then formulation people and clinical people, and finally the market. So now if you consider marine nature products, all these areas, marine nature products have been proved to be useful, and people or researchers have discovered different molecules for different therapeutic areas. So this is one survey which was done based on the DNA screening, and you can see that land plants only 12%, animals 5%, microorganisms 15%, and 8% marine plants. But 60% of marine organisms are producing bioactive compounds, and these compounds are very useful for bioprospecting. So now C2 pharmacy. This is a first product, that is ARA A. This is Vidarabin, and this was discovered and finally launched in market in 1975. I was just now mentioning about birth year of marine natural product chemistry, that was 1960. And you can see almost it took 15 years to bring any marine natural product in market. Of course, this product is no more in use because this was approved by US FDA. This was useful to treat the infection of simplex virus, but better option or better antiviral drug is available. So this molecule is no more in the drugs. But researchers or the scientist community understood or learned a lot from this discovery, initial discovery, and the first marine nature product which was in clinic. Then this is a current situation, like almost 20,000 different marine nature products have been described. Almost 20 different marine nature products are currently in clinical trials, and approximately 5 products are in market. So here is the list of molecules which are from sea to pharmacy. These are the compounds you can see, then mode of action, application mostly as a cancer or for infection, a couple of molecules for inflammation. And this is a status like market, phase 1, phase 2 clinical trial, phase 1 clinical trial. And these are the company worldwide working on marine nature products. And they are, assessing or analyzing their molecules in different clinical trials so that they can take these molecules to the market or clinic very soon. So if you look at this, definitely you will be having question like why most of the molecules are for cancer treatment or for infections. So please remember my previous slide when I was mentioning about the organisms are sessile, they are stick to the substratum. So to fight against their predators or the space competitors, they secrete cytotoxic molecules. So that is reflecting, you can see in the application category of the molecule. And also they are filter feeders. So to tackle the problem of these pathogens which are entering through filter feeding process, they produce this antibiotics. So that also is also reflecting in the molecules which are in clinical trial or in market. So apart from that, there are some products which are peptide, that is antifreeze glycoproteins from polar fish as a nutraceutical, chitosan from crustacean cells in cosmeceutical, proteins, that is GFP, green fluorescent protein from bioluminescent jellyfish, that is also a biotechnology product. And one thing which I have not mentioned here is a collagen. Collagen from fish scale is getting extracted and having applications not only in healthcare but in cosmetics and other applications as well. So now, very few molecules, just I would like to go through these slides, which are presently in clinical trials. This is plitidepsin. This is anti-cancer molecule, which is in phase 3 clinical trial. But very recently, when there was repurposing of drug was happening, like people were trying to use the existing drugs, which were already established for some other applications, and they were trying to, or they were checking the application to treat the coronavirus and found that this particular molecule from marine sources, which is in clinical trial 3 for as anti-cancer, the company Pharmamer, this is a Spanish company dedicated to Pharmamer, dedicated to the discovery of marine nature products, and they found that the aplidin, which is a trade name for this, is very effective, and now clinical trials are underway to treat the coronavirus, but originally it was anti-cancer drug. Then Chiarin 17, this molecule that is in clinical trial, and that is also anti-tumor and immunostimulatory molecules from the sponge. Then discodermolide, very interesting molecule, which is now in a phase 2 clinical trial. This was discovered by scientist Gunasekara from Harbour Branch Oceanography Institute, and this is a tubulin interactive agent. Tubulin interactive agents means this is used to treat the tumors actually. The tubulin is a protein which is all the time in polymerization stage and depolymerization stage, and this tubulin is present in various organs like cilia or flagella where there is a beating action, and also this tubulin is present in spindle fibers during mitosis. So if you are restricting this tubulin function, then you can stop the cell development, and that is a concept. That's why these tubulin interactive agents have been proved to be very effective as anti-tumor agents, and this molecule is tubulin interactive, which is in phase 2 clinical trial. I have already spoken about this molecule that is ARA-A, which is in market but presently discontinued from the market. Then manolite is anti-inflammatory agent. This was withdrawn from the clinical trial 2 because there was a toxicity. One thing is very important, that toxicity or the safety window should be there, that is the effective dose and toxic dose. So that was a problem. Initially in preclinical studies, this molecule was safe, but they observed that in clinical trial 2, there is a toxicity and patients are suffering from the toxic effects of this molecule. So it was withdrawn from the market. Then LEC-depsin is a chilalide molecule, again from the nudibranch or the sea slug, but recently it is proved that, and this very complicated molecule. So recently it is proved that this is not originally produced by the sea slug, but there are certain bacteria and these bacteria are producing this molecule. So this is a good news for the researchers. Now you can even ferment the microbe or the bacterium which is producing these molecules and get the molecules in larger quantity. The bryostatin, I was mentioning about the bryozoans in the biodiversity slide. So it's anti-cancer molecule from bryozoans, and it is in clinical trial 2. So now definitely there will be question from you. You are talking about so many molecules, but hardly few molecules are in clinical trials and very few are in market. So what is the reason? But one thing we should remember that the ratio, the success rate of the molecules from marine nature product is far better than the terrestrial sources. But still, if you consider this number, then we are ending up with very few molecules, selective molecules in clinical trials and finally in market. So these are the reasons. Actually, the researchers so far are more concentrating on just random collection of the organism and exploring them for bioactive molecules, and forgetting to ask these questions that why metabolites are produced, when metabolites are produced, and what are the biosynthetic pathways. Because the organisms, for example, the marine sponge which is sitting in Bombay coast or Mumbai coast or Ratnagiri coast or Malvan coast, why that particular organism has to secrete anti-cancer molecule or antibiotic. So reason is the ecological. As I have already told you in chemical ecology part, they secrete these molecules for their own purpose, for their own ecological purpose. And if we understand that ecological roles of the metabolites, then definitely we can take these molecules further in clinic in a sustainable way. So this is our concept. We are working on this particular concept, that is linking marine chemical ecology with bioprospecting. Okay, so I would like to quote one example of a supply problem. That is helicondrine. Helicondrine is coming from lozodendroic sponge. And this helicondrine, say, yearly requirement is 5 kg, but you have to harvest 16,000 metric ton of the sponge biomass. Now tell me, is it possible to get this much biomass without risking the extinction of the respective species? See, we cannot disturb the ecosystem or to harvest this kind of quantity for our benefit. So basically, one thing we have to remember that nature is just inspiring or showing us the structure of the molecule. Okay, this is a molecule, then we have to find a way to take that molecule for human benefit without disturbing ecosystem. Okay, because nature has its own pharmacopoeia, and we are just getting hint from the nature that this is the structure of the molecule. Then you have to find different ways to tackle the supply. So what are the different ways? Like first is mariculture. So people are trying to culture organisms in captured condition, or like how we do aquaculture, that very restricted environment. They are trying to culture the organism and then extract the molecules. But as I told you before, these organisms are secreting molecules for their own benefit. So if there is a need, they secrete the molecule. Because basically any organism is diverting its energy mostly for reproduction and growth. Defense is secondary. If there is a need, definitely there is a production. So when you grow this organism in very safe environment, researchers found that there is very less production of bioactive metabolites. So this approach is not very much successful. Then people also tried for the cell culture, but to get this kind of molecule by using cell culture approach for industrial scale, again there is a problem. Then molecular biology, that is a recombinant technology. In books we hear very interesting things about this molecular biology, or especially recombinant technology, that I can take the gene from one organism and put it in E. coli, and E. coli will start producing. But this is not so simple. Hardly there are 1 or 2 examples, because These molecules are very complicated molecules and not a single gene, but there is a cluster of gene involved in the production of these molecules. So you have to clone that complete gene cluster in simpler organism like the microbes, and then you can produce. So again, this particular approach is under trial, you can say. And then only approach so far successful is chemical synthesis. And there are many molecules are coming up by using this route, that is a chemical synthesis or derivatives of the molecule. But still, all of them are not possible to synthesize by using this chemical route, because there are some problems that commercially not feasible to synthesize the molecule using this particular route. So you can see there are bottlenecks to take the discovery from lab level to commercial level, but efforts are underway to discover different routes to get the material in enough quantity. So in conclusion, I would say that marine natural products are very much attractive and not only for healthcare purpose, but for different industrial applications. But we have to do that in a sustainable way without disturbing the ecosystem. And it's an attractive field of research which is having industrial application as well as societal relevance. So now what work we are doing at National Institute of Oceanography, the Chemical Oceanography division of NIO is having 3 different groups. One group is working on biogeochemistry, one group is working on water pollution, including microplastic pollution, and my group is working on, it's a bioorganic chemistry group working on marine natural products for bioprospecting. So this is our concept, linking marine chemical ecology, understanding chemical ecology of organisms, different organisms, not only marine invertebrate, but also microorganisms, and taking these products for bioprospecting. So what we do, that biology of potential organisms at cellular and molecular level, natural product repository we have, which we have developed, which is readily available for screening for any therapeutic areas, then ecological studies of lead molecules, then industrial potential of lead molecules in collaboration with industries and other academic institutes, and engineering marine derived biomaterials for biomedical application. Also, we are focused more on biomaterials. So we have natural product chemistry lab, which is full-fledged lab for chemistry, molecular biology, microbial fermentation, and marine natural product synthetic chemistry. So this is our present success story, which we are working upon, like the marine derived peptide antibiotic molecule. It's a very effective molecule against hospital acquired infection. If patient is lying in ICU for a longer time, like 2 weeks, 3 weeks, then this hospital acquired infections are coming. And presently there is not a single drug antibiotic available to treat this, and our molecule is very much effective, which is proved in vitro studies as well as in animal models. So now we are completing pre-IND studies. IND is investigational new drug application. So if you want to enter in clinical trials, you have to do you have to file IND application. And for filing IND application, you have to complete all pre-IND studies like safety pharmacology and toxicology. So we are completing this in collaboration with other institutes and industry. So one major project in this particular area, which I'm leading presently, that is a bioprosper, synergizing marine ecology with bioprospecting, harnessing marine living resources for products and processes. CSR and I was the nodal lab. Also, we have our sister labs from CSR, that is Indian Institute of Integrative Medicine, Jammu, IMTech Chandigarh, National Chemical Laboratory, Pune, Central Glass and Ceramic Research Institute from Kolkata, and Central Food Technology Research Institute from Mysore. So this project is underway. And last slide, I would like to show, though it is not very much connected to my topic, but I'm also coordinating PhD programs under ACSR, that is Academy of Scientific and Innovative Research, and every year 40 students we are admitting for under this ACSR program. So we have this ACSR and doctoral research program. So if anybody, because a lot of students are attending this symposium, so anybody is interested, you can contact us. The numbers are given here. Also, you can find on our website. So we welcome all the students. Also, we welcome students for dissertations and their summer training. Thank you all for listening my talk. And now this floor is open for questions or interaction. Thank you.
Thank you, Dr. Narsing. I'm glad that you have brought out all the possibilities of bioprospecting. But I have just one suggestion to make. The success of bioprospecting and the invention of biomolecules and all, no. The success depends on creating analogs. Because you cannot expect that it will, the whole molecules or maybe the quantity will come from the sea and all, no? So it is not possible. So analogs is, so along with your studies, no, maybe a small group or one or two people can just study on the production of analogs also, which will help you in future. Otherwise, just giving an intent or maybe giving an clue that everything can come from the sea will create problems later.
Madam, just I would like to mention this. Thank you for your suggestion. We have a synthetic chemistry group within our lab, which are taking care of analogs and derivatives. Because as you have correctly mentioned, a whole molecule will not work and we cannot expect everything from marine, but a small part of that, or we make a derivatives by inspiring, by looking at this particular structure. Yes, thank you, madam.
Okay.
Yes, we will take care.
Any questions? I think do you have incubation units to help the startups interested in working on marine natural products?
Yes, we have a business development group, and we do help. We do not have incubator at NIO, and we are working on that. Maybe in a couple of years, the incubator will be available, so that the people or the students who would like to start something in this particular area, they can do it. But presently, we have business development group, and we help startups. Even we can show them our technologies, which are readily available for commercialization. And there is one event which is happening, that is iConnect event, that is Industry Connect event on 4th of August. So if you could contact me, I will share the link, and you can be present there, because we will be showcasing our technologies, not only from NIO, but also from NIOT and CSMCRI Bhavnagar. So whatever technologies are there from marine living resources, we will be showcasing. So you can get more information. But yes, we do help startups for this purpose.
Indian Council of Agriculture Research also have business incubation units, which is present in different institutes. They also, from marine side, Central Institute of Fisheries Technology, Cochin, they have business initiative groups and BP incubation centers also, which will help you in making chitin, chitosan. And you are also mentioned many of the health nutrition support, because molecules from seaweeds and all, no? So they help it. They help.
Okay.
Any other question? If nothing is there, I'm sorry. Dr. Oja will be waiting for a long time.
Okay.
May I now request, thank you very much, Narsing, and it was very informative. And good that your lab is doing such a wonderful work. And now I know that there is a synthetic chemistry group also who will join you in just having analogs or maybe new molecules which is to be made in your lab. Thank you very much. And Mrinmay, I think now it is time that we take up the presentation of Dr. Oja.
Sure.
Yes, thank you, madam. Thank you.
Thank you, Dr. Thakur. So we'll be moving on to our next, the third lecture of this first session. Our next speaker is Dr. Shekarnath Oja. Dr. Oja is a principal scientist and head of the department Fisheries Economics Extension and Statistics Division of ICAR CIFI, Versova, Mumbai. Dr. Oja had started master's and doctoral programs in fisheries economics, extension, and business management, and mentored many students. He had taken several research projects and addressed issues related to common fisheries resources. The prestigious International Food Policy Research Institute, Washington, had acknowledged its concept related to privatization of fisheries extension. Sir has more than 100 research publications, articles, book chapters, and bulletin to his credit. Dr. Oja is an awardee of Dr. Hiralal Chaudhary Award for his extension work in fisheries. I welcome you, Dr. Oja. Over to you.
audible, ma'am?
Yes, clearly.
So, Honorable and very respected Vice Chancellor, Bombay University, Pro Vice Chancellor, Honorable Dr. Meena Kumari, our mentor, all the faculty members, scientists, and my dear students. So today the topic was very challenging for me at least, because it was the theme was talking about revitalization, collective action for ocean. And then I was going through different themes of different years. I found that 2009, the theme was Ocean, Our Responsibility. Then 2010, Ocean Opportunities and Challenges. So in the beginning stage, mostly the titles were, the themes were around exploring the ocean. Then when it came to 2013, it started shifting towards social science. So 2013, the theme was Ocean and People. Then come to 2019, it was Gender and Ocean. Then come to 2020, again, emphasis was not on social science, but general again, innovations for sustainable ocean. Of course, a lot of contribution from social science is also required in that, innovations for sustainable ocean. Then come to 2021, it was ocean life and livelihood. And 2022, it is collective action. Now, ocean is a very challenging area for everybody, all of us, we acknowledge. So we have done a lot of research in marine as well as aquaculture from extension angle, because ultimately the extension accumulates all different kinds of sciences. It becomes an ocean. So for this presentation, I did not collect the research findings because we had a lot of research projects, my side as well as my colleagues' sides, and then a lot of student research. So all those data I did not take, but the summary of those findings and my intuition, I have made a ideation framework so that we can quickly come to the conclusion what we can do in future. So to the students, I want to say ideation framework is to hypothesize about the product and services. So this is how it is defined, ideation framework. Now, what we need to hypothesize is that considering the challenges faced in the ocean, from the climate, overfishing, all those things that we have learned just now. Then pollution, these are the major three areas which is challenging us too much. So how to increase our capacities so that we can address those challenges. So we have the existing extension system, which was designed probably before 50s, mostly talk about authority and technology. So mostly the technology part, many of the technologies we have seen people have given a lot of deliberations and a lot of work has been done in the field of technology. And today's deliberation also, we saw how much beautiful work has been done in different technical fields. Then the second is extension is very much dependent on authority. So mostly policing, how to police in the ocean. So those things are there. Then suddenly, recently, something has come out, which is again Pradhan Mantri Matsya Sampada Yojana. So which is talking about supporting mostly the entrepreneurs and those who are poor people through producer organizations. But it is a little silent on how to do that, the extension part of it. The project has to be submitted, and then somebody will evaluate the project and admit it. So it talks in detail, different project cost, little bit of guidelines on different projects, and then how to calculate the cost, and then how to get it admitted. But how to promote those projects, that part is a little lacking. So I thought I should think on that direction, because farmers and fishermen, if they were capable to prepare projects, I think that the existence of department and research institutes would be a great question. So since they are not capable, that is the reason we are here. So facilitators are very important. If the only students are capable to learn, then role of teacher is almost zero. So only a library and hostel, etc., is sufficient to run the university. So since the teacher is very important, similarly, an extension officer is also very, very important in mentoring a fisherman. It is also important that extension officer has to improve the production, because production, productivity, etc., are very important. And then the fisherman doesn't have sufficient knowledge and skill to acquire the new technology and increase the production. So that is the reason in between the teacher and the college, there is a education called as extension education. Now, just a minute. Yes. So now coming to these present challenges which were not existing, mostly the challenge was production, productivity, for which the extension system was designed. But the new challenge which has emerged is climate, pollution, and overfishing. For that, probably the extension system was not designed. So we are not able to address. We only have the authority concept and we have the technology concept. Now, the world is understanding it is the collective action through which we can address these issues. So considering this background, against this background, I have developed this concept, alternative fisheries and agriculture extension strategy. Now since we have Pradhan Mantri Matsya Sampada Yojana as one of the most important tool before us, so can we mold this tool for to address climate as well as pollution as well as overfishing? So again, it was a very challenging task. So what I have done is in the third line is sustainable techno-organizational ecosystem transformation. So if all these things are converging towards sustainable techno-organizational and ecosystem transformation, probably we can have a framework to address all these new challenges. Now, again, how to address those challenges, I have divided into 3 parts. One is readiness action plan, because the challenges are becoming very severe, and we have to increase the capacity to address the challenges very soon. So we have to have a readiness action plan to address the emerging challenges like climate, increasing rich and poor gap, and less land per farm. So this is another challenge. The terrestrial ecosystem is not able, probably not will be able to sustain the entire population because size of holding, etc. The countries where the population is very high, the size of holding is coming down to such an extent that even we cannot absorb technology. The input cost is will be very high for against the purchasing power of a small and marginal farmer. Similar things are also very much visible in marine fisheries as well as inland fisheries. The total catch is coming down, and people are spending one day 5 to 5 days to get a minimum catch, and then they are not able to recover the cost. So how they will purchase new technology? So when the minimum they are not able to address the cost of catch, if they are not able to recover from how you can think that they will purchase sonar or any other instrument or new types of net and new types of gears, etc. So in both marine aquatic as well as terrestrial ecosystem, this is a very severe issue. Poor people are becoming poorer and rich people are becoming richer, and the catch per unit effort is coming down in the terrestrial system. It is less land per farm, which is also going to affect aquaculture, inland aquaculture. Now, these are the challenges for which we have to find out a readiness action plan. Second is platform-driven converging fisheries and aquaculture university extension. Now, we have, to some extent, some extension component is there in Department of Fisheries and Krishi Vigyan Kendra. But university extension, still we have to develop to a still higher level. So what I propose that if you have to address very quickly, today we can use the IT platforms because IT sector is moving very fast. So hologram, etc. A lot of concepts are emerging, metaverse, so many concepts are emerging. It is one of the fastest growing areas. So we can use this platform driven converging fisheries and aquaculture university extension service. All the universities like your college, our college, if we can strengthen our ICT systems, we can reach out to many people. For technology, technical backstopping, and the demand is because the small and marginal farmers in terrestrial ecosystem and the small scale fishers in the aquatic ecosystems, they have to be aggregated because they are not able to absorb any technology. Their income has come down to that level. So even if you tell them that to purchase this particular net, where is the money? Even if you are giving 60% subsidy through Pradhan Mantri, the rest of the 40% for them is a very, very, very big task. So what is now recommended is aggregate them. Now, if you aggregate them, then we have to write a project, a commercial project. So now for them, writing a commercial project is a very, very challenging task. So here comes the role of social science, project writing. And then once the projects are prepared and submitted for subsidies and then submitted for bank loans, then probably the appropriate technologies can be purchased. And then if the project has to be made successful, then the aggregation has to be sustainable. So the FPO model is now promoted. FPO or fish producer companies, this model is promoted. Now, how to run this model? Can the fishermen or the fish farmers run this model? Because that also requires a very high level of professional business management culture, like marketing strategy, managing the markets, and consumer response. Those who are studying business management, they must be knowing a lot of things are in the field of finance is taking place, a lot of changes are taking place, a lot of improvements are taking place in HR. So all this, those who have seen business management courses, so this field is also is growing very fast. So all these concepts have to be put in position if the company has to run. The Company Act itself is quite big. Then FPO, all these concepts have to be taught to them. So the role of social science is becoming more prominent in the form of project formulation and organization development. Now with this, we have to also increase the extension coverage. Now extension coverage, we are not using extension strategy. Even the traditional extension strategies are also not being used by the departments. We used to teach students how to contact people, how to divide the people into different groups, and then conduct training and visits system so that every farmer we are able to touch at least once in a 6 months. So those concepts are also very much important. Now, in addition to that, we have to also, if you have to increase the coverage, because the challenge is so severe that if the coverage also has to be increased very fast. So we have to use the modern technologies, definitely the GIS technology, GPS technology, IRS technology, remote sensing technology. Then we have mobile technology. Today, the direct to mobile concept has also come. So all these changes, then metaverse, all these changes which are hologram, etc. All these changes that are taking place in ICT, we have to address the traditional method like radio, television. They are also very, very important. Then the institutions also have to be converged, like public, private, voluntary, and community. This PPVC, this if we cannot have partnership, at least we can have participation, so that we can have better coverage in the area. So public, private, and voluntary organizations, along with community organizations, if we can converge. And there is no if and but today, because the challenges are becoming, all of us, we have heard first two lectures, they are becoming so severe that we have to address, we have to go for collective actions. So collective actions, we have to take ITs, we have to converge the institutions, private, public, voluntary, and community organizations. So very fast extension has to reorient, revamp itself. We have discussed revitalization, collection. This is the collective action for ocean. So this is now a challenge. Immediately, all people have to be brought under one umbrella. So first point is readiness action plan, so that we have to address, so that we can address the emerging challenges. Now, collective action for climate is very, very important. So we all know, in very short, let me tell, the similar situation was there in Ice Age. Now, probably that time we believe that God himself came and rescued us. But today we have created this situation. We are going to create this situation where the entire ocean is going to take up a lot of land. So if this situation is created by us, then we have to come out with some solution. So more land to be covered by the sea. So if the more land is to be covered by the sea, then it is the duty of marine scientists and the duty of aquaculture scientists to come out with a very robust system of extension, so that we can sustain the livelihood of the people. Because many people, the terrestrial land, terrestrial ecosystem will be submerged. So many people have to be rescued from the terrestrial ecosystem and to be converted into fish farmers. So then in inland areas also, all of us, we agree, and in the first presentation it was there. So the rainfall is going to become erratic. So if the rainfall is going to become erratic, and it will be sudden spell, flood followed by drought, flood followed by drought. This is the trend. So for 15 days it will be flood. Then after 1 month there will be no rain and a huge temperature. So if this is there, then there has to be a water storage system. So farm ponds are being created. The moment the farm ponds are created, many ponds, water harvesting tanks are created, there is a demand for aquaculture. So which the Department of Fisheries is not addressing. So our institute has taken a very mega project on farm ponds, aquaculture. So we also do not know what will be the aquaculture practices, but still we are trying to make quickly address those issues with the whatever ideation we can make. Because now there is even we do not find time to conduct research. So whatever idea is coming, immediately implement in a small scale and in the field condition, and then get the results, and then wherever we get the positive result, try to maximize it, and wherever we get the negative result, minimize it. So this is the approach. So that we can move very fast. So to control floods and droughts, the tanks are being prepared. Now, again, if the water bodies are to be managed, they are mostly common resources. In common resources, most of us, we have not learned how to handle the common resources. because our behavior is dictated by the terrestrial management of terrestrial ecosystem. Terrestrial ecosystems are divisible. You can divide it, make nations, districts, villages. So go on dividing. So we can have boundary lines. So we can have nations, between the nations we fight, between the districts also we fight, between the states also we fight. So we can create differences. So, but in water bodies, this is very difficult. So the differences that is created in the terrestrial ecosystem has increased the competition level, and our attitude to compete has become very prominent. So the Darwin theory also, survival of the fittest, competition, etc. Darwin theory also teaches all those things. But in water bodies, it is mostly collaboration. So joint actions, because there is very difficult to develop the terrestrial boundaries. So it is mostly collaboration, win-win situation. So we have to change our mindset from competition to collaboration, that is joint action, for better conservation of resources, livelihood, entrepreneurship development, and generation of emission-less technology. So this is the entire mindset. First, we have to change ourselves, including scientists and the fishermen. So if you see the traditional extension system, it was mostly focusing on technical skill for human capital development, and authority approach was used. And there was not much emphasis on social and natural capital. So the socio-economical impact was environmental degradation and increased rich and poor gap. So some people became very richer and some people become poorer. And the environment also was affected negatively, because the extension strategy or the education strategy, the field situation, the education becomes extension. So it was mostly focused on technology, human capital development, and authority or policing. So now in 2022 is declared as the International Year of Artisanal Fisheries and Aquaculture. The reason is in aquaculture and fisheries also, it is observed that small scale fisheries, they are suffering from two angles. One is overfishing is done by the large big fishermen, and pollution is coming near the coast. So ultimately, the small scale fisheries is getting negatively affected. Other side of small scale fisheries is that their contribution in nutrition, supplying the nutritious food to the coastal area is significant, because they don't have sufficient product to export. So they immediately sell in the nearest possible market. So their contribution for nutritional security is more than the other kinds of large scale fisheries. So if we can, and their methods are also very sustainable, eco-friendly. So that is the reason the United Nations has declared 2022, so that we can focus more on small scale fisheries, try to understand how to define them, how to understand them. Can we develop a separate strategy for them? So all those, can we develop even extension strategy for them? So all these things we have to think on this particular year. And environment, all of us are knowing environment is becoming a very big challenge. So considering all this, what should be what is emerging in extension, or what is emerging extension strategy? Extension of organization skill and ecosystem services as a collective action plan. This is becoming a very important area. So that is the reason this time the Ocean Day is the theme area is collective action for ocean revitalization. Now, three areas are very important. One is project formulation for sustainable resource and livelihood. So we cannot expect that fishermen and farmers, they can write a very professional project, bankable project. So here the role of students will be very high. So that they can do the cost benefit analysis, they can draft a project, detailed project, they can do the cost benefit analysis, they can also calculate the internal rate of return, so that any banker finds this project to be a viable project. So Bangladesh has already done it, and they have got Nobel Prize also, where the student and the farmers, they have worked together and they have shared the profit. So for the student also, it is a win-win situation, and for the farmer also, it is a win-win situation. Because project formulation is a professional thing, which without doing a course, at least a graduate is required. Become graduate or MSc in fisheries extension or economics is required. So if the student, they write a very good commercial project for the fishermen and it is applied, so the profit also can be shared, which is experimented in Bangladesh, Grameen Bank. So both of them are very happy, student as well as the farmers. Now, second approach is definitely everybody, there is a consensus, cluster approach, joint action based business organization development. So it is everybody agrees that in developing countries, individual farmer has become so small that they cannot purchase even very cheap technology also. So when they in cluster, definitely they can purchase some instrument like cage or pen or technologies which feed, etc. So it has to be in a cluster approach, and they can also hire some instruments. Then third thing is extension research for monitoring and evaluation, because if it has to be managed by professional as well as practitioners, then and a group of practitioners and a group of professionals, then it has to be a transparent. Transparency is very important. So monitoring and evaluation has to be a routine exercise. So what we have to monitor, this is my thinking, ideation. So generation of emission-less innovation that has to be strictly monitored. To what extent we have moved to the direction. I'm grateful to Dr. Professor Meena Kumari, who has given a list of technologies. So they are may not be emitting much pollution. Then a lot of battery operated boats or solar operated. These are also alternate technologies where people can work on that. Then ecosystem restoration. This is very important. Vincent George has spoken a lot on that. So how to restore the ecosystem? So ecosystem is a macro type concept. So we have to visualize a lot of things. So what are the factors which are contributing negatively to the ecosystem? And what are the factors which are contributing positively? So how to minimize the negative factors and how to maximize the positive factors through collective actions. So collective actions, only awareness will not do, only authority will not do, but we have to think of organization development. So ecosystem restoration and entrepreneurship and livelihood through organization development strategies. So these are the issues which have to be rigorously monitored to address the issue. So definitely the emerging principle of public extension will be today planning followed by partner search, because if we get a good partner, definitely in our life also our family becomes very good. And then similarly in business partner also, if you get a very good business partner, we should be very careful in selecting a partner. So partner search is very good, very important. Then feasibility studies are very important. Both the partners, what they come out with a new concept. So one partner is from say biology side, another from social science. So what they conclude, whether that is feasible or not. Then if it is feasible, then it has to be incorporated. So this is how the projects have to be designed in future, and how we can incorporate fishermen in this project. So that is also a great challenge, how to incubate them in that project. Many times fishermen also can come out with very good ideas. So how to incorporate those things in the collective action. So the principle which I understand is organizing joint ventures for harmonic action. This will be the focus, because when people from different background, they sit together, immediately there should not be much feeling about differences. There should be much feeling about harmony. So a lawyer should not think that law is better than research, or research is better than development, or development is better than corporate. So or public sector is better than private sector. So we should all the time hammer on harmony. So joint venture should continuously hammer on harmony so that the differences can be minimized and work together. So organizing joint ventures for harmonic action, that should be the principle. Now coming to again collective action. This was a very big challenge. How to initiate collective action. So we were discussing a lot with International Food Policy Research Institute, 2018-19. So 2-3 years after a lot of discussion with scientists, International Food Policy Research Institute, we could come out with a sequence. Mostly the people who are from the field background of biology, they start from conservation. And then the moment we start from the conservation, then the livelihood somehow it gets disturbed. The moment the livelihood gets disturbed, the collective action gets disturbed. So then from where to start? So we thought that if we can sequence like this, like for example, in the first point, if you see, generation of emission-less innovation for eco-friendly, already Meena Madam has already spoken a lot about it. So emission-less innovations for eco-friendly and climate-smart value chain. So mostly we think about production. We seldom think about value chain. So marketing, etc., or in between value chain, we have warehousing and all those. That part also we have to think. Definitely people have done a lot of work in that, but we should also project that, because there we find very good entrepreneurs. So value chain, especially the middle part of the value chain, warehousing, retails, and transportation. So all this entire value chain has to be addressed, especially in fisheries, because the fisheries is a very perishable. The moment fish comes out of the water, it is no more alive. But chicken, etc., we can transport the live bird to a very long distance. For vegetables also, it can be kept alive. Fruits also, it can be kept alive because they know the plants know how to go to the dormancy stage. So seeds, etc., they automatically go to the dormancy stage. But when it comes to fish, it is dead. So perishability is very, very important. And when it comes to nutrition, fish is very important. So fish has both a very positive point and very negative point. Perishability is one negative point, and then nutritive value is a extremely very positive point. Extreme is another extreme end. So we have to invest a lot of money in developing. The public sector also should invest a lot of money in partnership with the private sector. So that is the reason Sagar Mala project is a very ambitious project, where the supply chain is also, fish supply chain is also taken into consideration. Now come to the next part is FPO, FPC. Already I have said we have to understand a lot of company concepts and a lot of business management concepts, so that input, production, marketing, export, value addition, income, inclusiveness, job creation, etc., can be designed more professionally. Because now still we have the fisheries and aquaculture sector as a very traditional sector. But if you see, we do not find today the very traditional blacksmith or very traditional shoemaker, because a lot of companies, professional companies have entered in this area. So it is all entire value chain or entire system has been modernized. So all modern, up-to-date business management concepts are also in position. So similarly, we can the extension has to think, the modern extension has to think in this direction. Now, wherever those technologies are possible and technologies are available which are emission-less, there we should go for the second point is intensification, and the third point is expansion of area. Then once we are able to do this, then we are able to attract fishermen towards this direction, because simply directly jumping to conservation, then many times we can have differences with the fishermen, because when we joined this institute, we started with conservation. The moment you start with the conservation, then the fisherman says, what should I eat then? Should I not send my child to a school? So for 3 months, you are banning the fishing, you are not giving an alternate livelihood. So what my child will do? What can you stop your salary for 3 months? So these were the very questions where fishermen were asking us. So we thought we should think about alternate livelihood first, then go for conservation. Now within that is the reason 4th point is conservation. Now come to 5th point is need-based diversification. Now within the conservation also we should ask them if we are going to stop fishing for so many days, or if you are going to go for different kinds of net, then what is the alternate business you like to take up? So out of those list, we have conducted these exercises. So they will talk about computer, etc., etc. But out of that, some will match with fisheries, ornamental and etc. Those things can be or processing, value addition, marketing, etc. So those things we can tick, and then we can initiate programs in that direction. Of course, simply technology transfer is for value addition is not sufficient. We have done this exercise and we have failed also. So without proper marketing, etc., we should not take up those areas. So once we take up start from market-led extension, then come to production, then probably the chances of success is more. So where is the market? Because fishermen, we have taken money from TIFAC and started a processing plant in one of the remote areas of Thane district. And we assumed that those women can do the marketing. We took them to Lijjat Papad, we took them to different markets. But when we left, said, now you take up this project, entire infrastructure is ready, everything is ready, training program is also ready. So training program is also conducted and they are very good in preparing pickles, etc. Then coming to the market, they were, and when we were marketing, it was doing very good. But how long we can market? The projects are mostly 3 years. So then when we said that now you take the market, then in the marketing field, they started failing. Now, after a long struggle, one lady has come up. She has started marketing, but one person is not sufficient. So entire structure has to be created so that bulk marketing can be done, and markets also fluctuate. They are also not steady. Sometimes some 5-star hotels, they will be very keen to purchase those pickles. Sometimes they will say, okay, we are fed up with this. We are now purchasing another kind of pickle. So we have to then again search a new market. So this exercise is also very important, need-based diversification. Then come to the 8th point, participatory conservation. Once we are able to do this first 5 points, then let us go for participatory conservation. Why? Reason is already we are diverting some people from fisheries to other areas. So automatically the pressure on fisheries is coming down. So it is indirectly contributing towards conservation. So first let us try to divert people from fisheries to other fisheries related areas. So automatically it will take care a little bit, address the issue of conservation. Now come to conservation directly, participatory conservation, CCRF already it was discussed very nicely by Honorable former DDG. Now participatory conservation is little different than authoritative method. Authoritative measures, policing, etc. Participatory, what we want is that we should ask them what you want. They also know, if you just ask what was your catch 20 years back, they can give you some figure. And what is the catch today? So they can, and what were the species available 20 years back and what are, so through guided discussion, these are called guided discussions in extension. So through this method, we can get the answers what we want. So they will say, okay, the catch has come down to this level, then what should we do? So, okay, breeding ground, if we can do, how to protect the breeding. So, so that the answers come from them, and then only protection, marine protected area, only demarcating is not sufficient, what I feel. It should be in a participatory approach, that they should themselves come out, we can depute one person to protect that area. So then what will happen to the family of the person who is protecting that area? So we can say, okay, we can convert it into a tourist spot so that he can take people on the boat and then show them with the help of sonar or something, what is happening below the water. So, and then we can charge some money for that. So 20 rupees per tourist we can charge per visit. So that way we can design through some concept, through a participatory conservation mechanism, so that the people continuously are with us. Because without their participation, only policing is so difficult, what Madam has said, very difficult in ocean. Now, if we are successful in that area, then come to alternative fisheries and aquaculture enterprise development. Of course, it should come after 5th point only, it is 6th point. Alternative fisheries and aquaculture enterprise development. So what I have already explained. So alternative, when you are going for diversification, some of the points will come from fisheries only, aquaculture only. For example, pickle, product development, processing, marketing, ornamental fisheries. So first, let us address those alternative livelihoods, the enterprise development. Then 7th point is fisheries and aquaculture infrastructure development. So there also already Government of India has a infrastructure development fund, fisheries and aquaculture infrastructure development fund. So that also requires a lot of entrepreneurs. Some entrepreneurs in our area, Maharashtra, we see they have come out with ice plants. So that is also an infrastructure. So those entrepreneurs who are interested in contributing in the infrastructure development, so they can be also promoted. So then come to the participatory conservation. So by doing all this, we have already reduced the load on capture fisheries. Then go for participatory conservation, because we have opened new avenues, facilitated new avenues. Now, after the 8th point, we come to the 9th point. Environment is really creating a lot of challenge, climate, then pollution. So climate resilience is a very important area. So I have what we have done is we have divided environment security into 2 parts, 10th and 11th. 10th is resisting water pollution. Now, polluters are polluting the sea or any water body, but there is no resistance from those who are using the sea or those who are dwelling on the sea. So can extension organize some people to resist? If there is no resistance from the users, the polluters, they find it is a free area, so nobody is resisting. So let us dump all the pollution there. So can we find a mechanism in extension where we can create some resistance on the polluters? So we can ask the policymakers, put fishermen in the pollution control board, so that he also can, and take fishermen in the pollution control board. They can also offer their boats to collect samples. Because when we went to pollution control board, they said we don't have boats to go to the different parts of the sea. Then we talked to the fishermen, can you lend your boat to the pollution control board to go to a particular point to collect the sample? Well, already we are going. If they come, what is the problem? No, we don't have any problem. So we then again talk to pollution control board. They say we do not have this mechanism. So if this mechanism is there, that we can hire a boat from fishermen and go to the pollution and collect the samples. So this and then they also have the right. At least they can sign whether pollution was correct, the report was correct or not. Because only the authority which is signing is the pollution control board authority, and they are sometimes backed by the industries, that you just sign that there is no pollution in the ocean. So there is a pressure from the industry. Now, if there is a counter pressure from fishermen, why you have signed? I will not sign, because he is also a member in that. So there will be some resistance from the fishermen. The second is, of course, resisting water pollution. We can also add resisting overfishing. Small fishermen can also report if they feel that overfishing is going on by some trawlers. Then the 11th point is disaster management. The climate is changing so fast that now Western coast is also having cyclones, etc. Now every year, consequently, we are facing cyclones and sometimes flood, etc. So extension has to take another responsibility, that is disaster management, at least mock drills once in a year, so that the number of deaths can be reduced. Other facilities can be extended, like medicine, etc. Once we conduct mock drills, so that we know that how to do this work. So these are the areas what we find for collective action framework, so that we can conserve, we can improve the livelihood and safeguard our community from the disasters. So all these points, if we can address simultaneously, we can have a collective action framework. Now, for that, we require alternative extension. We should encourage the universities. We can encourage the marine colleges like Marine Studies, Center of Excellence Marine Studies. We can encourage them to develop a platform-driven converging fisheries and aquaculture university extension service for techno-organizational ecosystem restoration, so that all this information can be given to the fishermen through a platform. And then, of course, through personal visit, we can mobilize people for a collective action.
Yeah.
Now, we have to also use this facility program. So this is a massive program, Pradhan Mantri Matsya Sampada Yojana. Can we use this program for addressing the issues of the marine area? So this come to this program in very short. I have just given a brief, the harness to potential of the fishing areas. It's a very ambitious program, enhance fish production, modernize and strengthen the value chain, then double fish farmers income, then fishers and fish farmers income, enhance the contribution of fisheries sector in GBA. All these things are possible, then ensure social, and provided we have a very good robust extension system. The 7th point says build a robust fisheries and management and regulatory framework. So in this management and regulatory framework, we can also design a extension framework. Now, these are very general things. I will just, these are very ambitious plans. Economic, the export has to be increased to 1 crore, and then the post-harvest losses has to be reduced to 10%. All these things are there in that report. Then who can participate in this program? So community organization, and public organization, all three organizations can participate. Even private organizations can also participate in this program, entrepreneurs and startups. Now, community fishers, fish farmers, fish workers, within that weaker sections are also given special privileges, SC, ST, a woman, and differently abled persons. Now, community organizations like self-help groups, fisheries cooperatives, federations, fish farmers, producer organization, producer company, etc., they can participate in this Pradhan Mantri Matsya Sampada Yojana. Then public organization, Fisheries Development Corporation, state government, union territories, state fisheries development board, central government and its entities all can participate. So even military and police can also participate in this organization. So any program, it is supported by central sector scheme and centrally sponsored schemes. Central sector schemes, wherever we do not get much participation, they are very technically very sophisticated or capital intensive or knowledge intensive. Their government comes with 100% funding. And wherever there is a participation, of course, the contribution is distributed. So wherever the possibility of distribution of contribution is there, there is a contribution from the other sectors, private sector or government sector or individuals. There it is called central sponsored scheme. But again, within the central sponsored schemes, some areas are possible where the beneficiaries are not available. So in that also, of course, government comes out with more subsidies. Then for area-wise also, Himalayan and Northeast area, the subsidy is more than 90%, sorry. And for other state, it is 60% from the central sector and 40% from the state sector. Union territory, it is 100%. Now, beneficiary oriented, wherever it is possible, beneficiaries are possible, there again 60-40 share is there. Again, if you have to see in a matrix form. So the matrix, I will come to the matrix later on. So there you'll find it more clear. So this is the matrix. Central sector scheme, you see the total expenditure, then central share, and there is no state share, and there is no beneficiary share. Then in centrally sponsored scheme, you have central share, state share, as well as beneficiaries. Then beneficiaries oriented scheme, again you have central share, state share, and beneficiary share. Non-beneficiaries, you have central share and state share, and there is no beneficiary share. So that way all the projects are divided. Those projects by and large are taken under central scheme, which are knowledge and capital intensive. So only professionals can do that. So these are the central sector schemes where the subsidy is almost 100%. In that, I have highlighted some schemes which are very close to extension. Training, awareness, where you get 100% subsidy. Training for increasing the awareness, for training the people, exposure, capacity building, etc., 100% subsidy. Then field data collection, fisheries survey, strengthening of fisheries database, etc., remote sensing data, etc., 100% subsidy. Producer organization, producer company, 100% subsidy. Then private extension service again. There are 2 private extension services proposed in this project program. One is called as Matsya Seva Kendra, another is called as Sagar Mitra. So these private extension services also 100% subsidy. And rest are all technology oriented, like genetic improvement programs, etc., etc. So I'm only concentrating on extension. Now, how to promote extension? Now we have 2 additional things: organization development as well as ecosystem services. Now, to do this, collective actions are required, and then we have to do fast action. So the best possible thing is to take the help of platform. Now, the platform, the approach should be online field school to farmer producer organization. This should be the approach. So we should immediately start from field school, giving training on technology, giving training through platform approach, through online, and of course personal visits. 100% cannot be online. Practicals has to be given through personal visit. So, but many things we can cover through online. So field schools as well as producer organization. So once we go for producer organization, because individually nobody is capable today to even purchase small technology, cheaper technologies, people have to aggregate it. So they have to be organized. So organizational development concept, OD concept has to be implemented. All business management concept has to be implemented along with the technology. So those things has to be also covered in the field school. So this is again ideation, where I suppose that okay, scientists are there, they are giving online classes, taking online classes. Even some startups are also there. Then the fisherman is undergoing the online classes, and fish farmer is also undergoing the online classes. Fisherwoman is also undergoing the online classes. Then those who are not able to undergo online classes, they can be covered by good para extension teachers. So again, grooming the para extension is also becoming our responsibility. So whatever has been covered online, that can be repeated by these para extension professionals who can cover this, because we require 200, 300 people in a group to have a producer organization. So how to cover that? Everybody will not have mobile phone. Everybody will not have, only 1 or 2 people who can take the technology from the university or the research institute. They can be identified who are having the technology, like they can be identified to take the technology. And then a second line has to be created who can talk to what was covered, say yesterday or last class. So that has to be discussed with other rest of the people. And then they have to be brought under one organization. So this has to be a system. We have to initiate this system to go for producer organization concept. So in one unit, there can be 20 farmers. Otherwise, taking classes will be very difficult. So if you have to have 1,000 farmers, you can just divide 1,000 divided 20. So you have to have so many groups. Now we have to make some criteria for those para-extension persons.
Sorry to intervene, Dr. Oja.
Hello.
In fact, we are a bit running
Hello.
late. Can you hear me? So,
Hello.
Hello. Can you hear me?
Yes.
Sir, we are running a little late. So
Okay, I will move very fast. Yes.
Yeah,
Yeah.
conclude.
So
we have to
the
start the next
para-extension has
session by
to
3
do
o'clock.
repeat the classes, keep the contact of the continuously keep in touch with the DOF and take feedback, and then conduct practicals and the field condition have and they should have internet connections. Now, once we have 1,000 farmers in a group, then that group has to be divided into inputs. Some people who are interested in procurement, so they have to put under input supply group. Some people who are interested in maintaining the finance, treasury, so they will be put under finance and technical group. Some people will be interested only in technology. Some people will be interested only in marketing, and some people will be in networking and training. So that way, if we can divide this, so we can have managing directors for each group. So at least 5 managing directors are required to run a producer organization or producer company. So, and then 1 CEO is required. So we can groom, we have to groom this developing managing director from the beginning who can become a professional managing director in the group. Because it is a collective action, so we have to understand how to initiate collective action. Now, for collective action, again, project writing is very important because it has to be a viable project. It cannot be a totally subsidy project. So a commercial project has to be drafted based on a technology and organization. So demand and supply analysis has to be written. It has to be done by professional, cost benefit analysis, etc., internal rate of return, timeline, etc., etc. Now, the producer organization, again, it is very much related to a collective action. So at the village level, we can have interest groups. And then at the block level, we can have cluster committees. And at the district level, we can have FPOs. Now, one fisherman or fisher interest group can have 11 farmers or fishermen and one block in every village. And then in block, we can have 11 FIGs, fisheries interest group. So altogether, we can collect 121 fishermen or fish farmers. At the district level, we can have 10 such clusters. So we can have, if this is possible, then we can have 1,000 farmers or fishers in one FPO. So this can be an ideal collective action program for oceans. Now, already it is not a very scary thing. Already Amul has come out with this model. So already example is there. So to do this, we have to modernize fisheries and aquaculture extension. Already we have said PPVC, public, private, and voluntary and community organizations have to be brought under one umbrella, converging them under one umbrella through a platform approach. In addition to that, we can have another body called as Aqua Chamber of Commerce who can look after the business part. So regulators, because business management also has many dimensions, regulators, entrepreneur-led extension, and startups and farmers and fishers. So they have to see the procurement, production, promotion for prosperity, people and planet. So all these dimensions are becoming, when we add all these dimensions together, they become very complicated, but somehow we have to address it. So I tried to bring everything under one umbrella. And then if we have to modernize extension, we have to unfold from here to next stage. Say we have to initiate the private extension, then entrepreneurs, then public extension, then national collaboration, international collaboration, database management, entrepreneurship-led extension. Then we have to go to the next level, that is convergence, then input and market, etc. has to be brought under one umbrella. Then all these groups have to be private, public, community, etc. have to be brought under one umbrella. Then convergence for for pluralism has to be done, because it is not only fisheries will work, entire blue economy will work. Then enabling the convergence for inclusiveness, not only the rich people will work, even the poor people has to work. They also have to get the job. Then blue growth initiative. Then the last stage is ICT, etc. has to, if you have to enlarge this concept, we have to bring ICT, GIS, para extension, NGO, community-based fisheries management, etc. Then vertical convergence, vertical integration is also very much important from central government, state government, and the village level. So I will escape this. This is a concept again developed with International Food Policy Research Institute, how to make a vertical integration. Without vertical integration, state, etc., because fisheries is a state subject, then central government has a department of fisheries, Ministry of Fisheries, how they will work together. And the state, the politicians are different, central government, they are different, parties are different. So how to do this? We have done some exercise, how to do this. Then come to social entrepreneurship, how to, in the field level, what to do. Performance-based incentives, we have to initiate private extension at the grassroots level, so that the Sagar Mitras can be developed, who can look after this collective action, facilitate the collective action at the field level. So, and that each Sagar Mitra has to be performance-based. They should be incentivized on the basis of the performance. So all the students of your college, our college, can be inducted in as a Sagar Mitra, because if you see the qualification required is fisheries science, marine biology, zoology, etc. to become a Sagar Mitra. Then this Sagar Mitra will promote the stakeholders, primary stakeholders. They can also promote the students' entrepreneurship by taking them into different entrepreneurial activities in the fisheries and aquaculture area. So I will quickly scan through. There are hundreds of activities. So I will quickly show one or two, which can be taken by students as well as fishermen. So with this, I conclude my lecture. And finally, I want to say that today's extension has to work with practitioners, professionals' participation. So you can see boys and girls, they are professionals, and on the side you see their parents or the elderly persons, they are practitioners. So if they join together, then we can have this modern extension concept. So this is what in a nutshell I wanted to say to all of you, how to initiate or galvanize collective action for revitalization of ocean. So thank you very much. I thank Madam Meena, who is also our mentor. I also thank Honorable Vice Chancellor once again. I also thank Honorable Pro Vice Chancellor for giving me this opportunity. I also thank Director CEMAS for giving me this opportunity. I also thank all the faculty members and the students for having a patient listening. Thank you very much.
Thank you, Dr. Roja. I'm sorry that we had to rush you through the last part of your presentation. Without extension scientists, there is nothing can be, no fisheries management, no creation.
I think there is an issue with the volume. I'm not able to hear, Madam.
Then I'm not able to hear.
No, we are not able to hear you, Madam.
But it is unmuted here.
Yeah, maybe Dr. Oja can unshare his screen.
Perhaps.
Now she's audible.
Yes.
I have unshared.
Okay, yeah,
we are very sorry that we had to rush through your last part of your presentation, but there is a very, very hard issue of our time constraint. So sorry for that. Dr. Francis, you may decide now whether we have to take up some questions or not.
Yeah, I think we may ask people to write in the chat box, and we can answer it subsequently.
And maybe thank you very much all the speakers once again for this very elaborate and extensive session, but very informative. Once again, thank you, Dr. Francis and Vice Chancellor, Pro Vice Chancellor, all the team behind you for conducting this webinar. I know the second part will be very informative, but I am not able to participate in it because I have to rush to CMFRA by 3 o'clock. Thank you so much.
Thank you, madam. Thank you very much for chairing the session and delivering the keynote address. We are very fortunate to have you with us today. I know that today is very busy day for most of the oceanographers. So, and afternoon I have seen several programs. So we will take a short break. Now we don't have much time. I hope many of you have finished your lunch. So we will quickly finish our lunch and maybe by 3 o'clock we will come back. And in the afternoon session will be chaired by Dr. Jnanashilan. So we will quickly break for 15 to 20 minutes. Thank you, madam, and thank you, Mrunmay.
Thank you, sir. A small announcement for attendees. The feedback link will be shared at the end of the second session, and the certificates will be mailed to you within a week. So we are hoping that you will be attending our next session also. So we'll resume the session at 3 p.m. sharp. See you all. Thank you.
Good afternoon, Dr. Unnikrishnan.
Good afternoon.
Good afternoon, Francis.
We'll wait for a couple of minutes. Some people are joining.
Okay, okay.
Good afternoon, sir. Can you hear me? Dr. Unnikrishnan, can you hear me?
Yes, I am able to hear. What
Okay.
about? Yeah.
Yes, we are able to hear you, sir. Yeah. I think your screen is already shared. You are muted. Sir, you're muted, sir. Still it is muted. Okay.
This thing.
Yeah, it is unmuted now.
Yeah. The presentation is there, no?
You want me to show it, or you
Yeah,
can?
please. That will be better.
Okay. Yeah, we'll do that. Just wait a few minutes, sir. We will start in another 2-3 minutes.
Okay. Hello, Dr. Gnanasheelan.
Good afternoon.
Good afternoon.
Good afternoon. Nice to meet you, at least online.
Yeah.
How are you? You are in Goa, right?
Yes.
Okay.
So the program is slightly behind the schedule, I think. Whether we get time, enough sufficient time we will get, or we have to cut short.
No, I think we will go according to the plan, like 40 minutes.
Okay.
Yeah. So we'll wind up. Anyway, we will not allow the speakers to speak more than 40 minutes. So we'll give warnings.
Yeah. But morning it didn't work.
Really, yeah. But this time, Dr. Mansi will remind us maybe.
Definitely, sir. I'll do remind you.
Yeah, 5 minutes before the.
Sure, sir.
Yeah. No problem.
I'll keep it the track.
Okay.
Yeah, we'll wait for 1 or 2 minutes more, and then we'll start. Okay.
Fine.
Yeah.
think we can start. Good afternoon, everyone. Welcome back to the second half of the symposium. Today we have 4 speakers, and the session will be chaired by Dr. Gnanasheelan. Dr. Gnanasheelan is Scientist G in Indian Institute of Tropical Meteorology, Pune. He is a very well-known climate scientist. He has been heading the Decadal Prediction Group of IITM. It's a new group, and he is an extremely well-known oceanographer, particularly in the field of ocean modeling. So we are fortunate to have him today to chair the session. I request Dr. Sheelan to conduct the process, and we have Dr. Mansi Shah, my colleague, to help Dr. Sheelan. Yeah, over to you, Dr. Sheelan.
Thank you, Professor Francis. And we have, as he mentioned, we have 4 speakers, very well-known speakers. So we will try to finish well in time, so that I request all the speakers to limit their talk to less than 40 minutes and leave some time for questions and discussions. The first speaker is Dr. Unnikrishnan, former chief scientist from Inaugural, Goa. So he will be talking on sea level rise along the Indian coast. So I request Dr. Mansi to briefly introduce Dr. Unnikrishnan.
Thank you, Dr. Gnanasheelan. Dr. Unnikrishnan is a retired principal scientist from the Physical Oceanography Department of CSI NIO Goa. Dr. Unnikrishnan has a vast experience in the analysis of tide gauge data, and he has authored several research papers on sea level rise along the coast of India. In total, he has 86 scientific publications on his credit. Even he has mentored several masters and PhD students throughout his career. He has made significant contribution to the IPCC climate analysis and projection. Today, he is going to give us a glimpse of sea level rise along the Indian coast. So over to you, Dr. Unnikrishnan.
Thank you, Dr. Gnanasheelan and Dr. Mansi. Can I have the slide, please? Can you please?
Yeah, sure.
Yeah.
Is it visible?
No, yeah, it's
yes.
Put it on full screen.
For me, not yet. Yes, I can see. So, shall I start?
Mansi, can you make it full screen?
It's on a full screen, sir.
No, it's not full screen.
Okay, this is a PDF.
Yeah, it's a PDF. So
go to window in the that top menu panel.
Yeah, okay, one second.
You have seen file, edit, view, sign window.
Okay, over here.
And
yeah.
Okay, not there. Okay,
no,
go to
there.
the view.
View.
Yeah. And
full screen
then
mode. Yeah, thank you so much, sir.
Yeah. Yes, sir, you can go ahead.
Okay. Thank you, first of all, Dr. Francis, for inviting me. Without much introduction, actually today morning in the plenary session, Dr. Chenoy gave a glimpse of the sea level rise with a couple of slides. Our own work, actually, my own work. But now in this, what I am trying to, next slide, please. Next slide, please. Yeah. Okay. Yeah. So first of all, I need to introduce the topic. Many of the students may not be familiar because with the topic. So little bit of physics of it, and then variability, and how what is the natural variability, etc. So basically, you have to. Everybody knows that ocean surface undergoes oscillations or fluctuations over different time scales. For example, everybody might have seen, those who are living in the coastal side might have seen surface waves as well as tides in the ocean. and they are periodic fluctuations or oscillation at a short period time scales. Okay, so what do you mean by sea level rise? It is not a, what is the thing? Basically, one has to define what is meant by mean sea level. So then only we can talk about it. And those things come in the next slide. Next slide, please. Yeah, these are, for example, typically a picture of the surface waves on the ocean. And later in the afternoon, Dr. Sanil Kumar will be giving an in-depth talk on that. This is only to give you a feel that, see, the sea level, what we are talking about, what kind of variabilities are present on the ocean surface. Next one, please. Next, yeah. Then tides in the ocean. Tides are actually known since the time of Galileo or even before. So people knew that this astronomical forcing by the moon and the sun and the rotational effects of the earth generates tides in the open ocean, and they are propagated to the shallow regions when what we see as tides in the ocean. That these are again extremely periodic motion, because astronomical movements are very periodic. So what is to be remembered is that these tides are not forced by the climate as directly. So the processes in the atmosphere do not really affect, for example, winds or solar radiation do not affect the tides in the ocean. Next one, please. Yeah, say for example, this is the typical observed tides along the Indian coast. You can see they are not the same everywhere. This is actually, I am only introducing the topic to get the feel of the things. Kochi, for example, tides have very small amplitudes. Okay, for example, whereas Mumbai, where most of the participants are living, you can see the large tides up to 5 meters. And especially if you go to the beach on a spring tide, okay, during new moon or full moon, you can really see the large oscillations and extent of flooding on the beaches during the high tide, especially during spring tide. Then this is Marmagoa, of course, where I live. I mean, close to where I live. Veraval is again north of Mumbai. There again, it is lower than that of Mumbai. That is mainly because these variations are mainly due to the continental shelf width. Those who know basics of geomorphology, the continental shelf width increases northward from the south of the thing. So when there is a large continental shelf, for example, of Mumbai, then the waves coming from the tides, tidal waves coming from the open ocean, they get amplified because of some of the physical mechanisms such as resonance, etc. for the thing. So this is for the curiosity. So essentially what I want to say is that there are tides, there are waves on the surface of the ocean. Next one, please. Yeah. So the mean sea level, what we going to talk in this today's talk is the mean sea level. Mean sea level is the average sea level over a sufficiently long time, after filtering transients. Means transients such as these tides and waves are surface waves, gravity waves. They are filtered. I mean, there is a procedure to do that. And if you take an average, that is the mean sea level. So this mean sea level, if you see the right side, you can see some of a pictogram. So on the top, what you see is the thermometer with the red color and all. That is actually, it is indicating thermal expansion. Okay. So in the below that, it is showing mountain glaciers. Again below, if you see, you can see a picture of the Greenland. Then you can see the Antarctica. And the last is that actually it represents the terrestrial water storage, because terrestrial water storage. So these are the processes which can affect the mean sea level. For example, thermal expansion. everybody knows that if the ocean becomes warm, there will be an expansion, thereby mean sea level will rise. And then, of course, mountain glaciers from Alps, Himalaya, or whatever it is, Greenland, Antarctica, and terrestrial water storage. Greenland and Antarctica, all of you may be knowing, but terrestrial water storage, it means there are many anthropogenic activities such as dam building. That will affect the natural flow of water through rivers. That also can affect it, thereby from rivers going to the ocean. So that contribution is relatively small, but it is also not insignificant. Next one, please. Next slide, please. Yeah, so this is already I mentioned, there is something called thermal expansion or volume expansion as basic physics, as well as melting of glaciers and ice sheets from Antarctica and Greenland. This is fairly well known to everybody. Next one, please. Yeah, this is somewhat little bit more in detail. For example, here everything you can see. For example, there is also a hydrological cycle that affects water in the ocean. Then there is also something you can see left side, it is written as GIA. That I need to mention it actually, glacial isostatic adjustment. This is also known as post-glacial rebound. Earlier it was known as post-glacial rebound. That is because when from the ice period, ice age, when the ice melts, so there will be changes for the land because of the gravitational effects, and also that will also cause changes in the level actually. So then there is something called subsidence that is very much relevant for us. We will come to that in the next slide. Then okay, there are other processes like ocean circulation. Ocean circulation from will cause changes in sea level, but those changes are actually, you can say, ocean circulation mostly they may take place in a time scale of a season, for example, or time scale of interannual, year to year. So those time scales are due to various oceanographic processes. Then here right side you will see some of those ice sheet processes which will cause changes in sea level. Again, when ice sheets melt, there will be water is added to the ocean, mass is added. Whereas there other thing, thermal expansion, it is a volume expansion. There is no mass added, extra mass is not coming because this is from continent. Then again below you in a circle you can also see a representation of the extreme sea level. Extreme sea level actually means there is then an extreme event. For example, what is the maximum level? It is not the mean sea level. It's the maximum level. For example, it can happen to at a given place. So, as I mentioned earlier, during springtime, suppose there is a storm during springtime, there will be some water level rising or falling. So those also will cause the extreme sea level. Okay, next one, please. Next slide. Yeah, so this is also, that sea level measurements are generally done through tide gauges installed in harbors. And they are actually available. What is interesting is that they are available go way back in 1870. Okay, because these instruments started working since the industrial period. Just like thermometers, temperature measurements are available since the end of that 19th century. Approximately at that time onwards, sea level, people have started monitoring sea level because scientists had a curiosity. Then it was needed for navigation purpose, etc. Then only it is what is the most interesting thing is that it became useful now for the climate studies, these data. Okay, so that which was never thought of 100 years or 150 years ago. Then since 2 decades, we have continuous measurements of satellite measurements on the sea surface area height variations. So basically earlier in 1990s, there were many skeptics about the sea level. They told, okay, tide gauges are installed in a few selected points along the coast, and how you can conclude that sea level is rising and all that. I mean, 20 years before. Now, but since satellite data also started coming, they are giving consistent results with those of tide gauges. Those kind of skeptics got sidelined, and there are not much. I don't hear much about those kind of doubts whether sea level is rising and all. Again, I repeat, sea level, I mean, it is a mean sea level, which I mentioned in the beginning. It's an average sea level over a sufficiently long time. Next one, please. Next slide. Yeah, this is taken from, again, one of our WCRP report, which I was writing a small white paper, I can say. This is actually the places where the tide gauge stations are there. What is important to note is that tide gauges measure, these are instruments, ground-based instruments. So they are installed either along the coast or in the islands. So you can also see some of the islands and all. These colors show, blue color shows 40 years plus data. So these data are available. Anybody who is curious to look at it, can always get the data and look at the, analyze them actually. So there are few stations in the Indian Ocean where the data are available for a long period, 40 years. Some of these gauge, and also I need to mention that when there was a tsunami in 2004, lot of interest generated. Even tsunami can be measured through tide gauges because the sea level will have a sharp fluctuations. So lot more tide gauges got installed or rather upgraded in the Indian Ocean. Next one, please. Next slide. Yeah, this is from the satellite data actually. This is a global mean sea level. Global mean sea level means globally averaged mean sea level. But I can also add that there is a little bit gap because these altimeters, they don't measure, don't get data beyond 66° north. So it is a quasi-global, covering most of the globe. In the polar regions, they don't measure on either side, northern hemisphere or southern hemisphere. So it shows that a trend of about 3.4 millimeter per year. So this is, next one, please. Next slide, please. Yeah, now let us go specifically with Mumbai, and there are two tide gauge data I'll show separately. One is that Mumbai, there is this is during the historical period. Generally, the tide gauges along any part of the world give a trend of between 1 and 2 millimeter per year. So Mumbai, we are getting 1.2 millimeter per year. It is slightly lower, but it is consistent with the global estimates. But there are many lot of explanations regarding that. I mean, there are other processes that is causing that thing that we may not have time to get into that thing. So, but basically it is consistent with the red color shows the satellite data of Mumbai, slightly far from Mumbai, because satellite data, they are not reliable exactly at the coast because of land contamination of the thing. So we have slightly far from the offshore of the thing, and gives again this period, they are consistent even at this point. Next slide, please. Next slide. Yeah. Oh, so I forgot to mention, Mumbai has a data of more than 100 years. It is something great actually, because only tide gauge in the tropical region having this long data. This is at Diamond Harbour. Diamond Harbour is at Calcutta. Actually, here you can see a very sharp increase. If you see the number, in terms of number, it is about 5 millimeter per year, plus or a little bit, around 5 millimeter per year. Why is it so? Little more than 5 millimeter. Why it's so? So earlier, some of the research workers thought, wrote papers also saying that, oh, this data may not be consistent. Why it is so giving such a sharp thing? but that is not true. What we found when we did the analysis is that the similar trend is seen in all the tide gauge data in that region, that is including the Bangladesh tide gauges. So Bangladesh tide gauges have shorter period data. Here we have sufficiently 40-50 years. So the reason is that some other reason. That is because these Asian deltas are undergoing subsidence or sinking. So that causes when the land is undergoing subsidence, that will also because the tide gauges are kept on the land. You have to keep it in mind. So this problem has been noted in many ports in Asia, for example. So particularly in the Indo-Gangetic Deltaic region. So this is, for example, what it practically implies is that these regions are much more sensitive to sea level rise, because this subsidence will continue. This another process, actually geological process, you can say. And whereas this sea level rise is driven by the physics of climatic processes. Next one. Next one, please. Yeah. So basically, what are the global mean sea level rise trends? So about 1.8 was reported in the past century. I mean, historical tide gauge data. And during the last 2 decades, it has became 3.2. Current estimates show again a mean sea level rise of 3.7 millimeter per year. What all this means is that there seems to be an acceleration. Though the last 100 years it was slightly less than 2 millimeter per year, it is clearly showing much more than that now. So is it an acceleration? So many people try to estimate these acceleration values, and especially with the satellite altimeter data. Altimeter data, satellite data, one advantage is that there are no gaps. See, whereas the land-based instruments, sometimes they don't function, there are some gaps, so it becomes difficult to really determine the acceleration, because one has to do a second order fit and all, it becomes more tricky, sensitive. But anyway, that is a more scientific problem, whereas here the sea level is rising. These numbers are very consistent across the globe. Next one, please. Next slide. Yeah, these are actually taken from our earlier paper. So this is only to show that actually morning also this slide was shown. So you can see from different ports in the North Indian Ocean with a particularly significant trend at Diamond Harbour, Calcutta. This is, as mentioned already, it is due to the partly due to the subsidence of the delta. Next one, please. Next slide. Yeah. So then altimeters gave another advantage, because what happened is that tide gauges, as I mentioned, there were only point observations. So one could even think there are only few points, whether it is sufficient to give a global picture. But now the altimeters, they cover, they give a spatial trends. Actually, again, the point device, wherever data is available, they are consistent. The trends obtained from the altimeter as well as tide gauges, they are very fairly consistent. So the color scale you can see here, the yellow color is between 3 to 4. Most of the region it is like that. Northern Bay of Bengal it is slightly more that there, because there are actually here at least I may need to mention that there are some regions where variability, one calls climate variability, that is the interannual time scale. Year to year there will be some variability because of phenomena like ENSO. People might have heard of El Nino and so and all. Also there is another one, oceanographers use the word IOD, Indian Ocean Dipole Mode, etc. All these climate variabilities, they cause some changes from year to year. So altimeter data, the one difficulty is that now it started only in early 90s. So only we have 20 years data or 25 years data. So sometimes there one has to be a little bit, some regions, if it is slightly more, it means it has, most of the things are but it can be explained because from the known variabilities in other regions based on also numerical model simulations. So, but if you see the average for the region, it is very much consistent with the global estimates as well as point wise. If you check, it is consistent with tide gauge observations, trends obtained. Next one, please. Next slide. Yeah, future projections are again based on climate models. It varies for depending on the scenarios. Starts from 0.2 to up to 0.5, 0.55 for low emission scenarios and 0.6 to 1 meter for high emission scenarios. But these are, I would say, these are numbers indicative. But there is an important message from this is that actually I have not shown really the curve. These projections for various scenarios do not vary much up to the year 2050, but then they start diverging. So that underlines the message that you see for some period, for some more period up to 2050, the sea level is still not too drastic. Actually, even for emission scenarios are high. That is well, what the probable reason or most likely reason I would say is that many of those, so some of these melting processes, Greenland or Antarctica, which have started also and even to reach in many other parts of the globe, other oceans, it takes time because in ocean the time scales are slow. So adjustment of the ocean, so we call baroclinic adjustment of the ocean, that takes place 50 years or much more. So that is one of the reasons for this difference as far as the sea level is concerned. But anyway, even this low emission scenario numbers are not very encouraging. Next one, please. Next slide. Yeah, the impacts, people know that this main problem is coastal inundation, saltwater intrusion and all. And particularly there is a big concern of the low-lying islands. The islands low-lying means their height is from the mean sea level is not much. Islands in the Pacific Ocean, etc. So what is being experienced right now? There is, okay, future telling is one thing that we will see in the next slide. This cartoon is light and it is not that much visible. Then what it shows is that basically the same message. So I have written it at the top. Next slide, please. Next slide. Yeah. What is actually being experienced practically, though because it is a small increase in mean sea level is not experienced. What is seen, especially in some of the islands, is that flooding events are more right now. Because earlier an extreme sea level event occurring at a place was happening, say, once in 100 years, once in 50 or 70 years. Those things are happening much more frequently, in once in 10 years or even less. So that is right now the concern of as far as extreme are. The sea level rise is cannot be viewed in isolation. For example, along with that, there are also wave activity. There is also surge activity. So when these things put together, what matters is the total sea level, what we experience right at the coast. So that is being increasing. These things are very much reported from the Pacific Islands. Next one, please. Next slide. Yeah, this actually is slightly, to me, it looks slightly exaggerated story. But anyway, this is for the Mumbai region. There was a paper in 2019 by Americans actually. Nowadays, people are using the GIS techniques. You know that geographical information system can be used for knowing the flooding area, and you can project the sea level and then. So, but many, why I want to show this particularly to students that these figures, one may feel that, okay, this much area will get inundated because of sea level rise and all. That is not true actually. This has been calculated that for the annual maximum sea level, annual maximum sea level actually means the maximum sea level that one can observe in a year. If you look at the data for 1 year, what is the maximum? So that may be due to the maximum spring tide or surges activity, surges or even waves, sometimes raise by 50 centimeter, 1 meter. On top of it, you have the sea level rise, so spring tide. So those are the things which one is worried, and that is seen in many places. So this is calculated. This is if such an event happens once in a year or twice in a year, such a maximum thing by 2050. I mean, with the projections of mean sea level rise for that year, how much area will be inundated, low-lying areas. So students may please note that this is not a picture. This is written by Ben Stokes. Actually, he only provided me this slide from New York. If anybody. So this should be interpreted with caution. Next one, please. Next slide. Yeah, these are some of the islands. You see by aerial photographs, you can see that one of the Pacific islands is very low-lying. Their flooding has been observed to become more frequent. And some of the reports, some people start moving to other places, etc. There are reports, but how much percentage is actually is there still not very clear. But even this picture itself is scary, because if you have a strong extreme waves or storm surge, on top of it you have an additional contribution from sea level rise, what will be the state? Next one, please. Next slide. Yeah, then probably the last message is that what is important here is that morning Dr. Chenoy also was showing about the greenhouse gas emissions, zero greenhouse gas emissions, and by some 2050 or 2000 by developed countries, 2070 by other developing countries and all. But even if these greenhouse gases are curbed or even stopped, sea level will continue to rise for centuries. That is the key concern here. It is not that today, right now, if you know that sea level rise alone is that scary, but the overall, as I mentioned, the overall contribution from various factors, and even because the reason here, the physics is that whatever global warming heat that has gone into the ocean, that will remain there. That there is so it will slowly heat the ocean and also melt the glaciers, so sea level will continue to rise. And yeah, I am towards the last point. Scientists working on the impacts and vulnerability. There is a separate group in the Intergovernmental Panel on Climate Change, where one group is working group one is on the purely on the science aspects, and second group is on the impacts and vulnerability. But what is felt, what has been reported recently is that for low-end scenarios of emission, so if emissions are controlled, then adaptation approaches provide good solutions for the coastal zone. Adaptation means, as you, I think I need to mention it. There can be 2-3 possibilities adaptation. One thing is that hard structures like seawall and all, which is not at all desirable because it has got a lot of environmental impacts like beach erosion, etc. But it may be some places like Netherlands and all, it may be required where it is so low lying. In some critical regions, it may be required. But most of the soft approaches, such as restoration of beaches or those things, that may work only for the low end scenarios. In future. And then of course there are natural ecosystem based approach, that is the mangroves. That of course is a very useful thing. So these are the adaptation practices employed, and mostly for the coastal zone, adaptation works to a good extent, as you mentioned, if there is not too much of extreme scenarios of sea level rise. Okay, thank you. I think.
Thank you, Dr. finishing it well on time. So, any questions? Any questions to Dr. Unnikrishnan?
Yes, sir. There is one question in the chat box.
Yeah.
By Sriraj. Why satellite derived sea level data not available beyond the north of 66° N? Is that due to presence of sea ice? That is a Sriraj question.
No, it is mostly due to the track is designed such that it will cover only this region. Tracks.
These are measured by polar orbiting satellites. So they will be orbiting mostly in the up to mid latitudes. They don't cover the poles, that's why. Any other questions? Okay, so I have a few questions. See, you said if you look at the sea level projections in the near future, like up to 2050 or so, the trends are not so alarming. Is it due to the uncertainties in the near-term projections, or it can be believed? So there are a lot of uncertainties in the near-term projections.
No, as such, no. As such, because some of these, as I mentioned, some of these processes of oceanographic processes in redistributing the melted water from Greenland or Antarctica, it takes place in a larger time scale. So if there is, even if there is a, say, let us say there is a big melting in Greenland, for example, that has to be effective all over the globe. It needs a time scale, oceanography. Some of those things have, that is already going on, but so even if some drastic thing happen to redistribute the water, extra water added, it takes time. 2050 is not very far away, only 25 years.
For example, the regions in the North Ocean, for example, so they are not affected by the ice melt, the polar region. So whether the Indian region will get affected by such uncertainties?
No, actually the projections, mostly they, as you know, you are a modeler, you know better. But basically the projections are not varying that much in regionally. So global projections are more global. Though people have come up with regional projections and all, there is much more uncertainty in the regional projections. So it will be better to, I still feel better to stick to the global projections, which have more uncertainties, are much more well defined.
Okay. Thank you, Dr. Unnikrishnan, for an excellent talk and on a topic of your topic close to your heart. So thank you so much. Now I invite the second speaker, Dr. Kunal Chakravarti from INCOIS. So he will be talking on understanding Indonesian carbon dynamics. So Dr. Mansi, please introduce you.
Yeah. Dr. Kunal holds PhD in mathematics. Currently, he is working as a scientist E at INCOIS at position in the Ocean Observation and Modeling and Data Assimilation Group. His research focuses are on ocean modeling, ocean dynamic, biophysical interaction, and biochemical cycle of carbons in ocean, especially Indian Ocean. Till today, he has published 63 research articles in various national and international peer-reviewed journals. He has mentored both masters and doctoral students. Under his mentorship, total 4 candidates has been awarded PhD till now, and I'm sure the list will be upsurged. He is proud recipient of INSA Medal of Young Scientist 2017. Even he has received Ministry of Earth Sciences Young Researcher Award in 2016 in the field of Earth System Science. Today's his lecture is focused on understanding the Indian Ocean carbon dynamics. Over to you, Dr. Kunal Chakravarti.
Thank you, Dr. Mansi. Hope I am audible.
Yeah, you are audible.
Thank you. Okay, so let me first share my screen. I think it's visible.
It's visible.
Yeah, it's fine. Yes.
Thank you.
Okay. Okay, so good afternoon to all of you. Before starting my talk, let me first thank the organizers for providing me an opportunity to present our research in today's symposium in connection with World Oceans Day. And at the same time, I would like to acknowledge my collaborators, specifically Dr. Vinu Valsala and Dr. VVSS Sarma. And the results what we are going to present, I'm going to present today, that's basically the collaborative work. And in the subsequent slides, I'm going to talk about the understanding of Indian Ocean carbon dynamics. So specifically, I'm going to include, or rather the overview of my talk is something like this. I'm going to talk about the United Nations Sustainable Development Goals. I will briefly touch upon this, and then specifically it will be focused on the goal 14, that is life below water. And thereafter, we are going to talk about a specific goal, which is included under goal 14. This is ocean acidifications, which includes the marine biochemical carbon cycle that again divide into global ocean carbon cycle and then regional, specifically the Indian Ocean carbon cycle. Then I'm going to show the results of an experiment that is being done in collaboration with Dr. Vinu Valsala of IITM, that observation system simulation experiment. The results what we have got, that I'm going to show, that will give you an understanding like what are the critical needs of having these carbon measurements and what are the places where actually we can first go for this kind of observations. And then I'm going to show about this physical biological interaction in the Indian Ocean, the modeling approach. And then finally, I will finish with recap 2, an assessment that is being conducted to see how good the models are actually doing in terms of simulating the carbon cycle. So that's the overview. To start with, if we see this slide, this actually describes the UN 2030 agenda. So what happened in September 2015, the General Assembly of UN, they adopted this UN 2030 agenda, which includes 14 sustainable goals. And if you see, these are the specific goals that's basically were adopted to be implemented within a period of 15 years. And then, 17 goals, and specifically they have mentioned about 169 targets, and at the same time there were 230 indicators. In this specific talk, we are going to actually concentrate on the goal 14, which talks about the life below water. So if we talk about the goal 14 itself, it's basically has 10 targets and 10 indicators. So if we concentrate on is that sustainable development goal 14, which talks about the conserve and sustainability use of ocean, seas and marine resources, again, that specific goal, as I told, it is basically divided into 10 indicators. So which includes actually marine pollution, and then protection of coastal ecosystem, ocean acidification, and then subsequently it lists other specific indicators. Now, out of these 10, we are going to actually see or more focused about the ocean acidification, that is 14.3. So if we see 14.3, and before going into the more on the ocean acidification or the specific 14.3, which includes the implementation of that specific goal, let me tell you, like these are the specific targets, that 14.1, 14.2, 14.3, 14.5, 14A and 14C. These are the specific targets where Ministry of Earth Sciences is actually the nodal agency, or the government of India actually designated MOES as the nodal agency for implementing these specific targets. Obviously, there are other agencies who all are working with Ministry of Earth Sciences towards implementing that, but MOES is designated to be the nodal agency. So categorically, if we talk about 14.3, that target, so it is basically minimize and address the impacts of ocean acidification through enhanced scientific cooperation at all levels. So it talks about the basically collaboration at all levels to minimize and address the impacts of ocean acidification. Now, in terms of how do we see that that specific target has been achieved, in order to establish that, if you see this document, Sustainable Development, UN Sustainable Development Goals document, they have clearly mentioned about the global and national indicators. So which actually talks about, if we see the global indicators, it talks about the average marine acidity measurements at agreed suite of representative stations that can be anywhere in the global level. It may be in Indian Ocean or maybe any other places as well. And in terms of national indicators, specifically, we have agreed upon to find out the coral health index within the Indian EEZ. So that's basically the national indicators in terms of that specific target. So now today's talk, I'm going to show basically what are the specific work or the research we are carrying out towards implementing the target 14.3 under the Ministry of Earth Sciences. So if we talk about ocean acidification, what is ocean acidification? It's basically, if in order to understand that, you need to actually understand the Indian Ocean carbon dynamics, and which is actually leading to this kind of an acidification scenario. So if I talks about the Indian Ocean carbon dynamics, the first thing which comes is the air-sea CO2 exchange. And it is well known that ocean plays a significant role in regulating the amount of CO2 in the atmosphere. Even today morning's talk, Dr. Chenoy has already pointed out like how ocean is actually playing a critical role in mitigating this kind of hazards, and specifically how it is connected with day-to-day life. Now, what is happening if the atmospheric CO2 is increasing? Then subsequently, since it is counterbalanced by the oceanic uptake, oceanic uptake will be increased. And if oceanic uptake has been increased, then it has a considerable impact on the marine biogeochemistry of the ocean. So finally, it is going to change the pH, and it will lead to an alkalinity imbalances in the water column, across the water column, which is actually commonly referred to as the acidification. So please try to understand one thing. Acidification means it doesn't, it's not the fact that ocean will become acidic. It's basically the relative. So ocean will become relatively acidic, or the ocean pH will come down, which will have adverse impact on the marine ecosystem. So in order to understand the status of ocean acidification, what are the specific questions that can be addressed, or what we are trying to address are something like this: these open ocean and coastal environments, what kind of scenario at present, and we are trying to identify the drivers which is actually leading this kind of a scenario. And then at the end, we need to examine the impacts of this kind of relative acidification on the marine ecosystems. So that's the primary goal. Now, in order to describe through a cartoon how this upper ocean carbon cycle works, this is specifically, you can see this air CO2 flux, ARC CO2 flux. This is when this exchange is taking place. There are two pumps which are actually responsible. One we used to call is solubility pump, another is known as the biological pump. So what is happening when the wind is actually forcing the ocean, or rather in terms of, we can tell, when the momentum is transferred to the ocean, then at that point of time, specifically the ocean properties in terms of physical properties and biogeochemical properties, these are actually changing with time, and this is been happening in the spatial and temporal scale. So if I get into that specific process, what is happening, how do we get air CO2 flux? The first thing is, if I take a given volume of air, it has a partial pressure of carbon dioxide. So that what is called the PCO2 of air. Similarly, for a given volume of water, there is a partial pressure of carbon dioxide which is dissolved in the water. So again, it is, if we call it as PCO2 water, then the difference, that is del PCO2, if we see the PCO2 of air, if I subtract this with PCO2 of water, it will give the del PCO2, which is nothing but this air CO2 flux. So it is very easy to understand, if your air PCO2 is having higher pressure than the water, then it will come to the ocean. And if vice versa, if your oceanic PCO2 has higher pressure, then it will actually go to the atmosphere. So that is the process which is continuously happening in the ocean surface or in the boundary layers. So these processes are actually tightly linked with the solubility and the biological pump. So what is happening when the solar insolation is there, and in the upper ocean, which is actually the place where ocean is very productive. So in the presence of solar radiation, if you have sufficient nutrients over there, then in presence of inorganic forms, that is, it may be DIC or maybe in other inorganic nutrients, specifically this inorganic nutrients is actually transformed into the organic matters. So inorganic carbon is actually transformed to the organic carbon. So once this organic carbon is transferred in the process of chlorophyll through this, or we can say the process of photosynthesis, then finally this production is taking place. And once this production is taking place, with time, it is basically coming down towards the deeper layers. And this is the process by which actually carbon is first getting transferred or sequestered into the form of an organic form, and then coming towards the deeper layers. But you can see, if in the presence of nutrients, if it's a one-way process, so always if nutrients is being utilized and organic from carbon is coming down, then at some point of time there won't be any nutrients available in the upper layers. But it is not happening like that. It's basically a cyclic process. So what is happening, the ocean mixing, upwelling, entrainment, these are the processes which is actually remineralize that specific organic matters. And in the process of remineralization, again these organic matters transform into an inorganic form, and it is again going towards the euphotic zone or towards the near surface layers. So it's a cyclic process which is actually taking place, and that is leading to this kind of an ARC CO2 exchange. So it's a complex process, and all the factors needs to be taken care of in order to simulate that specific quantity. So in the subsequent slides, I'm going to show you what are the requirements in order to get a better simulations. Okay, so now if we just see about the global ocean carbon cycle, what about that? What exactly we know as of now? If you see this curve, the right hand panel, there is a curve which is famous, known as the Kalin curve. It's basically the data being used from Mauna Loa laboratory. You can see the atmospheric CO2 is constantly increasing, and the data is available from 1957 to 2021, even 2022. You can see there's a constant increase of atmospheric CO2. Okay, and it's an exponential increase. So what is happening every year? We are actually emitting 10 petagram of carbon globally. Now, if we say 10 petagram of carbon, if we are emitting regularly, out of this entire 10 petagram, it is not actually basically remaining in the atmosphere. What happens? 25 to 30% of it actually being sequestered by the terrestrial biosphere. Another 25 to 30% is actually absorbed or uptaken by the oceans. So another maybe 40 to 50% only it is remain in the atmosphere. So if you can imagine, if these processes are not happening, the situation would have been much worse than the present situation. So based on the estimates, what you can see from the pre-industrial level, we have actually, the global ocean has already taken almost 165 petagram of carbon. And based on the global carbon project, 2.5 petagram of carbon, it is the contemporary sink that is being estimated as of now. So that's the global scenario. If we talk about the Indian Ocean scenario, there are several estimates that are available. Based on that, I would like to first point out the percentage that is actually being uptaken by the Indian Ocean only. Indian Ocean, if you compare with the Pacific Ocean and Atlantic Ocean, it's basically a small ocean if we compare with Atlantic and Pacific. However, in terms of global sink, you can see based on the estimation, 16% of the total carbon that is being actually uptaken by the Indian Ocean. So you can see the impact will be much, much worse in the case of Indian Ocean. So based on the estimates, you can see this table. There are several papers that's talking about this particular quantity, like per year, what is the specific carbon that is being actually uptaken by the Indian Ocean. So that is specifically the amount that is listed in this. The question is, whatever estimates we have done, whether those estimates are reasonable or we need to actually go for a space estimate in order to have a better understanding of, based on the better understanding on the system. And at the same time, if we see the number of observations that are available in the Indian Ocean based on which these specific estimates are carried out, that is specifically another problem that we need to actually address. So you can see in the subsequent slides the number of observations that is being available globally. So these are the curves you can see from 1957 to 89. This is the availability of cruise tracks which actually measures these carbon variables. And you can see the Indian Ocean, the coverage is not that good. 1990, even the coverage is little better, you can see over there. From 2000, you can see again, this coverage is very poor in the Indian Ocean. Even from 2010 to 17, the coverage is again very poor. And so this is the condition of or the availability of data in terms of carbon observation in the Indian Ocean. Now, if we just club all together, like from 1957 to till date, or from 2019 or 2020 up to the SOCAT version 3, this is the total data that is being actually available with us. And if you see this below time series, here you can see the number of observations in the y-axis and year-wise how much observations we have actually carried out. So you can see from 1990 to 2000, this specific decade, we had a good number of observations. However, before that, we don't have any observations, and after that also the number of observations are not significant. So in terms of numbers, if we can see is something like that. Total database, this SOCAT version 3 2020, this SOCAT database is actually consists of 95 million quality controlled surface ocean PCO2 measurements during 1970 to 2019. However, out of that, Indian Ocean, if we consider Indian Ocean in this domain, 30 degrees east to 130 degrees east and 40 degrees south to 30 degrees north, it shares only 0.8 million. That's the total quantity. So hardly 2.8% we are actually contribute into the SOCAT database. So it's evident that the number of observations what are available in the Indian Ocean, that is not sufficient to have this kind of estimates. Now, what to do in order to have better observations, or rather, if we have the necessary resources, what are the places where actually you can go for this kind of observations? So that actually another questions that that needs to be answered for getting into that specific scientific problem. So what are the specific ways to get the observations, or something like you can have the sensors that can be mounted to moorings, the way you can get the time series on a specific location, or else you can go for underway sampling so that you can actually attach those sensors to the hull of the ships, maybe the commercial ships, and then you can actually go for this kind of underway samples for making those observations. Apart from that, bioargo floats can also be used, which are actually basically installed with pH sensor that can also be used for getting this kind of observations. Apart from our regular shifts that is basically making those observations. So these are the possible ways. So if these are the ways, we are actually trying to answer what are the potential areas where we should first go for observations. So in order to answer that question, that observation system simulation experiment that is being carried out. And in order to carry out this experiment, what we have done, we have actually divided the Indian Ocean in specifically that total 8 bioprovinces. And that bioprovinces are actually taken based on the Longhurst data that is actually globally accepted. So based on that, we have divided Indian Ocean into 8 bioprovinces, and then we have carried out that specific experiment. And the result which we have come, that is states that the moorings, first of all, the moorings what we have considered in these experiments are the existing Rama and Omni moorings. So whatever existing networks we are having, where what are the specific moorings which will give us better observations, or the observations which can constrain or reduce the uncertainty more in the model, that is basically addressed in this specific problem. So you can see this slide here, actually this deep blue color moorings, these are moorings. If we install this PCO2 sensor in these moorings, like seasonally if we talk DJ winter monsoon, this is the place, the most desirable place. If you can put these sensors, it will give you the data that can actually reduce the uncertainty in the model simulation. Similarly, for March, April, May, these are the locations. So based on that, specific experiment has been carried out, and the results are actually presented in this slide. So we have actually come up with the locations where you can go for this kind of an observation, which is categorically for a time series observation, specifically on a location only. Now, if we talk about this bioargo floats, it's a similar, it's a different kind of observation than the mooring observations. The bioargo floats, it is actually drifting with the ocean currents. So what we have assumed, if we have a 10 degree by 10 degree box, the Indian Ocean can be divided into a 10 degree box. And if we have that in 1 year, if we have a trajectory, at least one trajectory in this specific 10 degree by 10 degree box, then the specifically which specific locations is going to be better to reduce the uncertainty in the models, that is being actually shown in this specific slide. So again, you can see actually these are the areas which is coming closer in the case of bioargo floats as well. So these are the areas, obviously this is also based on the seasonal division. So these are the areas which will provide you a better chances to reduce the uncertainty in the models. Now, if we go with the underway sampling, then the number what we have done, actually this is being carried out for 2 months, that is January and July. You can see the ship tracks that is being numbered here. This is number 1, that comes number 1, this is number 2, and subsequently you can actually see the numbers in the upper 2 panels itself. And if we talk how much it is going to basically reduce the uncertainty, you can see this specific below plot. Here you can see for in the month of January, for the ship route 1, first ship route, it is going to reduce 70%, almost 70% of uncertainty in the simulation. Similarly, for 2, it is something like that, and then it's going up to the 10. These are all actually commercial ship routes that is being taken from a published literature. So that specifically talks about like what are the ways we can actually go for this kind of underwater sampling into the system. Then, so up to now, what we have actually discussed, that is based on the observations. Now, if we see what kind of models that is being employed to simulate this specific ARC CO2 flux or the Indian Ocean carbon cycle, what we have done at INCOAS is we have developed a regional model that is coupled with an ecosystem model which is simulating this Indian Ocean carbon dynamics. And that modeling system is actually developed to study the evolution of biogeochemical state of the Indian Ocean at both long and short time scale. So this model is regularly generate daily analysis of biogeochemical state of the Indian Ocean, which includes these nutrients, chlorophyll, dissolved oxygen, and the carbon fluxes. So that's the schematic which actually giving you an impression the domain of the model. Okay, and apart from that, we are having some high resolution models also, which are running for the operational purpose. So based on that, if you see, this is the simulation that is being carried out to find out the air CO2 flux. See, as in the previous slides, I have already shown from 1960, if we see the observation, atmospheric CO2 observations, from 1960 to 2020, there is an exponential increase in terms of atmospheric CO2. So it is already well established that PCO2 is increasing. Now, if this is in increase, oceanic PCO2 and atmospheric PCO2, if we are going to simulate, and based on that, if you want to find out the air CO2 flux for a longer period, that is from 1980 to 2019, for last 4 decades, actually, we have carried out a simulation. And based on that simulation, what we have found that the present rate of change is 0.007 petagram per year. And this exercise is also carried out to participate in a global exercise, which is known as the recap. That I'm going to show you a little bit in the subsequent slides. And this is the model simulation. This particular slide is actually showing the model simulations and how with time the model is simulated this temperature and dissolved inorganic carbon and air CO2 fluxes from 1980 to 2019. So that's that simulation is actually showing this. Now, if I talk about the recap, this stands for Regional Carbon Cycle Assessment and Processes 2. That's the recap 2. Recap 1 is actually launched sometime in 2012. That time, this global community, they have carried out one exercise which includes all global models which actually coupled with this kind of an ecosystem model who are capable of resolving these carbon cycles. So they have actually taken all those specific models and they made an exercise to find out which models are actually doing good in simulating this carbon cycle globally as well as the regional oceans. So that time only global models were participated, and 2013 when these results came, they have observed that none of the global models were capable of actually resolving the Indian Ocean carbon dynamics, and specifically the Northern Indian Ocean. And that time they have actually decided to include regional model simulations in the recap 2 exercise. So that's the way we have actually come into the pictures, and this time we have actually submitted our data for this exercise, which is actually present this is going on. So if you see the distribution in the oceans, how they have actually made, you can see the global models that will be actually be validated in the globally for all the entire area. However, they have categorized Southern Ocean, then Pacific Ocean, Arctic, Atlantic, and India. So this green part, we have submitted the model simulated output for this green specific marked area. And ours, that Indian Ocean chapter is going to have that comparison result soon based on this specific domain. And this exercise, global models as well as regional models, they are going to be part of that. And we are going to see which models are actually doing good in simulating the carbon dynamics, specifically in the regional oceans. Now, in terms of PCO2 observations, actually, these are specific 2 areas where INQUIS is now actually focusing, and you can see we are going to deploy 2 buoys. It is actually in the final stage. In Kochi and Vizag, we are going to deploy 2 water quality buoys, which is actually equipped with PCO2 and pH sensors. So we are going to have time series observations from these specific buoys locations, And apart from that, we are actually going to get all physical as well as ecosystem state variables data on the same locations, which will be extremely important to analyze the processes or understand what exactly is going to make the changes in the like water quality or in terms of acidification. This is one specific process we are actually involved with. Another one is the ECAMSAT. This is another project where the plant, as per the plan, we are going to have this pH and PCO2 data as well. And the glider will be actually operated in this specific track where we are going to have the data from along this track, and that data is going to be analyzed in order to have a better understanding on the Indian Ocean carbon dynamics and its drivers. So this is another initiative where INCOIS is actually playing a major role. So finally, at the conclusions, what we have seen as of now is there's a big knowledge gap, specifically in the Indian Ocean carbon cycle, or rather our understanding on the Indian Ocean carbon cycle. And if I talk about the CO2 fluxes, we don't have enough data to have a better estimate for this specific purpose. So that needs to be basically addressed. And obviously, there's a critical need to understand the status of the Indian Ocean acidifications, though we have carried out some studies, which is actually find out the hotspots where specifically the ocean is relatively more acidifying with time, like Western Arabian Sea and specifically some areas in the northern Indian Oceans. We have identified some areas, but we need to put more focus to have a better understanding, like how what are the drivers and its impact, specifically the impact of this acidification on the marine environment or the marine organisms. That needs to be addressed. Apart from that, the seep track measurements, what actually I was talking about in terms of measurements, there's underwater PCO2 sampling. That is specifically doing good when it's a better choice if we just compare with the time series data from fixed mooring. And the reason is the maximum flux uncertainty in the models, which is achievable from this underwater sampling data is 62%, whereas a fixed Rama or omni-mooring based data can only reduce 30% of uncertainty. And if we can actually go for bioargo based data from ocean, then in that case probably 20 bioargo can actually serve the purpose to have a better data that can be actually reduce the uncertainty into the models. And in terms of the rate of change of regionally integrated air CO2 flux, the model simulated data is showing that the present rate of change is 0.00763 petagram per year. So that's for today. Thank you for your attention. And again, I would like to actually acknowledge my collaborators, specifically Dr. Venu Valsala and Dr. Sharma, for actually immensely contributing in this specific work. Thank you.
Thank you, Dr. Kunal.
Welcome.
Finishing the talk well in time. So, any question to Dr. Kunal? I don't see any questions in the chat box also. So, I have a few small questions.
Yeah, please.
You said the 16% of the carbon uptake.
Yeah.
Of the global carbon is by Indian Ocean.
Correct, 16%.
So you also said the uncertainties in those data sets.
Yeah, correct.
So what could be the uncertainties in those figures?
Okay, I think it's already there. If you can see, the numbers are already given in terms of the deviation. You can, sorry. Let me just get into that once again. So
it's okay, man, you can.
Just 1 minute. I'm just putting, yeah. So if you see, the number is here, you can see here, actually 0.37. If we see, this is the estimate, whereas 0.06, that's the specific uncertainty which is based on that approach. Actually, there are several approaches that is being taken by the different researchers. You can see like Sarma et al. 2013, then from Takahashi data, then it is actually neural network based estimation that our Swiss group has done, and then again IITM Valsala, they have also done some estimations. So, but you can see the numbers, it's almost varying in the similar range. So obviously that specific data, whatever is available, that is being actually assimilated into the models in order to get this kind of an estimation. However, if you will have better coverage, obviously your estimations will be much better than the present. And based on the Takahashi, that's the globally accepted data as of now, which provides you the estimates. Even if you, what I talk about this recap 2 and all, in recap 1 and recap 2, in terms of observations, they have used this Takahashi and SOCAT. These are the two specific data sets that is being used for validating the capability of the models, how good they are actually performing. So based on Takahashi, you can see it's like 0.24 plus minus 0.12. It's actually in that range.
Thank you.
You're welcome.
See, now in the recent years, the Indian Ocean is warming, right?
Correct.
So do you think the uptake will change drastically?
There will be an impact. See, if the global warming, with terms of global warming, Indian Ocean warming, obviously the stratification, it will lead to this outgassing, whatever is there, it is basically going to reduce. And if it's going to reduce, obviously it will change the ocean dynamics drastically. There's no doubt on that. And if you see this paper, there's a paper which talks about like this global thermal expansion, it's contributing almost 16%, whereas the DIC anthropogenic impact, it's contributing 62% in this specific air CO2 flux variability in the Western Arabian Sea.
There is a question from CEMA.
Yeah.
The question is, what is the contribution of hydrothermal vents? Acidification.
Okay, that's I don't think in term exactly number we can we are in a stage to give you a specific answer on that. See, it's basically based on the estimates. Like if you see this PCO2, what we have actually done, the dynamics is defined in terms of temperature, salinity, alkalinity, and DIC changes, total dissolved carbon changes. So these are the 4 specific areas that is being taken, like the changes which is taking place in this in terms of ocean dynamics, that how much these are going to contribute. So if I talk about that specific factor, it's actually includes in the alkalinity. So when I'm talking about the changes in alkalinity, automatically includes that band. So if I talk about the alkalinity, then contribution is not that significant in terms of DIC or temperature. So alkalinity and salinity, it has relatively lesser impact than DIC and the temperature. That much at least I can say.
Thank you, sir.
Yeah, welcome.
Thank you, Dr. Kunal.
Welcome.
Wonderful talk. And before moving to the next talk, so Dr. Unnikrishnan is available here for Dr. Unnikrishnan? No. Okay, we will move on to the next talk. The next talk will be by Dr. Rajiv Nikam, the former Chief Scientist of NIO Goa. He will be talking on a new, novel topic, a journey in the past, ancient Indian coastal towns at Lothal and Talavera. Mansi, please.
Yeah, thank you, sir. It's my privilege to introduce Dr. Rajiv Nikam. Dr. Rajiv Nikam is a retired chief scientist from Geological Oceanography Department of CSIR National Institute of Oceanography, Goa. He is expert in paleoceanoclimate, paleoceanography, micropaleoceanontology, and climate change. Till today, he has mentored 27 students for their internship and dissertation. He has 249 scientific publications on his name. His 249 scientific publication has got more than 3,000 citations till today. He is a proud recipient of J.A. Cushman Award for Excellence in the Field of Foraminiferal Research in 2022. Only 41 scientists have received this award after its inception in 1979 by USA-based Cushman Foundation. Today, he's going to take us to the journey in the past, focusing on two in Indian coastal towns, Lothal and Dholavira. Dr. Rajiv Nigam, over to you.
Thank you, Mansi. I'm going to share my screen, and once it is visible, please let me know.
Sure, sir.
Can you all see this?
Yes.
And just let me know whether it is moving also.
Yeah, it's moving. It's
okay, very good. The Honorable Chairman and distinguished guest, as well as the students, a warm welcome in afternoon session. Dr. Chenoy started his talk with the background, how and why we are celebrating the World Ocean Day. And since morning, you are listening mostly the present state of ocean, the effect of climate change, futuristic projections, and so on. So now I will take you to the journey, not into the present or future, but in the past. The World Ocean Day may be a recent phenomena, but for Indians, this is well known from the time immortal. The story of Samudra Manthan is known to all of us from our school days. The sea is considered to be the last frontier because it is believed that the mineral resources available on land will be exhausted in 50 to 100 years. And then we have to depend on ocean. We are already dependent on ocean for the easy transport. We are also dependent on the food from the sea. Anything, whether it's energy, it's a food, minerals, sea is always there to help us. But what we are returning to the sea is just in form of pollution. I agree with Dr. Chenoy that let us make our sea pollution free. The sea not only provide the food and other things, the sediment at the bottom of the sea also provide the information how the climate has changed in the past. And with the change in climate, how the civilization and particularly the coastal towns are affected. The study of these ancient coastal towns, in fact, come under the topic called the marine archaeology. So with the varying sea has affected the coastal areas, and let us see how it is. But the very question, why we have to study the past, when everybody is talking about the future, this question is often asked to us, why you people are taking us to the past? In literature, it is said that experience is yesterday's answer for tomorrow's problem. So we know that the one who is proud of his or her culture, rich cultural heritage, always work hard to maintain the high level of civilization and tries to enhance the living standard of the fellow citizens. We in India have another very limited sense of history. How many of us were knowing this magnificent building before this building came on a 100 rupees note? Very few. It's a Rani Chivav or Queen Sister Well, which was built in 1050 AD. It's not only that the archaeology or study of the past helps only for the cultural affairs. It's a hard economics as well. See, most of the revenue which is earned through the archaeotourism, you can see, is from these 5 monuments: Taj Mahal, Agra Fort, Qutub Minar, Fatehpur Sikri, and Red Fort. Except the Qutub Minar, all others are hardly 300 to 400-year old. Okay. This is all Mughal period. Is India is that much young only that we have to project to the world only 300 to 400, 500-year-old monuments? No, we have much better than this. Our civilization is age-old, and I think we can enhance this understanding with the detailed survey. Some of the things will be taken in my lecture today. I agree with the Amitabh Kant, Chief Executive Officer of Niti Aayog, that our built heritage can be leveraged for economic gain through tourism dollars, as well as opportunities for the craftsmen and the local communities. Let us see the earning from these monuments. You can see the list. The Taj Mahal, Qutub Minar, Agra Fort, Humayun Tomb, Red Fort, Fatehpur Sikri, they are the topping the list. The next one is Mahabalipuram, Konark, Khajuraho, and Ellora. Where is the world's oldest dockyard discovered in this list? Where is the recently developed, declared by UNESCO, the World Heritage, the Dholavira? Okay, so we can actually enhance our cultural understanding by studying the past climatic changes and its effect on the coastal monuments. Some of them will be discussed today. Okay, the one which is since I come from the oceanography, I will not be touching the entire archaeology of the Indian region. I'll be only discussing today where the sea has shaped the destiny of ancient coastal towns. There are a couple of them, like Lothal, Dholavira, Gopikapatnam, Submerged Dwarka, Ram Setu, Pomphar, Mahabalipuram, and so on. So, study of all these coastal regions where sea has played a very dominant role comes under the marine archaeology. It's interesting to know how the marine archaeology started. It's a rather very young branch of marine sciences as well as the archaeology. The credit goes to late Dr. S.R. Rao, and he is a classical example what a person can do with his passion even after retirement. He was with the Archaeological Survey of India, and after retirement, he thought of studying the marine archaeology. Thanks to the then scientific leadership at the National Institute of Oceanography, Goa, who welcomed a retired scientist from another organization and encouraged him to start the marine archaeology with the help of people from other branches like marine biology, marine geology, marine chemistry, physical oceanography, survey, instrumentation, and so on. He started this studies with just 20,000 rupees grant from the INSA and the help from the National Institute of Oceanography. He started with Pomphar, but later he shifted his interest to the Submerged Dwarka, which became a very famous discovery. And therefore, a marine archaeology unit is started in first it was started in 81, and then it became a full-fledged recognized unit in 1991. The question is, while introducing, it was told that basically I am a geologist. I'm not an archaeologist. Then how I came into the marine archaeology, or what is my interest in it? See, archaeology may be subtly defined as the systematic study of the antiquities as a means to reconstruct the past. So reconstruct the past is one of the objectives of archaeology. And we, the geologists, the unique contribution of the marine sediments has been for deciphering the changes in oceanographic conditions due to climatic variation in the past. So when two branches of science, the marine science and the archaeology, they have a common objective to reconstruct the past, there has to be a coherence between the two, and they can help each other. This is the way our interaction started at NIO. First, let us see how we reconstruct the past. In fact, this reconstruction was not aimed initially for the marine archaeology. It was for reconstructing the past climate, and which is helpful to develop the futuristic models, as well as some of the models can be tested with the climatic variation in the past. So how to reconstruct the past climate based on the marine sediments, that is, let us see first. Then we'll discuss how it is useful in the field of marine archaeology. See, if this is the land and this is the sea receives the sediments two ways, either through river or through wind-blown sediments. Along with these sediments, there are a lot of marine organisms. Actually, these marine organisms are the source of today's talk. A lot of marine organisms live. These organisms, when they live and they build their shell in equilibrium with the ambient water conditions. And after their death, these microorganisms as well as the sediments both go and get deposited at the bottom of the sea, layer by layer, year by year. So they contained, actually, they served as a pages of Earth history. We can take our ship, we can take the core. And once this core is subsampled with the help of the climate indicator, we will be in position to tell how the climate has changed in the past, whether it is a monsoon rainfall, whether it is a tsunami records, where it is a sea level changes, and so on. So how to decode these layers? We decode them with the microorganisms I told you, which live into the water. They are called foraminifera. They are less, see, they are having certain properties which we have exploited for interpretations. They are less than a millimeter in size. They are exclusively marine organisms. They are excellent depth indicators. They are very, very sensitive to the environmental parameter and therefore have been extensively used. Even the ornamentation has been used commercially for designing the hotels, the ornaments, and the paths. There are about 10,000 species have been identified in the recent part of these organisms. About more than 2,000 species we have already identified from the Indian water. You can see how beautiful it is there, and you need a microscope to see them. You can't see them with naked eyes. You can see here. I just put up only 2 slides so that you can appreciate the beauty of these microorganisms. Because of its climatic sensitivity, they have a variety of applications. Like I was talking about paleoclimate. Sediment transport direction can be inferred, which is an engineering application. Application of this microfossils is age-old in petroleum exploration. They can also be used as the monsoon variation, how in 2,000 years monsoon has varied. Actually, this was the word on which I got my first award. They can also tell you idea about paleo fisheries and fisheries. Recently, one of my students got Young Scientist Award for application in the fisheries, particularly the Kerala mud bank studies. Their ornamentation has been used for the commercial purpose. In China, an entire park has been developed based on these microorganisms, which they carved into the granite. And the president of China inaugurated that park. These organisms are also helpful to generate the paleo-tsunami records, helpful in finding out how sea level has fluctuated in the last few thousand years. And based on the sea level changes, we have used them in the marine archaeology. And not only to reconstruct the past, even in the present environment, have been used very extensively in pollution monitoring. All other things some other day. Today, we'll talk only about 2 things: sea level changes and the marine archaeology. So when we say the sea level changes of the past, I think since morning we are talking about the sea level changes, but that is about, say, of very recent changes, say last 100, 200 years. But, but to know about archaeological application, we need to generate the record for last few thousand, particularly the Holocene period, in which the maximum development taken place in the mankind. The record of past sea level changes are available everywhere. They are available in religious records, something like what we call it the Manu or the Noah's Ark in religious records. As a geologist, we know that where the highest mountain, the Himalaya, stands today, millions of years before that was the Tethys Sea. There was a time in Cretaceous when large part of the Tamil Nadu was under the sea. Surat and Bharuch were under the sea. A part of the sea was reaching up to the Madhya Pradesh. But that story goes when man was not on this planet. So we are interested only to know about, say, last 10,000 to 12,000 years. These are the some of the records from different regions. When I'm talking about sea level changes, what I mean is a relative sea level changes. If there is any new tectonic effect, if land is going up and down in that particular region, that is also included. So see here, sometimes sea level was quite lower than today, and a couple of times the sea level was higher than today. Since it is a relative sea level changes, what has been done in other areas, other part of the world, in total cannot be applied to our region. We have to generate our own record. How to do that? And where are those records? They are in the form of marine science record, marine sediments. See, when sea level was higher than today, such records are available on land today. See, the sea erode the coastal rocks at its level. Okay? So you can see this is a notch. This is at the Donapola. Those who know NIO and Goa, they know this place very well. It means once upon a time, sea level was here, and presently the sea level is somewhere here. Similar is the sea cave. This cave was carved out by the sea when sea level was higher than today. So these are the evidences of the erosional feature of the sea once it was higher than today. The material which is eroded from these places has been deposited somewhere, mostly along the beaches. So you have to find out the ancient beach. You can see here along the roadside is the shelly layers. Now these shelly layers contain the microfossils, which indicate that sea level was higher, and because it is carbonate, you can date them. So this is the way to get the idea when sea level was higher than today. I'm putting it in a very simple way. See, along the sea level, at 60 to 80 meter water depth, we have noticed along the pinnacles and the fauna living at these places. If you date them, it comes around 10,000 years. But these are the fauna which is indicating a very shallow environment. How the shallow indicator fauna now presently we are getting at about 60 to 90 meter water depth. What could have happened? This is work of Dr. Praveen Hendricks, who is at the Bombay University Geology Department, head of department at Xavier College. And this is from Rajni Panchal's thesis from Myanmar region, similar type of phenomenon. So this is on the Indian side, this is Myanmar side. So simply we can through a conceptual model. If this is the, if sea level is here and this is a small pinnacle, a small hill type thing. And if sea level started going up, the indicator fauna, which, because I told you this foraminifera are good depth indicator, as well as the corals also they do like. So if sea level is going up, they try to migrate and as much as possible, and the time comes they cannot migrate. So if you date them, you can date here, you can date here. So this must be oldest, this must be youngest. So depth versus time, if we plot, then we'll get a sea level curve. That's what we have done. We have, whatever has been done, we summarized and produced a sea level curve, which was first time we published in 95, then in 2002, when we updated in 2012, and probably will update this curve once again. As more and more data is coming, we can refine. But overall nature is not changing. Now, this sea level curve, let us see what indicates. Friends, around 15,000 years before present, sea level was about 100 meters lower than today. Think of it. If you lower the present sea level by 100 meters, if you see the 100-meter contour, miles and miles will become the land. And after that, the sea level, when it started going up, around 30 to 40 meter water depth, around 9.5 thousand years before present. 7,000 years back, almost it has crossed the present sea level. The sea level was higher than the today, around 5 to 6,000 years, 4,000 years. And around 3,500 years back, it was slightly lower than today, then around 2,000 years, it's higher, and this is the present sea level. So now this sea level curve became very handy to explain later some of the phenomena of the marine archaeology. Okay. This sea level curve we prepared to generate record for our climatic interpretation and global warming program, but it have a much more. It has really done a wonder in the field of marine archaeology. How? Let us see. I told you that the S.R. Rao, who started the marine archaeology in India at NIO, when he was at Archaeological Survey of India way back in 1954, he excavated the Lothal. Friends, all of you must have heard the word Mohenjo-daro and Harappa. They were the classical sites of Indus Valley civilization, but unfortunately, after partition, both of them has gone to Pakistan. After that, there was efforts by Indian archaeologists to discover some of the sites within our territory. One of such, there are many such sites, but Lothal became a very sensational discovery in 1954. See, in Sindhi language, Mohenjo-daro means mound of dead. Whereas in Gujarati language, Lothal is also mound of dead. So when it was discovered, the entire sea came into the existence, which was about 4,500 years old. See here. This is the seal which has been recovered from the Lothal. Some of the structures like well, a wharf, a burial, a twin burial at Lothal. This twin burial also attracted a lot of attraction. Why these two people have been buried together, whether it's to do any ancient tradition. But the object which became very famous and became controversial is this, a dock or a tank-like body at Lothal. Now, see here, this is a tank-like body. And soon after it was excavated and made known, it became a controversy. One group of people were telling it was a dockyard. It's like this here. It's a picturesque view. And this is the dockyard. And this is the boat is here. The other group says, no, it's not a dockyard. It is a freshwater irrigation tank. And how they were arguing for about 30, 40 years. In 1954, this was discovered. And archaeologists kept arguing with, there are a number of conferences, papers, books on this well-known controversy in marine archaeology, dockyard versus irrigation tank. See, for example, this type of stones, you can see this picture of these stones have been found in this region here. And according to one group, these stones have been used as an anchor stone. You can see here in the modern world. This is a type of anchor that say. And since there was an anchor, it means the boat used to come in this area and this was the dockyard. There are many arguments. I have picked up the simplest one. The other group also used the same stone, but they say no. This stone has been used to lift the water for the irrigation, like this. Even still in our villages, water has been lifted for irrigation like this. And the archaeologists kept arguing. So first time when I visited and I came to know about this controversy, I thought, why this controversy is on for so many years? Probably because archaeologists are arguing with the archaeologists. Had they consulted any paleontologist or marine geologist, it could have been done easily. That's what I have done. I collected the samples at the sediments here and analyzed in our lab. It just took us in our lab over 2-3 days. Initially, when we found the foraminifera in the sediments, we thought there may be contamination because our labs extensively work on these microorganisms. So we used the new set of all that material which we use for processing, and again process, and again we got this organisms. Now, since I told you, foraminifera are exclusively marine organisms, and its presence finally ruled out its use as an irrigation tank. It must have been filled with the marine water or brackish water, and therefore the entire argument tilted in favor of a dockyard theory. This was a very major development in that field because this is 4,500 years old, and it is claimed by archaeologists this is the world's oldest dockyard ever discovered, and that too in our country. So we must be very proud of it. That world's oldest dockyard is within our territory, and this can become a very big attraction if it's been projected properly for tourists. Because what we are showing them only a few 100-year old, whereas we have something to show which is 4,500 year old. So once I say that this has tilted the argument in favor of dockyard, is still some other feature has to be explained. Have you seen any dockyard on land? This place is about few kilometers away from the present sea level and few meters above the present sea level. How it can be dockyard on land? It is possible only if sea level was high at that time, and this is the same sea level which I showed you. Around 4,500 years back, sea level was higher than today. So it was possible to have a dockyard that time, which was doing a roaring business and in the marine trade. It's the oldest dockyard. And once the sea level has gone down, this became out of use and it became an abandoned city. Since I told you it is quite far from the present sea, there's still some more question to be answered. This answer came from another remote sensing paper, which has showed how Lothal was connected with. This is the Sabarmati River, and these are the paleo channels through which the Lothal was connected to the sea. And this once again has supported our contention that Lothal was the world's oldest dockyard discovered in India. Recently, one more paper came. The sea level drop spurred the Lothal decline. I'm happy that what we have done in 1988, 1990, even now people are supporting that theory that this was a dockyard. And this is a paper just this month only. It is appearing in Journal of Geochemistry, Geophysics and Geosystem by Archana Das and others. This news item came on 8th May this year only. See, these places are now gaining, things are changing in our country. Now we are giving a lot of attention to our ancient monuments, which is much, much older and much more attractive than the few 1,000-year-old Mughal time monuments. And Honorable Finance Minister, Mrs. Nirmala Sitharaman, while giving a budget speech in 2021, she mentioned that that Indian government is going to give a lot of importance to the 3 places, the Rakhi Gadi, which is here near Delhi, and Dholavira, which is here in the run of Kutch, and the Lothal. And Indian government has also planned to establish National Maritime Museum at Lothal. So our application is still pending with UNESCO to declare Lothal as a World Heritage Site. So with this, I shift to the second city that is called the Dholavira. Dholavira is in the Khadar belt in the run of Kutch. This is a place where the city of Dholavira was discovered. It's a very about 5,000 to 6,000 year old city. See, this is Harappa, this is Mohenjo-daro, and here is the Dholavira. You can see here. Here is the Dholavira. Now, this is the at entrance. This is the board which was discovered. You can see a lot of archaeological remains at this city. This is our team, and this is behind is the Dholavira Museum. This is our team which has worked at Dholavira. See, Dholavira was already known to the world. First time it was noticed by Dr. J.P. Joshi in way back in 67, 68. Then Dr. R.S. Bish has done a monumental work. He has done the excavation of this site. It started from 89 to 90 and up, which went up to 2005. And final report was submitted, I think, in 2015. And then we have published a paper in 2016. Since recently, just few months back, this was declared as a World Cultural Heritage Site. So it got a lot of media coverage. See, this place is famous for its excellent water conservation system. This is one of the reservoirs at this city. So if it was already well-established site, what was left for us to study? First thing, the Dholavira was a port town. Okay, and port, right now the sea is quite far from this place. But 5,000 to 6,000 years back, when sea level was higher, this place was much lower than, much nearer to the sea. And the Saron was the landing point for this. See, this is the site plan of Dholavira. And it's very interesting. See, this is a citadel, the VIP area. This is a bailey, which you can say, which is the citadel is the most, you can say, VIP area. This is bureaucratic setup. Then the middle town and the lower town. And this citadel, you can see this wall, and all along this is a water conservation system. This place is, you can see between the two minor rivers, Manhar and Mansar. So this is a water-starved area. But this citadel wall you can see here, this is a 18-meter thick wall. 18-meter thick wall around the citadel, and I think 6 to 7 meter thick wall around the rest of the town. So the question comes, why this 18-meter thick wall? Nowhere we have seen this wall. If you see, so what were the possible reasons for constructing a wall? I was told by the archaeologist, this is perhaps because of the protection. It's a protection against whom? Against animal. For that, even a bamboo fencing is enough. But against the enemies. So when the gunpowder was discovered, after that the fort which was built, none of them are having this much thick wall. Even the China wall, this not that much thick. Kumbhalgarh wall, which is 15 feet, is also not that much thick. Then why they have made this 18-meter thick wall? And what was the ammunition of your enemy 5,000 to 6,000 years back without gunpowder? So it means it is not for the protection against animal. It is not because of protection against the enemies. Then what? Some people has given the idea because this wall is tilted and reinforced at some place. Professor Baldia, who was a very famous geologist and Padam Vibhushan, he gave an explanation probably because of earthquake. See, if earthquake hit the wall, it will destroy because it hits from the bottom. Sorry. Okay, so earthquake cannot be the reason. Unless this wall is tilted, something you hit horizontally. Okay, if you hit horizontally, then wall will be tilted. So the chances of tsunami is the maximum for this one. And this area is on Makaran coast, which is the tsunami prone area on the west coast of India. So, so we can, and we have published a paper in Geomarine Letters. We have said around 8,000 years back, we have already reported a tsunami in the Kutch region. So that the people who built the city of Dhalavira, they were aware that this is a tsunami prone area. But for the business purpose, it was very strategic location. Therefore, they have protected it by a very thick wall. It means this is a tsunami protection measures wall. Recently, Japan has built a dike, which is a 11-meter thick wall for the protecting against tsunami. So we must be, this is another point which is very important, that the ancient Indians were aware of tsunami protection measures around 5,000 to 6,000 years back. This is the world's oldest evidence about tsunami protection measures. So this we have reported, but still we wanted to test whether a tsunami has still hit that area. So we did some survey in the Middletown area somewhere here. We used that the instrument which is called the ground penetrating radar. This is the excellent use of this civil engineering instrument in the field of archaeology. Okay. It tells you what is buried into the sediment, below the sediment, you can say. So we use this ground penetrating radar. You can see this is our field team, which is doing the survey in this area. And this has given a very interesting records. Around 2.5 to 3 meter thick layer of sediments after the initial about 40-50 centimeter modern sediment layer. This thick layer have this thick sediment. There is no layering in between. So it means this is one-time deposit. And this is very unusual. See, because normally if you see the sediment deposited in natural environment, see here, this is about, see the river sediment. Year by year, when they deposit, they leave a layer like this. Okay, the sand dune types of sediment, they also have the layers. These are the marine sediment core. You can see the layering. So if sediments are depositing annually without any disturbance, they have the layered nature. But if you take a truckload of sediment and dump anywhere, they will not have any layer. So it means this, from where this such a thick layer has formed, from where the sediment came, which has made this layer. See, they can come either two ways. Either they came from the land through rivers in form of the flood, or they came from the sea in form of a tsunami. So let us check how to check that one. We got the permission from the Archaeological Survey of India to have a trench in this area. So we dug a trench in this area, and results were very interesting. See, first thing about the river flood. This first thing you must remember that this is a water-starved area. No major river. Two minor rivers are there. And since it is water-starved, Dhalavira became world famous for its excellent water conservation system. So if river brought these sediments here, they should contain only the river-bound sediment. But when we analyzed the sediment into our lab, we found the well-preserved foraminiferal population. I told you these are the exclusively marine sediment organisms. So it means this sediment has been brought by the tsunami into this area. It means the outer wall. So this has finally decided that this is the sea is the origin. Okay. So this area was still affected by the tsunami. Now the question remains, see, it means this outer wall could not protect it, this area for, so tsunami may be one of the reasons for decline of this region. And what is more required, whether the tsunami has crossed this 18-meter thick and about 4 to 5 meter height wall or not, for that a detailed survey is required into the castle area. This is something somebody has to do into the future. And this is having some relationship also with the sociology. See, normally always efforts taken to protect the VIP areas more. Here also ancient Dholavirian also did the same thing. They protected it by the 18-meter thick wall, but the remaining, the commoners have been left with the less protection. We have evidence that the tsunami has hit and this wall could not protect. So that may be the reason for decline. So unless the entire protection measures have been taken, by only safeguarding the VIP will not help. So the discriminatory practices are not new, it's age old. So friends, we can say that now that with the help of marine organisms and the instruments, we can say the sea level kept fluctuating, and at least it has shaped the two prominent cities, the name Lothal and Dholavira. Lothal is world famous for the oldest dockyard ever discovered, and the Dholavira is world famous now for its telling that the ancient Indians were aware of tsunami protection measures. The sea level curve also helps to explain some of the more findings as well, but it's not today. The one is the Neolithic of Surat. This here was the ancient city was discovered by the National Institute of Ocean Technology way back in 2000. And people were surprised how we can have an ancient city. Nobody knows the name of the city. But if you see the sea level, yes, sea level was between 30 to 40 meter water depth, around 9.5 thousand years, which was there. And India today brought out a special issue for this point. Ram Setu, around 7,000 years, which is the time given, sea level was slightly 2 to 3 meter lower than present. So India and Sri Lanka were almost connected with the little efforts. So that it can also tell that Ram Setu is not an imagination, but a reality. It is also having the Dholavira and Lothal. This is ancient Dwarka and Mahabalipuram. So this, with the help of our understanding of sea level fluctuation in the past, we can explain some of the mysteries of the marine archaeology. Friends, this is a small step to unravel the past in order to illuminate the future. Thank you for listening patiently.
Thank you very much, sir, for giving a wonderful talk on the history. And in fact, it gave a very clear the investigation strategy on unraveling many of the the scientific issues. So thank you very much, sir. I mean, shall we take some questions?
Sure, definitely. I will love to do that.
Any questions? We don't see any questions in the chat box also, sir. It was, I mean, there is no chance of questions because you explained it so beautifully that, everybody understood all those. Thank you very much, sir. I mean, we will now move on to the talk of the day. This is by Dr. Sanil Kumar, Chief Scientist of NIO Goa. He will be talking on surface waves in the ocean and its impact on the coast. Yeah. Dr. Mansi.
Dr. Sanil Kumar is the Chief Scientist at Ocean Engineering Department, CSI National Institute of Oceanography, Goa. His research area focuses on wind waves, coastal processes, marine structure, and lateral drift. Till today, he has published more than 185 research articles, and those research articles has got more than 3,000 citations. Till today, he has mentored around 29 students for their various dissertation and internship. Today, he's going to talk about surface waves in the ocean and its impact on the coast. Over to you, Dr. Sanil.
So good evening. So my slides are visible?
Yeah.
Okay. Greetings of the World Oceans Day. I thank Dr. Francis, Director, Center for Maritime Studies, Mumbai University, for inviting me for this talk. Thanks, Dr. Yanasilan and Dr. Mansi for the introduction. I welcome you all for this talk. So I'll be talking on surface space in the ocean and its impact on the coast. Dr. Unnikrishnan briefly mentioned about the waves in the ocean. So now waves are one of the main forces which affect the coastal and ocean structures and the coast. So my talk will cover wave characteristics. So the waves, what we see when you look from the beach to the ocean, so we can see that waves are approaching and coming towards you. So the wave characteristics, and during cyclone, what happens to the ocean? Then wave energy potential, then impact on marine facilities like coastal and offshore structures, then erosion, siltation of inlets. So when we see that waves in the ocean, so there will be having different wave periods like ripples. So when the wind is blowing over the ocean, so the waves are generated. So that starting the capillary action, so when small waves will be there like 0.1 second or something. Then when the wind action increases, so the wave period increases like 1 to 30 seconds it becomes. Then there are also waves generated due to other process like tsunami or tides, what Dr. Unnikrishnan mentioned. So I'll be talking only on this energy. We can see that this horizontal axis is the wave energy. So that high energy waves, that is the wind generated waves from 1 to 30 seconds. So this is a basic definition that what we talk is a wave height. That means a difference means a distance of the wave crest to the wave trough, and the wavelength and the wave period. So the waves are basically measured by different instruments. So we normally is using this spherical instruments like 90 centimeter diameter buoys. So which we will be keeping in the ocean. I like this arrangement. So it is moved with some bottom anchor, and so this type of instruments will be there in the ocean. So at present there are 15 instruments deployed by INCOIS, and some are with NIO, and they are continuously collecting and transmitting the data from the coastal area. Then there are instruments in the deep water, which is maintained by NIOT Chennai at 3000 meter water depth, 2500 to 3000 meter. So that also will be giving the deep water this wave conditions. So this instrument in the surface, it just goes up and down with the wave motion. So if you see that, so this horizontal line shows the sea surface, and that wave buoy instrument will be going just up and down like this with a different type of waves, because all waves are not with the same period. So we can see that wave period is different. And so usually we say sea state for 30 minutes, we will be collecting this data. So during that period, there will be one maximum wave height that we are calling as Hmax. And another term is the significant wave height. That is the average of the highest 1/3 waves during this 30 minutes. So the record will show this top graph shows the displacement. So that buoy goes up and down in centimeter, like this is during a monsoon time. So that waves can go up to, or a cyclone time. So it can go up to like a 4 to 5 meter. It goes up and down. So from that, then different people are interested in, like a designer, they will be interested in which frequency is predominant for that, like the response of the dynamic displacement or response of the structure to the ocean waves. So then we want to know what is the predominant frequency of the wave. So for that, we are doing the fast Fourier transform and getting the wave spectrum like down this one. That so then we get a spectrum like this, and then bottom graph. Then the left hand side shows the spectral energy density, and right side shows the wave direction. So that blue line is the wave direction. So that we can see that different frequency waves are approaching from different direction. So then from this is at one time step. The left side of this graph shows that during different time steps, like every half an hour we are collecting. So if you arrange them Then sometimes we are seeing that waves with frequency like 0.1. That means 1 by 0.1 means 10-second waves. So that we are calling as a swells. That means is and coming, and a locally generated wave will be like a 3-second or 4 seconds. So that is called sea breeze. So seeing the spectrum itself, we will come to know the waves are generated locally or it is coming from far off place. So then from the wave spectrum also we can estimate different wave characteristics, like what is the significant wave height or mean wave period, or what is the width of the spectrum. So all these parameters are used for different designers, design engineers for different purposes. So now when you look at the, if you are in the off Goa coast, so this one location. So this location is at, for example, if it is at 100-meter water depth. So then we can see that these are all open area, so that any wave generated in any of this place can travel and reach this area. The energy transmitted through the wave motion, and we get different waves from different direction. That means from south means it is from the even from the Southern Ocean, so which is around 10,000 kilometers south from this area, or even from the coast also. So even the coast, if it is 11 kilometers from the coast, one location is there are waves generated from the this coastal area. So that is like a land breeze time in the early morning. So we can see that the land breeze will be there, and by 11, 12 o'clock, so sea breeze starts. So then the wave changes its direction also. So if you see average all the wave data, if you collect every half an hour and average for 1 year, then the top graph shows that during that 1 year average in the North Indian Ocean. So the wave height is like up to 4, red color is 4 meter and blue will be 2 meter. So that average is like very close, of course, it will be 1 meter. Like off Goa, the annual average wave height will be around 1 meter. But it varies because we know that there are strong winds happens during the monsoon time. So the bottom graph shows that during the monsoon, the Somali jet, so strong wind comes like this, and this creates a lot of high waves. So the red color, so that average. So this is again for the seasonal average, 4 months average. So it comes up to 4 meter, and to the coast it will be like a 3 meter like this. Then before the monsoon, this top graph, and bottom is after the monsoon. So that this is for the long period, like 79 to 2012. So the waves in the ocean, so it is not same almost all the time. So it varies. A lot of variation will be there with the time. Now this left side graph shows that so entire Indian Ocean. So means we are taking Southern Ocean plus Indian Ocean. That means 70 degrees south onwards to the 20 degree north. So every month, like January, February, March, the 12 months. So if you see the average wind in this entire ocean, so we can see that like a 40 degrees south and all is strong wind belts are there. Whereas in our area, that like this around 10 degree north area, that wind is relatively calm, like only average monthly average will be around 2 to 3, and only during the monsoon month, that is June, July, August. So we can see that that red color is coming. So that is up to 8 to 10 meter per second wind will be there. That is a monthly average. Now this wind, so we know that waves are generated by winds. So then if you go and look at from the coastal areas, if you from Mumbai or Goa, so we can see that on a calm day when wind is not there also, we can see that the waves are approaching your coast. So this we can see that the waves generated even from the like 40 degrees south and all. So it travels. So this bottom graph shows that the propagation of wave from generated from the Southern Ocean traveling all the way. So it takes around 8 to 10 days, depends on the wave period. So if it is 12 seconds or 10 seconds, so that accordingly it takes and it reaches our coastal areas of Bay of Bengal or Arabian Sea. So this that we could identify that means a propagation time of the waves. So now if you look at Mumbai, like Warsaw or Ratnagiri or Vengurla and Karwar. So this is a distance around 500 kilometers. So if you see that like Karwar to Ratnagiri is around 300 kilometers, and then another 250 kilometers. So that if you see that if you measure the waves, like different locations, Versova, Ratnagiri, Bengal, and Karwar, there will be some changes because these are all in the west coast of India only. But we have seen that waves generated from the Southern Ocean travels this area, and we have experienced the wave. But again, there are disturbance, like local wind also will be there. So this diagram is showing this left side diagram is we call the wave rose diagram. So that wave approaching from different directions. So we can see that from 225, that is southwest direction. Then west is like 270, and then northwest like 350. So this at Versova, it is slightly less because that area is a little covered by the Gujarat coast. So there is a blockage. So whereas Ratnagiri area, we can see that northwest waves are large during February to May. This is for the top graph is for the February, May. And next one is during the monsoon, June to September, then October, January. And the last one is 1 year picture. That means all the half an hour data is arranged into this diagram. So then the bottom one, we can see that a swell coming from the Southern Ocean or South Indian Ocean, all these things. So they will be traveling and coming to a different area. And this intensity of northwest waves from north to south, it reduces. So we can see that Ratnagiri is more, slightly reduce, and Karwar it reduces. And in the monsoon, what happens is all these features goes, and because of that Somali jet, so we are getting the waves from the 270-degree predominantly. So westerly waves, or we can see most of the time all high waves, and color indicates the wave height. So pre-monsoon, it is all less than like a 2 meter, and then here it goes up to 5 meter and all. Then October, January, the condition is similar to the pre-monsoon, but that northwest waves are slightly less. That is not there. So that northwest waves are basically during the February, May. And this one, we could identify there are the three main systems. One is the northwest wind sea. Then that is due to like Arabian Peninsula. There are like strong winds called Shamal. So that is also creating the waves. Then there are low level jets. Then Makaran area. From that area also, there are some events happening. So during that period, so we get a waves from the northwest. Then the high waves is during the monsoon, and southwest swells are from the Southern Ocean and South Indian Ocean. So if you see for 1 year, means January to December 31st, this x-axis is this one. Then we can see the height, wave height. This location is of Ratnagiri, again Maharashtra coast. So then it is less than 2 meter up to May 15th or May 20th. Then when the monsoon, it goes up to 7 meter, 8 meter. That is we call the southwest monsoon. So then again, it reduces after the monsoon, except during if any cyclone happens, again this will change. Otherwise, this pattern repeats every year. And during that time wave period also, we are not getting, we are getting long period waves before the monsoon. And during the monsoon, you can see that it is all coming back to like 10 to 12 second wave, again back to the long period waves, that is 18 second, 20 second waves are there. Because these waves are very important, because this long period wave causes mooring. If you are designing some anchoring for the instrument or structures in the ocean, so then this long period waves creates a lot of oscillation and that mooring force, and that ships are moved, and also that will get snapped. So then this direction also we can see that there are directions. This top one is 300 to 330, that is northwest waves, and down one is the southwest one, whatever we saw, 220 to 240 degree. So this is the pre-monsoon, and again monsoon time, again this all gone, again 270 degree, that we saw that diagram, and again after that it repeats. But if you look at the wave spectrum, that wave height variation is less than 10%. If you look at Ratnagiri and 1 hour, the locations separated by 350 kilometers. So this in the west coast. So if you look at two locations separated by 350 kilometers, this black dark line shows the spectrum at 1 hour, and the blue one shows that is the Ratnagiri northern location. So we can see that January, February, March and all, So there are double peaks with the secondary peak higher in Ratnagiri. That means locally generated waves are more in Ratnagiri area, because we saw that the northwesterly that winds are creating this difference. But if you look at the wave height, so it will be around one average, annual average is 1 meter for Ratnagiri, and slightly less. It will be 90 centimeter for 1 hour. But there are significant changes in the wave spectrum happening, except in the monsoon. Monsoon, it is more or less same, single peak like June, July, August. So we are getting a similar type wave characteristics. Then we can also see the growth of waves, how waves are growing when the wind is blowing, coming. Like we know that there is in the coastal area, there are one process called sea breeze and land breeze. So in the like morning, the wind will be from the land to sea, and then by 11, 12 o'clock, so the sea breeze starts from the sea to the land. So then this also creates we can clearly see the wave spectrum generated, that waves generation from the wave spectrum. So if you do that whatever the EU data you collect from the buoy, so if you do the FFT, then you will get the wave spectrum. So this x-axis shows the frequency, 0 to 0.45 hertz. And this is with the day in February. That is, we are seeing this type of thing process in the pre-monsoon period. So then we can see that one strong red color is the intensity. So the strong red color is coming from like less than 0.1. So this is always, almost all the time present. So this is the swells actually. So that is 10 second, 0.1 is 10 second, 0.05 is 20 seconds. So it is in between 10 and 20 second waves, which are generating far off place and coming to this area. And then we can see that some are things coming at 0.3, 0.35, 0.4, 0.45. So this one, we can see that the first waves, this middle graph shows the this wind, U wind, that is crosswind. So the crosswind, when it is changes direction, -2 to +2, so that it is when that wind is increasing from the seaside, that plus means it is towards from the ocean to the land. So then we can see the red patches generates at low frequency, and it increases and it shifts from energy, means it shifts the energy from low frequency, high frequency to low frequency. So that all the process, we can very clearly see that how the waves are generated. Then during cyclone, what happens is, so then already that cyclone time, the waves will be much higher than this monsoon wave also. So like some cyclones cause like Vayu cyclone. So that was in coincidence with the monsoon onset. This happened in 2019. So there were 4 cyclones in the Arabian Sea, and this was collected at one location. And so then we can see that Kyar cyclone. So this is at Vengurla. So we have measured at Vengurla and Karwar, so nearby areas. So then we can see that wave height from the even October. So otherwise earlier we saw that in October the wave height is less than 2 meter. So here when cyclone comes, it goes up to 7 to 8 meter. So the structure or operation, whatever marine operation we are doing, so it has to survive during such period. Then the wave spectrum also we see that. So we can see that monsoon intensity is less than, whereas cyclone, the intensity will be much higher than the monsoon. Then really we have measured waves up to like 13 meters. So 13 meter means it is like a 4-story building. So this is measured at 50 meter water depth in the east coast of Gopalpur. That is during the Highland cyclone. So that is in 12th October 2013. So this time that wave was like 13.1 meter, 13.5 meter and all. So such waves also will happen in the ocean. So the whatever structure or it has to withstand this condition. Then we can see that the number of cyclones. So if you look at the number of cyclones that atlas, this IMD atlas from 1979 to 2019 period. So we can see the Bay of Bengal has an total number of cyclones. When you see that Bay of Bengal has more cyclone than Arabian Sea. And these cyclones, what happens is like we put like a coastal structures like jetty and all. So this wave during the cyclone will be, it will just come and splash, or it will create uplift force for the deck structure. So then even offshore platforms. So it should not come and hit the bottom. So one of the design criteria is like air gap, that is from the sea to the bottom of the platform or bottom of the structure should be kept in such a way that it should take care of what is the chart datum, that is a datum at that area, what is the expected maximum tide level. Then storm surge, water level also increases when the wind increases in the atmosphere. Then the crest height of the wave, because it is not 50% up and 50% down, because wave, generally if you see a wave, linear wave, so it will be 50% up and 50% down. But in ocean, so crest height, it will go up to 0.63 high. So it is like this was measured for 10.75 meter. So crest height was 6.81 meter, whereas drop is only less than 4 meter. So this we have to keep in mind while keeping the air gap. Then last year, May, we had a cyclone in the Arabian Sea. So during that time, you all know that that ONGC vessel barge was broken free of its anchor, and there was some platform, because again mooring line broke. So the vessels, these barges will be moved to the location, and they were doing the work. So cyclone came. So this top graph shows the distance of the cyclone from the buoy. So when it reaches almost close to the buoy, the wind speed increases. Then wave height also, it went up to 10 meter. Then a significant wave height up to like a 6 meter. So all this causes, because everything, wave period changes, all the parameter changes. Then this causes the mooring line to broken from that area, and so it went and hit the platform and sank off Mumbai coast, and 75% are missing. That means some of them are dead or missing from that area. So then we can see that if you analyze the one record, so one wave may be of 10 meter, the next wave may be of 8 meter. So like that, a series of waves comes and hit that vessel. So it causes that repetitive loading on the vessel, and that mooring line broke. So while designing, so then we had to have some theoretical spectra. So that also we can derive from this data, whatever measured data. So then we can also pick some, find out some empirical equation, and then we can see that how the wave spectrum. So the black line shows the spectra from the time series, and the blue line shows the theoretical spectra. So different month, but this is required for a designer for response spectra of the offshore structures. Then we can measure waves for some period. So then, but the person who is interested in planning these operations in the offshore, so a structure has to be stand for like 50 or 100 years. So then that wave height, which cannot, which may not cause what is it, increase during that 50 years, we have to estimate. So there are some different theoretical distributions like probability distribution, generalized extreme value distribution, or generalized Pareto distribution. So then we have to also check all the different methods, because different methods may give different values. So we have to check for that before giving a design wave height, what has to be used. So then when you compare that, it should match like almost similar value we should get. Again, if you use different data period, like you will get different values. So minimum 30 years data has to be considered while coming to the design parameter. So here we can see the bottom graph, maximum wave height in entire Indian Ocean. Then what is the trend in wave height, so that how whether wave heights are increasing in some area, they are decreasing in some location, and what is the 1 in 100-year wave height. So we can see the similar values. Southern area we are getting the very high waves, and when our area, so we are getting similar value like maximum wave height, whatever is happening. So same trend we are getting for the design wave height also. Then some cyclones completely changes the design wave height. So if you are taken for area of Gopalpur, like 1979 to some period before these two cyclones happened continuously, like 2013 and 2014, Bailin and Hudhud. So if these two cyclones were not considered, then there is a large difference in the like 50-year wave height itself. One up to 2012 data if you taken, we will get only 5.12 meter. Whereas if you consider up to these two cyclone data, then it is coming 8.67 meter. So 100-year return value means a lot of 30% changes there. So the data set has to be selected very carefully. It means we have to take all the cyclone data, whatever has happened in that area, and when you take the 30 years or the data for coming at 1 in 50 year wave height. Then when you know that what is the maximum wave height occurred in our coast. So if you take different locations, so we have checked at 19 locations from Gujarat to West Bengal. So then that is from Gujarat location is 1, and then 19 is at West Bengal. Then we can see that wave height varies from like 8 meter to almost like 20 meter at different locations. So that is a maximum value in that area. Then this shows that why that wave height has happened. So it is due to sometimes storm, the Arabian Sea storm, different one, and especially in the west coast, that basically during the storm data only, and except this area like of Kerala coast and all, where Lakshadweep that blockage is there. So that is monsoon area only, monsoon wave height, and that area we can see that southern, when you come to the Kerala coast up to from 8, 9 to 11, the wave heights are slightly less, and this side is again 12 is covered area because Sri Lankan influence, so that area is also less height. Again, all other east coast area, it is during different cyclones like Thane cyclone, Pondicherry, Varada cyclone. So all different cyclones has caused different wave height, very large wave heights. So this information also we have to, that means we have to check the data set very carefully before giving the design value. Then so this waves have a lot of energy. So then same location, 19 locations. If you see the annual average wave energy, so whether we can use this for wave power or wave energy extraction, wave energy converter we can put. But when you see that some of the area in the west coast, there are large seasonal variation. So annual average value is very less only. This black line is the mean value, but there are very large seasonal variation. So we see that during that 4 months we get a very high value and it is less. Whereas when you look at the location of southern, like location 11 of Kanyakumari, where that 11 we get around like 9 kilowatt per meter or watt hour value, and that seasonal variation also is less. So such locations are good for wave energy converter placing. Then if you see the year-to-year variation, so there are variations up to 13% in wave power. Then which location we have to plan, because offshore, the power available in the offshore location is different. So when you come to the coastal area, the power will be different. So it reduces. So then this left graph shows that distance from the coast. So if you go 10 kilometer, 20 kilometer, 30 kilometer, 40 like that from the coast, then how the wave power increases, means from the coast to the offshore, and what is the water depth at location, because water depth also plays a major role, because we cannot place wave energy converters at a far off place, like there is no point in putting it 100 kilometer away, because again we have to lay power cable to bring the power from that area to the coast. So we should try to get locations close to the coast is advantageous. So then like that we have to select which location so that power variation is less. So like that we can identify from different locations. Then other one, what is happening in the coastal areas. So when you see that during the June or July month, when you go to the beach, so the beach earlier beach was 100 meters. So when you go in the July month, we'll see only 20 meter or 30 meter beaches. Remaining beaches already lost. So if it is an undeveloped area, so it is a natural and cyclic process. Every year that beach berm, that area, it erodes and put it in the near shore area. And after the monsoon, when long period waves are there, so they bring the material back and they rebuild the beach. So this happens every year. It is a cyclic process. So, but if we do some development in that area and some storm or something has happened, then that something extra erosion happens in that area, like a monsoon time, some storm has come. So that extra material might have taken into deep and that material will not come back. So then it becomes a coastal erosion. That is why CR notification is restricting developments in the coastal area, means from the high tide line. So some distances for different type of coast. So we are leaving 50 meter or 100 meter or 200 meter. This notification is restricting that no developments in this area because it is a very risky area. So if you construct road, is the bottom one, very close to coast and all, so then that erosion will be happening every year. So then this graph shows that, like, if you collect data for some continuously every month beach profile, so this one we can quantify from the beach profile data. So different month, if you go and collect the beach profile, so earlier 120 meter will be there, and monsoon it may go up to 50 meter. So that this is the distance from the dune to the water line. So then we can see that this line, that one was a lot of beach was lost during that year, and slowly it has rebuilt. So why this has happened? So then we can see that this top graph shows the wave height. So that wave height is, this is at 9 meter water, wave height measured. So up to 4 meter, it happens in the monsoon, and in 1 year, 2009, so wave height was slightly increased. Earlier it was 3.7, but that year it has happened up to 4.3 meter. And this more than 3.5 meter persisted for 33 hours. So it is not only the wave height increases, the time, same wave height is continuously hitting the coast. So then that large erosion. So we can see that this is a beach volume. So that every year erosion is there, but that year, lot of erosion has happened, that we can see from this beach profile. So then planning the port, like this in the east coast of India, Ennore port. So then we can see that ports require calm area. So for that they are building the breakwaters. So when you put any structure into the coast, into the sea from the coast, so then you are obstructing that there is a movement of littoral drift along the coast. That is sediment movement is there. So then the sediment will accumulate. So this shows that sediment is gradually accumulating. So this is like the different years. Right side we can see that, and whatever accumulating south, and then north we will be losing the sediment. So another issue is the siltation of inlet. So most of the small river inlets get silted up because most of the small traditional boats and all will use this inlet. So this is also happening due to the sediment movement. So this again wave pattern changes. So then the siltation also pattern also changes. This in different, like, sorry. So then finally, so we can see that impact of waves like beach erosion, we saw damage to the structures, damage to moorings, cliff erosion. So if a strong wave happens, so then we can see even the cliff gets eroded. Siltation of river inlets, siltation of navigation channel. Then there will be also flooding, because when erosion happens, that water level will enter the low lying area. Then there are also the coastal accretion. So this. So thanks for your kind attention.
Sanal Kumar, any question? Any questions to Dr. Kumar? No questions in the chat box also.
No question.
I have questions. In 2009, you showed more erosion.
Yes.
But 2009, the monsoon was very weak. So what was the reason?
That's it. Only the thing is that wave height persisted for longer period.
Okay.
Even though height is less, but that wave height was a similar wave height was persisted for longer duration. 33 hours we are continuous. That wave activity was there.
Okay. Okay. So what are the measures they normally take for beach erosion?
Beach erosion, there are different type of protection measures. So one is like putting some structures in the underwater, like a reef. Recently, means they make that some reefs are built in the 5 meter or 6 meters. So that what happens is wave when it is coming, we break the wave at that area and reduce the intensity on the coast. So that we are not doing. Earlier, what we are doing is we will dump stones all along the coast. If you see that Kerala coast, like 80% of the Kerala coast is like a seawall. Means the granite stones are just dumped. This one,
but that spoils
this one. Plus, fishermen also cannot use them. So nowadays that is not recommended. So we have this type of things like groin, means some structure in the ocean, or groin, perpendicular structures from the coast to the sea. That type of structures are planted.
Okay. Thank you, Dr. Sanil Kumar. Dr. Unnikrishnan is there. There was a question for you. If you are, there was a question from Sriraj. What is the minimum span of sea level data required to explain a robust sea level rise trend considering the decadal to multi-decadal variabilities? I think Dr. Unnikrishnan is available. Yeah, okay, you are there. Okay.
You can repeat the question.
So what is the minimum span of sea level data required to explain robust sea level rise trend, considering the decadal to multi-decadal variabilities?
Okay. Yeah, generally recommended is about 40 years of data. 40 to 50 years are there. That is practical experience shows it does a good job.
He may be referring to regional sea level variabilities in the decadal and multi-decadal time scale.
Yeah.
Like a PDO response or a AMO response.
Yeah. But multi-decadal, of course, it is slightly difficult. But yeah, but other things, normally practical experience is 40 to 50 years.
Correct. Okay. Yeah, it's a good question anyway, because the Mumbai record, if you see, there is a increase in around 1960.
Yes.
And again, there's a fall in mid 90s.
Yeah.
That must have really attributed to the trend what we are calculating.
Right.
Okay.
No,
Thank
but
you. Yeah. Dr. Unnikrishnan, you were saying something.
No. I nothing more.
Yeah. Okay. Thank you. So first of all, I thank all the speakers for wonderful talks, giving a lot of information to the audience, as well as completing the talk well in time. So that is a rare thing, which I thank all the speakers. And to summarize, we had a very nice sessions. I'm sure everybody has learned a lot from the 4 talks. Though there are only 4 talks, we learned a lot. So Dr. Unnikrishnan started with the fundamentals of sea level, the observations, different strategies, then the trends, then the projected trends, the uncertainties in the trends, and many the global trends and regional trends. So I think a lot of things he talked about. And then Dr. Kunal talked about the marine biogeochemical carbon cycle and its dynamics, and he covered many aspects and highlighted the ocean's role in mitigating the global climate change and the need of more PCO2 observations over inventory. So that's a very important thing. And what are the new observation platforms in the Indian Ocean, and that's our role, mainly the role of MOES on the marine pollution control. And then Dr. Rajiv Nikam, he has really taken us to the history. By highlighting the importance of our monuments, which were not projected as much as some of the recent monuments are projected. And he has also highlighted the possible source of income which we could have generated through highlighting our monuments. And then he talked about the paleo decompressions and the paleo sea level, paleo tsunami, and he has posed very nice scientific problems and solved them, and showed us the method how to unravel the scientific mysteries like a investigation officer. So very nice. And then finally we had a talk on the ocean waves, the short waves and its impact on the coast, which is very, very important. So I thank Professor Francis and the team for inviting me and making me a part of this. So and also I thank all the audience, because I can see a lot of participants even now. So thank you all, and I thank my co-person, Dr. Manshi. Thank you all.
Thank you, Dr. Nyanashilan, for chairing the session very successfully and on time. Even though we started a bit delayed, none of the talks overshoot. Also, we had a very successful symposium today. We started today morning with Dr. Chenoy's talk with a very insightful lecture on the sea level change, climate change impacts on the society. And then we had a very useful talk from Dr. Meena Kumari and other speakers on the fisheries and oceanography, Dr. Oja, Dr. Thakur, and Dr. Grinson George. So I should thank all of you for giving this wonderful talks. In fact, it was a very informative talk for me also. Most of these things were not known to me also. So I take this opportunity to thank all of you, the chairs and the speakers, and also the audience. Also, I thank my colleagues Mansi, Mrunmoy, Vivek, and Dr. Varsha for helping me to organize this session. And thanks a lot for Honorable Vice Chancellor and Pro Vice Chancellor for their support. Thank you all, and we will have some other occasion. We will have one more such meeting.
I have a suggestion. Can I make a suggestion?
Sure, Dr.
Today's talks are really, so exciting that there should be a follow-up panel discussion on the topic, because the topic is very relevant to public, the common man, collective action for the oceans. So I think it deserves a panel discussion.
Yes, Dr. Sheila. In fact, we are actually planning for a brainstorming session, because this is important for us to get the future directions of the center also. So we are planning to have a brainstorming session. So we will take these notes of this today's symposium. We will invite all the speakers and chairs for this brainstorming session, and then we can have a lot of discussions which will help us to steer our center and the oceanography as such. As Dr. Chenoy was mentioning, in fact, University of Mumbai can say that this is India's contribution to the decade. We started the center, and also we are having these events. So I'm sure that we have a lot of interest in sustaining the activity. So I will definitely bug you again for this brainstorming session. Yeah, thanks a lot. And with this, let us conclude the event. Thank you very much.
Thank you.
Okay, let's move ahead now.